Hi, my name is Balázs Holzer from Budapest, Hungary, and welcome to my course on Java programming step by step from A to Z. So first of all, let me tell a few words about myself. I'm from Budapest, Hungary, as I said earlier. I'm qualified as a physicist, and later on I decided to get a master's degree in applied mathematics. Currently, I'm working as a software engineer, and I have a special addiction to algorithms, data structures, and quantitative finance. Okay, so let me tell a few words about the course itself. I've been making tutorial videos for years, and my basic Java course called First Steps in Java is available for free for a long time now. Fortunately, I have received a lot of positive feedbacks from my students, and this is why I have created this advanced Java programming course. What's crucial that I highly recommend starting with the free First Steps in Java course in order to learn about the fundamentals of Java programming, and this advanced Java programming course is the next step. Okay, so the First Steps in Java is about the fundamental basics of Java programming, but if we want to understand better Java programming, we have to go deeper and we have to expand our knowledge. And this is the purpose of this course, so this advanced Java programming step by step from A to Z. Okay, so let me tell a few words about the content of the course. We are going to talk about operators, we are going to talk about wrapper classes, garbage collection, stack memory and heap memory. We are going to talk about strings such as the string builder and string buffer. We are going to talk about enums and dates and times, arrays, array lists, collections and generics, then object-oriented programming such as abstraction, encapsulation and polymorphism, and the new features of Java such as optional, streams, Lambda expressions and so on. So these are the topics we are going to consider on a step-by-step basis. Thanks for joining my course. Let's get started. In this chapter, we are going to talk about operators in the main. So first of all, what are operators? Java provides operators to manipulate variables. Operators are special symbols that perform specific operations on one, two, or more operands and then return a result. There are several operators such as arithmetic operators, relational operators, assignment operators, bitwise operators, logical operators, conditional operators, and time comparison operators. The first three operators are basic operators. Then we have the bitwise operators. Bitwise operator works on bits and performs the bit-by-bit operation. And this is what we are going to talk about in the coming lectures. So logical operators, conditional operators, and time comparison operators are the most commonly used operators in the Java programming language. Okay, so let's talk a bit about arithmetic and relational operators. Arithmetic operators includes addition, subtraction, multiplication, division, the modulo operator, incrementing and decrementing the given variable value. As far as relational operators are concerned, we have the equals to, we have the not equals to, greater, less than or equal to, less than or equal to operations. Okay, I guess these are quite straightforward. If you want to add integers, you have to use addition operation. If you want to calculate the modulus, you have to use this percent sign. If you want to compare two values, whether the first one is smaller or greater, you have to use relational operations. Okay, so what about assignment operators? We have the equal sign. This is how we can assign a given value to a given variable. So in this case, we assign the value 22 to the variable I. We have the plus equals, which is going to increment the value of I by a given value. In this case, we increment I by 33, so it is the same as I equals to I plus 33. The minus equals operator is equals to subtracting the given value from a given variable. Okay, we have the multiplication equals to, it is the same. I multiplication equals to 55 means I is equals to I times 55. So this is how we can use these kinds of assignment operators. Let's talk about bitwise operators. The Java programming language also provides operators that perform bitwise and bit shift operations. These operators are less commonly used unless you are dealing with cryptography. Most of the cryptography related approaches, such as the data encryption standard or the advanced encryption standard, rely heavily on the bitwise operators. But if you want to become a software engineer, there's a high probability that you are not going to meet with these bitwise operators. Anyways, the AND% operator is the bitwise AND operation. This operator is the so-called exclusive OR or XOR logical operation. This operator performs a bitwise inclusive OR operation, and the last operator can flip the bits of the given sequence. So this is how we can use these operators as far as bitwise operations are concerned. Okay, let's talk about logical operators. Logical operators are quite common. So what are logical operators? A logical operator, sometimes called a Boolean operator, returns a Boolean result that's based on the Boolean result of one or more expressions. We can use the double % sign, as you can see, which is the logical AND relation. If both the operands are non-zero, then the condition becomes true. This is the logical OR operation. We are going to talk a lot more about it in the coming lectures. If any of the two operands are non-zero, so true basically, then the condition becomes true. We have the exclamation mark, which is the logical NOT, that's going to reverse the logical state of the operand. And we have this operator, which is the exclusive OR, so the XOR operation. The condition becomes true if any of the operands are true, but not both of them. Okay, so we are going to talk a lot more about logical operators. We have conditional operators. A conditional operator is also known as ternary operator. So the Java ternary operator functions like a simplified Java if statement. The ternary operator consists of a condition that evaluates to either true or false, plus a value that is returned if the condition is true and another value that is returned if the condition is false. So this is the formula we have to consider. The result is equals to a given test condition, question mark, value 1 and then value 2, which means that if the condition is true, then the result is going to be the value 1, otherwise the result is going to be value 2. So this is why the test condition is going to be a condition, and based on this condition, the result is either the value 1 or value 2. We are going to take a look at concrete examples and it's going to be clear. Okay, and finally we have time comparison operator. The time comparison operator is also known as the instance of operator. The instance of operator is used to test whether the object is the instance of the specified type, such as class, subclass, or an interface. So we can use this is instance of operator as a type comparison operation. Okay, so the instance of operator syntax is we have to check whether the object reference is an instance of a given type, and the return value can be true or false, so we can use this instance of operator in order to test whether the object is an instance of a given type, whether it is a class, a subclass, or an interface. So this is what we are going to talk about in the coming lectures on a one-by-one basis. Thanks for watching. In this lecture, we are going to talk about logical operators. So logical operators, as we have discussed in the theoretical section, are the AND logical relationship. So this is the AND logical relationship. We have the OR logical relationship. We have the exclamation mark where we can negate a given logical statement. And finally, we have the XOR logical relationship. So first of all, let's define two variables. Integer a is equals to 10 and integer b is equals to 20. So we can check with the help of an if statement that if the a variable is greater than 5 and the b variable is smaller than 100, then we are going to print out, just for demonstration purposes, that it is true, and otherwise we print out that it is false. So if we save the application and run it Of course, we get true as the result because a is greater than 5, the value of a is equals to 10, 10 is greater than 5, and the b value, which is 20, 20 is smaller than 100. So because both of these statements are true, that's why the AND logical relationship is going to be true. By the way, you can search for the AND logical table. So as you can see, true and true is equals to true, true and false is equals to false, false and true is equals to false, and false is equals to false. So what does it mean? That if we want to print out true, then we have to make sure that both of the statements are true. If one of the statements is not true, for example, b is equals to 200, because b is not smaller than 100, that's why this logical value is false, this logical value is true, but true and false is equals to false. So if we save and run it, we get false. So whenever we are dealing with the AND logical operator, we have to make sure that both of these statements are true. Of course, we can use as many AND operator as we want. So for example, we can say that AND a plus b is smaller than 1,000. So let's see if, for example, b is equals to 20 again, this logical relationship is true, this logical relationship is true as well, and this logical relationship is true as well. So the final result is going to be true. But if one of the statements, so one of the logical statement is not true, so it is false, then the result is going to be false. So for example, if a plus b is smaller than 0, of course, it's not going to be true, so that's why the final result will be false. Okay, so that's all about the AND logical operator. Let's take a look at the OR logical operator. So the OR logical operator is something like this. We can search for the OR logical table. Okay, sorry for that, a typo. So this is the OR logical table. As you can see, if both of the statements are true, then the result is true. True false is equals to true, false true is equals to true, and false false is equals to false. So for example, we say that if a is greater than 5, it is true, b is smaller than 100, so that's why the result is going to be true as well. But if we say that, for example, the b value is 200, it's going to be true because one of the statement is true. Okay, it is false, but it is true. True or false is equals to true. If we want to make sure that the result is going to be a false, we have to make sure that both of these statements are false. So for example, a is greater than, for example, 50, it's not going to be true, so it is a false statement, and it is a false statement as well, so the result is going to be false. So that's all about the OR logical operator. By the way, we can use as many OR logical operator as we want. A minus b is smaller than minus 10. If we save it and run it, it's going to be true because it is false, but this statement is true. A minus b is 10 minus 200, which is minus 190. It is smaller than minus 10. So because one of the statements is true, that's why the final result will be true. Then we can use the negation, which is the exclamation mark. So we can say that if a is not equals to 10, then we print out true, otherwise we print out false. Because a is equals to 10, that's why the result is going to be false. But if we say that a is not equals to 20, then of course the result is going to be true. So this is how we check whether a given variable is not 20 or not the given value we specify here. Of course, we can mix the given logical operators. So we can use that a is greater than 5, and we would like to make sure that a is not equals to 20, or for example, a is not equals to 10. So this is the case when we want to make sure that a is greater than 5, but the a value is not 20, or the a value is not 10. So if we run it, it's going to be true because a is greater than 5. Okay, so this is how we can combine logical operators, and it can prove to be very, very important. So usually as a software engineer or a programmer, you are going to meet with these logical operators on a daily basis. Thanks for watching. In this lecture, we are going to talk about the so-called ternary operator. So this is what we have been talking about in a theoretical section, that the ternary operator syntax is something like this. If the test condition is true, then the result is going to be the value 1. Otherwise, so if the test condition is false, then the result is going to be the value 2. So for example, if we define two variables, integer a with value 10 and integer b with value 20, we can say that the smaller value is going to be the a smaller than b. This is the test condition. So we test whether a is smaller than b or not. If it is true, then a is going to be the result, otherwise b is going to be the result. So if we print out the smaller value, okay, something like this, we save it and we run it, then the smaller value is going to be the solution. Okay, of course, if a is 100, then b is going to be the result. So with the help of this ternary operator, we can check a given condition, a smaller than b, and if it is true, then this value is going to be stored in the smaller value variable. Otherwise, the b value is going to be stored here. So this is what we are going to print out. So this is how we can use a ternary operator. Of course, we can use ternary operator with any types. So for example, if I have a string name is equals to Adam, then we can check whether if the name is equals to Adam, then the result is going to be the name is Adam. Otherwise, the result is going to be the name is not Adam. And of course, we have to use a string. It's going to be the result. So something like this, and here we print out the value of the result. So again, we can use ternary operator on strings as well. This is the test condition. We test whether the name is equals to Adam or not, which means that it is going to yield a Boolean value. If it is true, then this is going to be the result. Otherwise, this is going to be the result. So if we save and run it, the name is Adam. If the name is Joe, then the result is going to be the name is not Adam. Okay, by the way, we can use several ternary operators in the same line. So for example, we have the a variable with value 100. We can print out to the console that if the a value is equals to 0, then we print out 0. Otherwise, we use another ternary operator. So just to make sure it is valid, we use something like this. So otherwise, we check whether the a value is smaller than 0. If it is true, then we print out negative number, and otherwise we print out positive number. So it is going to work fine. Let's run it. It is a positive number. If we use with minus 100, it's going to be a negative number. And if we use 0 as the value of the a variable, it's going to be 0. Of course, it is working fine, so this example is appropriate, but keep in mind that we do not use too long and too complex chained ternary statements, because code readability is more important. So as a programmer or software engineer, do not use something like this. It is working fine. We are able to chain ternary operators, but it is not a good programming practice because it is not straightforward what's happening under the hood. So this is how we use ternary operators. Thanks for watching. In this lecture, we are going to talk about the so-called type comparison operator. This is what we have been talking about, that the type comparison operator is also known as the instance of operator, and it is used to test whether the given object is an instance of a given type or not. So for example, if we have a class, for example, cat. We have a class dog. We have another class, for example, animal, and the cat is going to extend the animal class. Okay, then we can check in the main method that first of all we instantiate a new cat, then we instantiate a new dog. Then now we can check that whether the cat is an instance of the animal class or not. So because the cat, sorry for that typo, of course the cat is an instance of an animal class. If it is true, then cat is an animal. If we save it and run it, cat is an animal, it is true because the cat class extends the animal class as well. So a cat is an animal basically, and this is why we can check whether the cat is an instance of an animal. If we would like to do the same with dog, then we get a compile time error, which means that we are not able to run the application. As you can see, because the dog is not an animal, so the dog class doesn't extend the animal class. This is why it's going to be an incompatible conditional operand types dog and animal. Of course, we can do the same with interfaces. So if we have a interface, for example, mammals, then the cat is going to implement the mammals interface. Okay, maybe it's not the best solution to use mammals. It should be something like just a mammal. Okay, let's finish it. And because a cat implements the mammal interface, we can use again the instance of operator. So cat is the instance of the mammal, whether it is true or not. As you can see, it is true. So we can say that cat is a mammal. So if we save and run it, of course, it's going to run without any issue. So this is how we can use the instance of operator in order to check whether a given class implements or extends a given class or an interface. Thanks for watching. In this lecture, we are going to talk about wrapper classes. So first of all, the primitive data types are not objects. They do not belong to any class. They are defined in the language itself. So Java provides wrapper classes for each of the primitive data types and the mechanisms to convert primitives into objects and vice versa. Okay, so you may pose the question that why do we need objects? So the answer is that objects are needed if we wish to modify the arguments passed into a method, because primitive types are passed by value. So this is why sometimes it is useful to convert primitive data types to objects and objects to primitive types. So first of all, let's consider the 8 wrapper classes. There are 8 primitive data types such as the byte, short, int, long, float, double, char, and boolean. And every single primitive data type has a wrapper class accordingly. And these classes are objects, as you can see. So we have byte, short, integer, long, float, double, character, and boolean as well as a wrapper class. So these wrapper classes are subclasses of the abstract class number. So byte, short, integer, long, float, and double are numbers. So if we take a look at the wrapper class hierarchy, we can make sure that object is the parent. Then we have character and boolean that are objects. We have a number that's an object as well, and byte, short, integer, long, float, and double are numbers. So this is the wrapper class hierarchy. Okay, let's talk about autoboxing and unboxing. Autoboxing and unboxing feature converts primitives into objects and objects into primitives automatically. So basically, with the help of autoboxing and unboxing, we are able to convert primitive data types to wrapper classes and vice versa. Okay, so as you can see, unboxing and autoboxing is the mechanism where we convert primitive data types to objects and vice versa. Okay, let's take a look at a concrete example. If we use something like this, that integer int object is equals to 55, it is a simple example of autoboxing, because in the background something like this is going to happen. Java is going to use integer.value of 55 in order to create a wrapper class, because integer with capital I is an object and not a primitive type. Of course, we can use unboxing, so unbox the object into a primitive type, as you can see, with a single reference. So if we use something like this, we are going to use unboxing, which means that we are going to convert the object, so the wrapper class, into primitive type. This is what we are going to talk about in the coming lectures, by the way, so it's going to be clear how to use autoboxing and unboxing. One of the objectives of the wrapper class is to define several utility methods, so we can use several useful methods that otherwise we couldn't use with primitives. So if we check the Java documentation, for example, the integer class, as you can see, it is an object and it is a number as well. This is what we have been talking about in the wrapper class hierarchy. As you can see, there are several methods. These are the methods we can use with the wrapper class. We are not able to use these methods with primitives, so this is why it is one of the most significant features of wrapper classes or objects, that we can use these methods. Bit count, for example, that returns the number of 1 bits in the 2's complement binary representation of the specified integer value. We can compare given integers. We can compare two integer objects numerically. We can decode a string into an integer. So these are the methods we can use with wrapper classes, and this is why sometimes it is useful to convert primitive data types into wrapper classes or objects such as this integer, because we can use these methods quite easily. Thanks for watching. In this lecture, we are going to talk about autoboxing and unboxing, so primitive types and object types. So if we want to create an wrapper class for an integer, we have to use something like this. We try to create an integer object, so int object. We can do something like this, but it is not a good programming practice. So in the old days, we use something like this, that we instantiate a new integer object with the value, but it is deprecated. So instead of this, we use something like this, integer and the value of 100. So this is how we make sure that the int object is going to store the integer value 100. So if I print out int object and save and run it, of course the result is going to be 100. If we use, for example, 300, save it and run it, then the result is going to be 300. So this is how we can create a wrapper class, so an object for an integer. Of course, we can do the same for a double. So double object is equals to a double and the value of, for example, 30. In this case, it is going to be converted into a double. So if we print out the value of the double object, as you can see, it is converted into double. So this is an integer, but it's going to be converted into a double precision floating point number. Okay, so this is how we can create wrapper classes for objects, so integers, doubles. Okay, by the way, if we create something like this, so autoboxing object, if we use something like this, the exact same thing is going to happen. So in the background, Java is going to use something like this, that integer value of 10. So basically this is called autoboxing, that we use a primitive type and it's going to be transformed into an integer object. So under the hood, Java is going In this lecture, we are going to talk about the methods of the wrapper classes. So this is what we have been talking about in a theoretical section, that the reason why we use wrapper classes is because there are several useful methods we can use. Okay, so for example, the value of method. As you can see, we can use the value of method with strings. So we can define an integer as a string and it's going to be converted into an integer. We can use a double as a string and with the help of the value of method, it's going to be converted into a double. It is true for booleans. We can use the value of false, which is going to be transformed into a boolean value. If you give wrong values, then Java throws a runtime exception. So for example, let's try to run the application with 20 or something like this. So as you can see, it is a Java number format exception. So this is what's going to happen if you specify some invalid strings. Okay, so otherwise we can print out the values of the integer object, the double object, and the boolean object. So let's make sure it is working fine. Okay, so 20.0 is the double value, false is the boolean value, which means that it is working fine. Then we are able to use binary representation because it is binary. This is where we define the so-called radix. The radix is going to define the number of values in the alphabet. In this case, because it is binary, we have 0 and 1, so 2 possible values. And as you can see, we are able to convert a binary representation into an integer. So as you can see, 11010 in binary is equals to 26 in decimal. So we are able to use binary representation as well. Okay, then we are able to use primitive type as we have discussed in the previous lecture. So the value of 30 is going to be an integer. The value of 30.33 is going to be a double. We can use it for characters as well. As you can see, the value of letter A is going to be a character. So here you can check that 30 is the integer, 30.33 is a double. In this lecture, we are going to talk a bit more about wrapper class methods. So first of all, we are able to use the compare_to method that's going to compare two integers. As you can see here, we define a given integer with value 10, and we are able to compare it with other integers. And if the return value of this method is equals to 1, it means that this integer is greater than the argument. If the return value is equals to 0, it means that this integer has the same value as the argument itself. And if the return value is -1, it means that the integer, so in this case 10, is smaller than the argument we specify here. So the return value of this compare_to method has three possible values: +1, 0, or -1 accordingly. So if we run it, as you can see, the first value is 1, which means that 10 is greater than 9. The second result is 0, which means that 10 is equals to 10, of course. And -1 means that 10 is smaller than 11. So we are able to use this compare_to method. It is quite powerful. So when you are implementing, for example, your own data structures from scratch, you have to use this compare_to method very, very often. Okay, let's talk a bit about Boolean variables. We have a b variable with value true, then b2 with value false, and b3 with value true. Again, we can use this compare_to method, and as you can see, it is going to return 1, 0, or -1 accordingly. So if b is true and b2 is false, it is going to return +1. If this value is true and the argument is true, then we return 0. And -1 means that the b2 is false, so this value is false and the argument is true. By the way, we don't use the compare_to method on Booleans usually, but as you can see, you can do it without any issue. Okay, then we have the equals method. The equals method determines whether the number object that invokes the method is equal to the object that is passed as an argument. We are going to talk a lot more about the difference between the equals and the double equal sign operator in the coming lectures, so it's going to be clear. At the moment, I is equals to I2. What does it mean that 10 is equals to 10? Okay, as you can see, it has the value true. Because I3 has the value 9, 9 is not equals to 10, so that's why it's going to be a false. We can use the equals method on Booleans to check whether the true value has the same logical value. So B has the value true, B3 has the value true, so true is equals to true, that's why we have a true. And of course, true is not equals to a false, so this is why the result is a false. So we can use the equals method and the compare_to method because of the wrapper class. So this is why it is good to have wrapper classes and objects, because we can use these methods quite easily. We can use the ceil and the floor methods. So if we have a double 9.51, then the ceil is going to yield the ceiling. So the ceil is 10, so it's going to round up the value. The floor is going to do the opposite. It's going to round down the value, so that's why the value is 9. We can use the round that's going to round up the value as well, so 20.59 is equals to 21, okay. We can get the minimum and we can get the maximum out of two values. So for example, we have 9.51 and 20.59. The minimum is going to yield the smaller value, the maximum is going to yield the greater value. And with the help of the random method, we are able to get a random value within the range 0 and 1. If you are familiar with Monte Carlo simulations or cryptography or neural networks, then generating random numbers is extremely crucial. So this is why it is advisable to check math.random as well. That's going to generate a random value within the range 0 and 1. As you can see, in this case, it generated 0.9474 and so on. So we can generate random numbers. By the way, these are pseudo-random numbers. If you are interested in cryptography and what's the difference between true random numbers and pseudo-random numbers, then check out the course on cryptography. Anyways, it is extremely crucial to be able to generate approximately random numbers. These are called pseudo-random numbers, and we can do it with the help of the math.random method. Okay, so that's all about the most important methods as far as wrapper classes are concerned. Thanks for watching. In this lecture, we are going to talk about characters related methods. So first of all, let's create a character with value letter A, and let's create a character with the value integer 9. We can check whether the given character is a letter or is a digit. So if we run the application, that's why the first value is true, because letter A is a letter, but the digit 9 is not a letter. That's why the second one is going to be a false. Then because the character is not a digit, that's why it's going to be a false. And the last value is a true because the digit is a digit. So we can check whether a given character is a letter or a digit. I guess it is quite a useful feature for Java wrapper classes. Then we can check whether the given letter is a white space or not. So we have the isWhitespace method that's going to return true, as you can see, because it is a whitespace character. Then we can check whether the given character is an uppercase or lowercase character. So that's why it is true, because it is an uppercase letter. Then we can transform lowercase letters to uppercase letters and uppercase letters back to lowercase letters. So we can manipulate characters, as you can see, with the help of these methods. Then we can use escape sequences. So if I try to run the application like this, that we want to print out that Java said hello to the word, then we are not able to do so because we have to use the so-called escape sequences. So this is why we can use this escape sequence. As you can see, if you use a backslash right in front of the code, then we can print out that Java said hello to the word. So we can use quotation mark, but we have to use the escape sequences. Okay, we can use the same for single quotation mark. We can use the same if we want to use backslashes, because backslash is an escape sequence. But what if we would like to print out a backslash? Then we have to use another backslash right in front of the backslash. And as you can see, this is why just a single backslash is printed out to the console. Then we can use tabs. So this backslash T is going to use a tab. The backslash N is going to use a new line character. So this is why Java said a new line character hello to the word. Java said, and there's a new line hello to the word. So this is how we can use escape sequences, and this is how we can manipulate characters with the help of wrapper class methods. Thanks for watching. In this chapter, we are going to talk about garbage collection. In other programming languages such as C and C++, the programmer has to deal with memory management manually. So for example, if you are familiar with C programming, then you have to allocate memory with the help of the malloc function. You have to free the memory with the help of the free function. So what's crucial that the programmer has to deal with memory management manually. In these languages, the programmer is responsible for both the creation and the destruction of objects. Usually, the programmer neglects destruction of useless objects, and this can cause out-of-memory problems when the memory becomes full. On the other hand, Java, we are in a better situation because it has an automatic memory management system called the garbage collector, or GC, that works in the background. The garbage collector runs on the heap memory. We are going to discuss stack memory and heap memory in the coming lectures, so it's going to be clear what is the heap memory, but what's crucial that garbage collection has something to do with heap memory objects. So garbage collector runs on the heap memory to free the memory used by objects that doesn't have any reference. Okay, so garbage collector works in two simple steps. First of all, marking the given objects, and then sweeping the objects that have been marked. So as far as the mark phase is concerned, the garbage collector identifies which pieces of memory are in use and which are not. As far as the sweep process is concerned, the garbage collector automatically removes objects identified during the mark phase. So these are the two important steps as far as the garbage collection algorithm is concerned. So once we made an object eligible for garbage collection in the mark phase, it may not be destroyed immediately by garbage collector. When the Java virtual machine runs garbage collector program, the object will be destroyed. This is the sweep phase. So what's crucial that garbage collection is rather a non-deterministic process. The Java virtual machine runs this process and it is more or less independent of the programmer. System checks whether there's enough free space in memory, and if there is not, it runs the garbage collection to free up some memory. So you have no direct control over the garbage collection in Java. We are going to take a look at several examples in the coming lectures, and it's going to be clear why garbage collection is non-deterministic. So before the garbage collection, there may be used spaces in the memory where there are objects. So as far as these red chunks are concerned, it is needed for the application. But there are several objects that are not used by the application, which means that they are eligible for garbage collection. And of course, there are some free space in the memory. After the garbage collection, these chunks that are eligible for garbage collection are going to be removed, which means that they can be used up again by the application. So basically now they belong to the free memory. And after the compaction, Java Virtual Machine makes sure that the used chunks are going to be rearranged in a manner in order to avoid memory fragmentation. So for example, we create a new car. When we instantiate a new car, then the car object is going to be created on the heap memory, and we will have a reference to the car object. So the reference is the A variable itself, and when we instantiate a car with the new keyword, we create a new car object. We can create another car object with variable b, which means that we have another reference and another object. Then we can create another car object that's going to be present on the heap memory, and we have the reference as well. So the c variable, the b variable, and the a variable, these variables are references, and every single reference is pointing to a memory location in the heap memory, basically to the given objects. Okay, so what's going to happen when we set a variable to be null? It means that we are going to remove the reference. So the a variable is no longer pointing to a memory location in the heap memory, which means that this car object will be eligible for garbage collection. So what's crucial that objects that do not have any references, they are eligible for garbage collection. So because this car object doesn't have a reference, because we set a variable to be a null, there is no reference anymore, which means that the garbage collector will get rid of this car object. Okay, what if we set c equals to b? It means that the car reference with value c is going to be pointing to the second car object, so there will be no direct reference to the third car object, which means that it is eligible for garbage collection. What if we set b equals to be a null, so we get rid of this reference, but what's extremely crucial that it is still alive because it still has one reference coming from the variable c. So the second car object is not eligible for garbage collection. Okay, so when the Java virtual machine runs the garbage collector system is going to get rid of the first car object, and it's going to get rid of the third car object, but it is not going to get rid of the second one because it has an active reference. So this is how the algorithm works. If there is an active reference, then that given object is not eligible for garbage collection. And this is why graph algorithms are extremely crucial, because mark and sweep algorithm relies heavily on breadth first search as a graph algorithm in order to detect the objects that can be removed and the objects with active references. Okay, so you may pose the question that what is the exact difference between an object and a reference? Do not confuse a reference with the object that it refers to. They are two different entities. The reference is a variable that has a name and can be used to access the contents of an object. An object, on the other hand, is sitting on the heap memory and doesn't have a name. In the coming lectures, we are going to talk about stack memory and heap memory, and it's going to be clear that the objects are on the heap memory, but the references are in the stack memory. So the stack memory references are going to reference a given memory location on the heap memory. So objects are present on the heap memory, references are present on the stack memory. Therefore, you have no way to access an object except through a reference. So we can access a given object present on the heap via a reference or a variable present on the stack memory. So that's all about objects, references, and the garbage collector ecosystem. Thanks for watching. In this lecture, we are going to take a look at a concrete example for garbage collection. So I'm going to create a new class, for example, car, and the car class is going to contain a so-called finalize method. This finalize method, as you can see, is called by the garbage collector on an object when a garbage collection determines that there are no more references to the object. So this is what we have been talking about in the previous lecture when we have been talking about a theoretical background for garbage collection. That garbage collection algorithm is going to check whether are there any active references for that car object. And if there are no active references, then it's going to get rid of that object, and before removing that given object from the heap memory, it's going to call the finalize method. Okay, so this is the protected void finalize that throws throwable, and here we are going to print out, just for demonstration purposes, we print out the object itself, object cleaned from heap memory. Okay, so this is what's going to be printed out whenever the garbage collector removes that given object from the heap memory. And in the application, let's check if we create a new car. This is what we have been talking about as well, that this is how we instantiate a new object, and this is the reference to the given object. So this reference is in the stack memory, the object is in the heap memory, and we are able to access the object with the help of the reference. Okay, so let's try to set the car reference to be a null. What's going to happen? In this case, there is no longer an active reference to the object, which means that this car object is eligible for garbage collection. So we can call system.garbage collection with the help of this GC method, but this is what we have been talking about in a theoretical section, that garbage collection is rather non-deterministic. So because there is just a single object, it doesn't have any active references because we set it to be a null, and we call garbage collection, but despite the fact that we call garbage collection, usually nothing happens. If you run multiple times, then sometimes Java virtual machine is going to call garbage collector and it's going to run the finalize method in the car class, but there are cases when there's nothing happen, as you can see, like in this case. So this is why I told you that garbage collection is rather non-deterministic. As a software engineer, we are not able to control garbage collection. So sometimes it is working fine and sometimes it is not. So for example, if we use a for loop and I is smaller than 50, I++, and we create several car objects, then we set the references to be a null, and then we call system.garbage collection. Again, sometimes it is going to work fine, but sometimes it's not going to work because there are going to be just 50 car objects on the heap memory, which is not a huge number. So this is why Java virtual machine may come to the conclusion that okay, there are enough free memory in the heap, and this is why Java virtual machine is not going to run garbage collection despite the fact that we call system.gc. So if we run it, Okay, then the garbage collector is going to be called, but as you can see, it should be called 50 times. And here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is called 20 times and not 50 times. So again, we can come to the conclusion that the garbage collection mechanism is rather non-deterministic. Despite the fact that we call garbage collection explicitly, sometimes garbage collection is going to run, but sometimes it's not going to run. So finally, let's consider the situation when we create 5 million car objects, but without the system.gc. So in this case, we are not going to do something like this. So we are not going to call the garbage collection procedure explicitly. And if we save it and run it, then as you can see, Java Virtual Machine is going to call the garbage collection automatically, because if the Java Virtual Machine calls garbage collection, then garbage collector is going to run the finalize method of the given class automatically. So this is why we know that the garbage collection has run. You may pose the question that what is the conclusion? First of all, the conclusion is that garbage collection is rather non-deterministic. The Java Virtual Machine is going to decide whether to run garbage collection or not. If there are just a small amount of objects in the heap memory, then usually Java Virtual Machine is not going to run garbage collection. So basically, there's no need to call system.gc because the Java Virtual Machine is not going to run garbage collection anyways. But if there are a huge amount of objects on the heap memory, then we don't have to call system.garbage collection because the Java Virtual Machine is going to run garbage collection anyways because of the huge amount of objects in the heap memory. And this is why system.gc is a bad practice, because let's recognize that system.gc isn't an absolute solution and we are not able to rely on this solution as a software engineer. What's crucial that instead of calling system.gc, maybe we should refactor our implementation. We should make sure that we hold active references to objects that we need in the future, and we have to make sure to get rid of the references and set them to be a null if we do not need that given object anymore. Because if there are no active references to given objects, it means that these objects are eligible for garbage collection. So that's all about system.gc and garbage collection. Thanks for watching. In this lecture, we are going to talk about the main differences between stack memory and heap memory. So let's talk about heap and stack memory overview. So knowing how memory actually works in Java is important, as it gives you the advantage of writing high performance and optimized applications. It helps you to understand the scope of variables, object creation, and memory management in the main. In Java, there are two main memory types, stack memory and heap memory. As far as stack memory is concerned, it contains method calls, local variables, and reference variables. On the other hand, heap memory contains objects and instance variables. You may pose the question that what are instance variables? For example, when we have a car class, then we can define private integer, for example, speed. We can define private string name of owner and something like this. So these variables that belongs to the class itself, these are called instance variables, and these variables are stored on the heap memory, of course, because these are associated with the object itself. Okay, so stack memory contains primitive values that are specific to a method and references to objects that are in a heap referred from this given method. The Java heap space is used by Java runtime to allocate memory to objects and Java runtime environment related classes. Whenever we create any object, it is always created in the heap space. Okay, so let's take a look at a concrete example. Every single application starts with the main method. Because it is a method call, it's going to be inserted into the stack memory automatically. So in the stack, a frame will be created from the main method. And if we create a given variable, for example a double with value 10, then this local variable d in the main method will also be created in the main method's frame on the stack memory. So that's why the main method has a local variable d. If we make a given method call, then this public void method1 will be called with the given argument. So what does it mean? Method calls are stored on the stack memory, so there's going to be another stack frame for method1. Okay, so if we create the method1 specific local variable, a floating point number with value 30, then these values are going to be stored on the stack memory associated with the given method. So method1 stack frame is going to contain the argument I and the local variable f. So as you can see, every single method has a distinct frame on the stack memory. And by the way, these stack frames are independent. So for example, within the main method, we are not able to alter the value of the local variable f because they are in different stack frames. Anyways, if we call, for example, another method, method2, which is a public void method again, it is going to be stored on the stack as usual. And if we create a new object, for example, we have a class house with instance variables, windows and doors. If we instantiate a new object with the new keyword, then this house object is going to be stored on the heap memory. Okay, so as you can see, a new object is created on the heap memory with instance variables. So it is crucial that instance variables, it may seem to be very similar to local variables, but they belong to a given class. So local variables are stored on the stack, but instance variables that belongs to a given class, they are stored on the heap memory. And the reference itself, in this case the house ref, is going to be present on the stack memory. Okay, so as you can see, the house reference is on the stack memory. This is what we have been talking about in the previous lecture, that the reference itself is on the stack memory, but the object it is referencing is present on the heap. Okay, so the assignment operator makes the house ref reference variable to point to the house object in the heap memory. Okay, so there's the reference from the house ref present on the stack to an object present on the heap memory. So what's going to happen when we finish with method 2? When method 2 execution is completed, the flow of the control will go back to the command method 1, because method 1 called method 2. That's why Java is going to consider method 1 again. Okay, so this is what's happening here. And what's crucial, that because method 2 is completed, it is flushed out from the stack. So this method 2 related stack frame is going to be removed from the stack. So what does it mean exactly? That there is no active reference to the object present on the heap. So what does it mean exactly? That this object is eligible for garbage collection. So when the Java virtual machine runs the garbage collector, the object will be destroyed because there is no active reference to that given object. This is exactly how garbage collection works. After method 1 is finished with its execution, then method 1 stack frame is going to be removed from the stack memory, and the flow control will go back to the command main method. So this is why this stack frame is removed from the stack memory and we go back to the main method. And because there are no more operations in the main method, which means that we are finished with the execution of the main method related stack frame is going to be removed from the stack as well. Okay, so this is how stack memory and heap memory works. Method calls, arguments and local variables are stored on the stack memory, but objects on the other hand are stored on the heap memory. So whenever we create a new object, then the reference itself is on the stack memory and the object itself is on the heap memory. So this is the crucial difference between stack and heap. Okay, so any object created in the heap space has global access and can be referenced from anywhere of the application. The stack memory is always referenced in a LIFO, so last in first out order. push operation adds an element at the top of the stack, and the pop operation removes an element from the top of the stack. So I'm not sure whether you are familiar with abstract data types and data structures, but stack is the most common abstract data type. We can store items in a LIFO manner, so the last item we insert is the first one we take out. In this case, the stack is going to contain method frames, and within the method frames there are local variables and argument values. Okay, we can use Java Virtual Machine options to define the startup size and the maximum size of the heap memory and the stack memory. So we can control that what's going to be the size of the stack memory and the heap memory. What's crucial that when stack memory is full, then Java runtime throws a stack overflow error, whereas if heap memory is full, it's going to throw an out of memory error. So this is crucial as a software engineer to be able to detect whether the stack memory is full or the heap memory is full, and we can conclude based on the error itself. Stack overflow error has something to do with the stack, and out of memory error has something to do with the heap memory. In the next lecture, we are going to talk about how to monitor heap memory in Java. Thanks for watching. In this lecture, we are going to talk about how to monitor the heap memory in Java. So first of all, every Java application has a single instance of class runtime. So we can get a runtime reference with the help of runtime.getRuntime. You may pose the question that what is this runtime? Basically, it allows the application to interface with the environment in which the application is running. So we can monitor the size of the heap memory, the total memory, the maximum memory, and so on. So first of all, if we have the get runtime and we have access to the runtime interface, then we can get the total memory. So if I save and run it, first of all, we have the total memory in bytes, but we would like to deal with megabytes. So this is why 1 megabyte is equals to 1024 kilobytes. 1 kilobyte is equals to 1024 bytes. So that's why 1 megabyte is this amount of bytes. So this is why we have to divide the total memory by this value in order to get the memory in megabytes. So as you can see, heap memory currently available for use is 245 megabytes. So this is how we get the In this lecture, we are going to talk about constructors and constructor overloading. So first of all, as we have learned before, the constructor is called when an object of a class is created. So whenever we instantiate a given class with the new keyword, this is when the constructor is going to be called. The name of the constructor matches the name of the class. It is very similar to a method. What's crucial that there is no return type as far as a constructor is concerned. So all classes have constructors by default. If you do not create a class constructor yourself, the Java compiler creates a default constructor. The default constructor doesn't have any parameters. Each time an object is created using the new keyword, at least one constructor is going to be invoked. It could be the default constructor or it could be the constructor that we have specified. Usually we invoke the constructor in order to assign initial values to the instance variables or data members of the given class. If we write a constructor, then the compiler is not going to create the default constructor. So for example, we have a class, example class, and the default constructor has the same name as the class itself. It doesn't have any parameters and it doesn't have a return type. Okay, so as far as the default constructor is concerned, in this case, as far as my class is concerned, as you can see, we have a single integer instance variable, but we haven't specified the constructor explicitly, and this is why Java is going to create the default constructor in the background. So if we instantiate the new class and we print out the value of x, this is why it is going to be 0, because Java is going to create the default constructor in the background and it initializes class variables to their default values. For primitive types it is 0 and for objects it is null. If we specify the constructor on our own without a given parameter, it is going to be very similar to a default constructor, but here we can define a specified value. For example, we initialize the value of x to be 33. So it initializes class variables with fixed values for all objects created by this constructor. So if we print out the value of x again, this is why the value is going to be 33. And we can have parameterized constructors. A constructor that has parameters is known as parameterized constructor. We can initialize fields of the class with the constructor. So in this case, we get a given value I, and we set the value of x to be the value of I. So this is why if we instantiate the class with the new keyword, we have to specify that I value. Here it is 99. So if we print out the value of x, this is why it has the value 99. Sometimes there is a need of initializing an object in different ways. This can be done using the so-called constructor overloading. So constructor overloading is a technique in Java in which a class can have any number of constructors that differ in parameter list. The compiler differentiates these constructors by the number of parameters in the list and their type. So here, as far as the person class is concerned, as you can see, we have two constructors. The first constructor has just a single string n, and this is how we initialize the name variable. But again, we can define a constructor without any parameters, and here we can initialize the name to be unknown. So if we instantiate the person with a string, then the name value is going to be Kevin. Otherwise, if we instantiate the class without defining the string value, this is when this constructor is going to be called, so the name value is going to be unknown. This is called constructor overloading because we can define several constructors within the same class, as you can see. Overloaded constructors often call each other. One common technique is to have each constructor add one parameter until getting to the constructor that does all the work. It is called constructor chaining. So as you can see, my class has three variables x, y, and z. We can define a constructor for the x value, and then we call the constructor with two parameters. So with the help of this, we are going to call the constructor with two values x and 10. As you can see, this constructor is going to be called with the value of x and value of y, and then again we call a constructor with three parameters x, y, and 100. And finally, this constructor does all the work, which means that it sets the x value to be the x value, y value to be the y value, and z value to be the z value. So this is called constructor chaining. We can instantiate the class with a single value. It is going to be the value of x, then y is going to be 10, and z is going to be 100. So this is why the final result as far as c.x, c.y, and c.z is concerned is going to be 3, 10, and 100. So this is what we are going to talk about in the coming lectures. Thanks for watching. In this lecture, we are going to talk about constructor overloading. So first of all, let's create a new class, house. This house has several instance variables, so private integer number of rooms, then private integer number of doors. For example, a house has number of windows. Okay, so these are the instance variables, and we are able to inject values for these variables from outside with the help of constructors. So for example, I would like to create a new constructor. Okay, so if there are no parameters, so the user doesn't provide the number of rooms, number of doors, number of windows, then we are going to call this with value 1. What does it mean? That it is going to call the constructor of this class. So of course we have to create another constructor with a single argument, which is going to be the number of rooms. Okay, so if this constructor is called, then we call another constructor. This is called constructor chaining. So we call the number of rooms and we specify, for example, 10, which is going to be the number of doors. So let's create another constructor with number of rooms and number of doors. And what's going to happen here, that again we use constructor chaining, so we call the constructor with number of rooms, then the other parameter will be the number of doors, and then there's going to be the number of windows with value 20. So let's create that constructor as well, number of rooms, number of doors, and the last argument is going to be the number of windows. So in this case, we set this dot number of rooms is equals to the number of rooms. This dot number of doors is equals to the number of doors. And this dot number of windows is equals to the number of windows. So this is how we can use constructors, and this is how we can use constructor chaining in order to set the values for instance variables. So if I instantiate a new house with no parameter, then what's going to In this lecture, we are going to talk about method overloading. So if a class has multiple methods having same name but different arguments or parameters, it is known as method overloading. So what's crucial that these methods have the same name but have different arguments and parameters. There are two ways to overload the methods in Java: changing number of arguments or changing the data type. So this is what we are going to do. We are going to use the method with the same name but with different data types. So for example, I would like to create a static integer odd method that's going to take number 1 and number 2 as the arguments. Okay, we print out that adding two integers and then we return with num1 plus num2. So this is how we add given integers. Then we can do the same. So this is why it's going to be method overloading, because we use the same name of the method, but instead of integers, we are going to use it for doubles. So that's why we have double number 1, double number 2, and adding two doubles. And we return with num1 plus num2. Or, for example, we can add integers, but instead of adding just two integers, we can add, for example, three integers. So adding three integers and num1 plus num2 plus num3. So this is what we have been talking about, that there are two ways to overload the methods in Java, changing the number of arguments. This is what's happening here. The given method has the same name, but they has different arguments. Here there are two parameters, here there are three parameters. So we can print out that, for example, we would like to add 1 and 2. So in this case, we add two integers, so this method is going to be called. If we run it, adding two integers and the result is 3. What if we add three integers? 1 plus 2 plus 3 is equals to 6, and we call this method where the method has three parameters and adding three integers is printed out, and of course the value, which is 6. Then of course we can add doubles. So if we use 1.0 plus 2.0, then adding two doubles method is going to be called, and the result is a double with value 3. So this is called method overloading, when a given class has multiple methods with the same name but with different arguments and parameters. So this is exactly what's happening here. Thanks for watching. In this lecture, we are going to talk about the main differences between overriding and overloading. So we have already learned about method overloading and overriding, but sometimes they can be confusing for Java programmers, so let's summarize the differences. Overriding means having two methods with the same method name and same parameters. So in this case, both the method name and the parameters are exactly the same. But one of the methods is in the parent class and the other is in the child class. So these methods are in different classes. By the way, the given method can be in a parent interface, but anyways, method overriding is the example of runtime polymorphism. On the other hand, overloading occurs two or more methods in one class have the same method name but different parameters. So this is what we have been talking about in the previous lecture, that overloading has something to do with the given class, and that given class contains several methods with the same name. As far as overriding is concerned, there are same method names In this lecture, we are going to talk about strings and string creation. So first of all, what are strings? Strings are sequences of characters and they are threaded as an object. So in Java programming language, strings are objects, so they are stored on the heap memory. We can create and manipulate strings with the help of the string class. There are two ways to create string objects. First of all, with string literal. So string name is equals to Kevin. This is how we create a string variable with value Kevin. The second approach is to instantiate a new string with the value Kevin. Both of these approaches are working fine, but we are going to come to the conclusion that using string literals are way better and efficient than instantiating new strings. So let's talk about the so-called string constant pool or the intern pool. Since strings are everywhere in Java, they use up a lot of memory. Many strings repeat in the program, and to solve this issue, it is a good idea to reuse common strings. The string constant pool or the intern pool is a location in the Java virtual machine that collects all these strings. So string constant pool is a memory location within the heap memory. Let's take a look at a concrete example. What's going to happen if we create a new string with the value Kevin? Kevin is the constant value, and of course we have a reference variable, in this case n1. Because the string constant pool doesn't contain Kevin as a string, each time you create a string literal, the Java virtual machine checks the constant value and the string constant pool first. So because Kevin is not present in the string constant pool, that's why Java virtual machine is going to insert Kevin into the string constant pool. Okay, so there's going to be a Kevin in string constant pool. What if we create another string variable with the same value? If the string with the same value already exists in the pool, then Java Virtual Machine will not create a new object, but will return the reference to the same instance. So what's crucial is that the Java Virtual Machine never creates duplicate objects in the string pool. Okay, so as you can see, the references are pointing to the same object in the string constant pool. Okay, so this is how we create strings by string literal. What if we instantiate a new string? In this case, it is not that efficient because first of all, the Java virtual machine will going to check whether the value, so Kevin, is present in the constant pool or not. If it is not present, then at compile time, Java virtual machine is going to check the constant pool and going to insert the given value if necessary. In this case, because Kevin is already present in the constant pool, that's why there is no need to insert again. So if a string with the same value already exists in the pool, then Java virtual machine will not create a new object there. But because of the new keyword, Java virtual machine is going to create a new string object at runtime in the heap memory. Okay, the string constant pool is in the heap memory as well, but as you can see, this Kevin object is going to be created outside the string constant pool. And the reference variable will be pointing to this object. So n3 is going to be pointing to Kevin object in the heap memory. This Kevin object is not part of the string constant pool. So this is why it is crucial that if we use the new keyword, then Java virtual machine is going to check the string constant pool. If the given value is not present in the constant pool, then Java virtual machine is going to create a new object. And because of the reference, the Java virtual machine is going to create another object outside the string constant pool in the heap memory. Notice that only the values are the same, but the reference variables are pointing to different objects. So the first two Kevin strings are pointing to the constant pool, but the last string we have created with the help of the new keyword is pointing to a different location in the heap memory. Okay, what if we create another string with the same value Kevin? Kevin is not going to be inserted into the constant pool because there is already the string Kevin, but as you can see, another Kevin object will be created in the heap memory. So notice the difference between the literal creation and creation by the new keyword technique. As far as constant pool is concerned, there's just a single Kevin and all of the strings are referencing that given value, while on the other hand, if we use the new keyword, Java Virtual Machine is going to create as many string objects in the heap memory as many times we instantiate a new string. So this is why using string literals are way more efficient than using the new keyword. Okay, let's create a new string with value Peter. Peter is not present in the constants pool, so Java Virtual Machine is going to insert Peter into the constant pool. Okay, and then because we use the new keyword, we have to create another object in the heap outside the scope of the constant pool with value Peter. So as you can see in this case, two strings are created, one string in the constant pool and one string in the heap memory outside the scope of the constant pool. So note that when you are creating string with new keyword, you will create one object or two. It depends on whether the value of the string is already present in the string pool or not. So in the example, when the string's value Kevin was already in the pool, there was only one new object created by the Java Virtual Machine in the heap memory. And as far as Peter is concerned, the Java Virtual Machine had to create Peter in the constant pool and had to create Peter outside the constant pool in the heap memory. It is possible that in the future, in a Java-related interview, you will be asked a tricky question in the string topic. The question looks simple: how many string object is getting created in the statement below? If we create a new string with the help of the new keyword, then what's going to happen? In this case, the answer is that it could be 1 or 2. It depends on whether the constant value of the new string is already in the string constant pool or not. If it is the first string, so the constant pool doesn't contain that string, then the Java Virtual Machine is going to create two string objects, one in the constant pool and one in the heap memory. So it is rather a tricky interview question as far as strings are concerned. This is the main difference between string literals and creating strings with the help of the new keyword. Thanks for watching. In this lecture, we are going to talk about string comparison. So there are two ways to compare strings, with the help of the double equals sign and with the help of the equals method. So the difference between the double equals sign and the equals method, that both equals method and the double equals sign operators are used to compare objects to check whether the objects are equal or not, but there are two differences between them. The double equals sign tests for reference equality, so whether they are pointing to the same object or not. On the other hand, the equals method, it's a comparison of values within the object, so it tests for value equality, whether they are logically equal. So the double equals sign has something to do with the memory location, and the equals method has something to do with the value itself. By the way, if a class doesn't override the equals method, then by default it uses the equals method for the closest parent class. Okay, so let's consider the examples we have been talking about in a theoretical section. This is what we have been talking about, that we are able to create a string literal like this, and we are able to instantiate a new string. This is what we have been talking about, that we should avoid this implementation. Now, just for demonstration purposes, we are going to use string literals and we are going to use the new keyword to create strings. So if we create a Kevin with string literals like this and then another Kevin variable, then what's going to happen? This is exactly what we have been talking about in a previous lecture, that Kevin is going to be inserted in the string constant pool, and whenever we create another string with the same value Kevin, then it is going to be pointing to the same location. So as you can see, there's just a single Kevin variable in the constant pool, and both of the strings are pointing to that given location. Which means that if we check with the double equals signs, that going to test for reference equality, so whether they are pointing to the same memory location or not, then N1 and N2 is going to be true. So if we run the application, then as you can see, n1 is equals to n2, so it is a true value, which means that both of these variables share the same memory location. This is exactly what we have been talking about with string constant pool. If we check whether the values are the same, so Kevin is equals to Kevin, of course, in this lecture, we are going to talk about the intern method. This intern method returns a canonical representation for a string object. The intern method may save a lot of memory for our application. So what is it exactly? When the intern method is invoked, if the pool, so the constant string pool, already contains a string equal to this string object, then the string from the pool is going to be returned. Otherwise, this string object is added to the pool and the reference to this string object is returned. By the way, Java automatically interns string literal. So if we create something like this is exactly what we have been talking about in a theoretical section. That whenever we create a string like this, then the string itself is going to be added to the string pool. So it is like calling the intern method automatically. It means that the intern method is to be used on strings that are constructed with the new keyword. So for example, we have a constant string with a string literal with value Kevin. What's going to happen in the background? Because we create the string like this, then it is going to be added to the constant string pool. What if we create a string like this with the new keyword? In this case, an object is going to be created outside the pool somewhere on the heap memory. So what does it mean exactly? That the constant string =, new string, it's going to be false. Why? Because they are pointing to different memory locations. This Kevin string is in the string pool. This Kevin object is on the heap memory outside the scope of the string pool. So this is why the =, as you can see, is false. Of course, the value values are the same, so Kevin is equals to Kevin, so this is why the equals method is going to return true. So if we use the intern method on this variable, then what's going to happen? This Kevin is going to be inserted into the string pool. Of course, there's already a Kevin, so it is not going to be inserted, but more important that the reference to the string pool object is going to be returned, and the new string is going to point to the same memory location as the constant string in this case. So this is why after calling the intern method, this string object is going to be added to the string pool if necessary, which means that the double equals sign in this case will return true. Of course, the equals method will return true, but it is quite straightforward because Kevin is the same as Kevin, so the values are matching, no question at all. So what happened in the background? Before calling the intern method, the new string was pointing to the heap to an object with value Kevin. After calling the intern method, the new string is pointing to the string constant pool to an object which value is Kevin. So after the intern method, constant string and new string are pointing to the same object in the pool. So this is why we can use intern method. It is crucial that if we use something like this, so with string literals, then the intern method is going to be called automatically, which means that this object is added to the string constant pool. So that's all about the intern method. Thanks for watching. In this lecture, we are going to talk about the most important string-related methods. So we have already been talking about the equals method that compare of values as far as objects are concerned, and we have already discussed the intern method that returns a canonical representation for a string object. Okay, so for example, if I create a string, for example, Adam, then I am able to get the number of characters. So I am able to do something like string1.length. And with the help of the length method, we are able to return the length of the string. The length is equal to the number of Unicode units as far as the string is concerned. So in this case, we have 1, 2, 3, 4 characters. So that's why the length is going to return 4. If we have, for example, Kevin, then the result is going to be 5 because there are 5 letters in the Kevin string. Okay, so this is how we use the length method. Then we are able to concatenate given strings. So we can use string2, for example, spacey. We are able to concatenate that given string. So I'm going to have the result. The result is equal to the string1. We are able to use the plus operator. It is not that efficient because whenever we use the plus sign as concatenation, then Java is going to create a new string. So this is why it is not the best solution possible. But anyways, let's check whether it's working fine or not. It is working fine, as you can see. So we are able to concatenate given strings, and we are able to use the so-called concatenation method. So this concatenation method concatenates the specified string to the end of the string. Okay, so if I use concatenation with string2, then the result is going to be the same. We are able to concatenate Kevin and Spacey. We are able to use the so-called char@at method. So if I use the string1.char@at with index 0, what does it mean? That Java is going to return the letter with index 0. Index 0 represents the first letter, index 1 is the second letter, index 2 is the third letter, and so on. So with index 0, the K is going to be returned. If we use 1, then E is going to be returned. Of course, we are not able to use 10, for example, because it is outside the scope of the string as far as the letter indices are concerned. So in this case, we get a string index out of bound exception. Of course, if we want to get the last letter, we have to use something like this, that the length -1 because indices starts with 0. So this is how we can get the last letter as far as the string is concerned. We are able to use the substring method. So if I have a string, just for demonstration purposes, let's use something like hello world in Java. Okay, so this is the string and we are able to print out the substring. So if we use substring with index 5, what does it mean? That Java is going to create a substring starting with index 5, 0, 1, 2, 3, 4, and 5, and that's why this is going to be the substring, as you can see, and it includes the character with index 5. Of course, we are able to specify that, for example, 0 and 5, what does it mean? That we would like to get the string where the first letter index is 0 and the last letter index is 5. So if I run it, then hello is going to be printed out. So this is how we can get a substring as far as a given string is concerned. We are able to use the replace method. It is quite common again. So we have the, for example, letter L, and we would like to change it to, for example, the capital K. And if we use something like this and run the application, then as you can see, Java is going to consider this string and it is going to substitute the L letters with capital K, and this is why it is going to be the solution. So all the L letters are substituted with capital K. We can use the replace all method. The replace all is going to consider a given string. For example, the Java is going to be substituted to Python. So if I save and run it, then hello world in Python. So this replace all replaces each substring of this string that matches the given regular expression, in this case the Java word, with the given replacement. In this case the replacement is Python. So we don't have to implement our substring search algorithms from scratch because Java has extremely powerful methods. So that's all about the replace method. We can use the trim method. The trim method is going to get rid of the unnecessary white spaces as far as the beginning and as far as the end of the string is concerned. So if we use something like trim without any argument, we don't have to specify anything. In this case, as you can see, the unnecessary white spaces have been removed. So the trim method is going to get rid of the white spaces. And finally, let's talk about the split method. So this is going to be splitted, and we can do something like the following. We are going to get a one-dimensional array of strings. So strings is equals to the string, and we would like to split it as far as the ampersand sign is concerned, and we have to specify that how many chunks we are going to get. 1, 2, 3, 4, 5, and 6. So if I specify 6, then I am able to use a for each loop. So string s strings, and I am able to print out the s, and what's going to happen is that Java is going to split this given sentence based on the given character we have specified, and we have to specify the number of chunks we are going to get. 1, 2, 3, 4, 5, and 6. So this is how we can use the most important methods in Java. Thanks for watching. In this lecture, we are going to talk about string immutability. So first of all, what is string immutability? The string class itself is immutable, which means that once it is created, a string object cannot be changed. So the string class has a number of methods, this is what we have been discussing in the previous lecture, that appears to modify strings. For example, the trim method, for example, the substring method, for example, the replace method. So these methods are modifying the strings, but because the strings are immutable, what these methods really do is create and return a new string that contains the result of the operation. So this is why we have to be very careful when manipulating strings, because these operations are usually not memory efficient. We keep creating several objects on the heap memory because of the fact that strings are immutable. So once it is created, a string object cannot be changed, which means that whenever we do some modification, Java is going to create a new object. So for example, we have a string Alex, then what's going to happen? It is going to be inserted into the string constants pool. This is what we have been talking about. What if we do some concatenation? So the concat method appends the string at the end of the original one. So the result is going to be Alexander, but if we print out the name, because strings are immutable, the name is still Alex. So it is not Alexander, but it is still Alex because strings are immutable. Okay, so what if we do something like this, that the name is equals to name.concat_, then Alexander is going to be the result. So Alexander is the value of the name variable, and it is going to be inserted into the string constant pool again. So this time it will print Alexander because Java Virtual Machine creates a new string by string literal in the pool with this new concatenated value, and the name reference variable is going to be pointing to this. Please notice that the Alex object is still not modified because it is immutable. Okay, so because the new string object Alexander is assigned to name, the old Alex object has no more reference variable and it becomes eligible for garbage collection. So as you can see, Alex has no active reference to it, which means that garbage collector is going to get rid of this object. Okay, so because of the fact that strings are immutable, it is usually not efficient to manipulate strings with the help of these methods. And this is why we are going to talk about string builder and string buffer, because if we have to modify strings frequently, then it is a way better and more efficient option to use string builder and string buffer. Thanks for watching. In this lecture, we are going to talk about string buffer and string builder. So in the previous lectures, we have been talking about that string manipulation is quite expensive because whenever we modify a string, the Java Virtual Machine is going to create a new object on the heap because strings are inherently immutable. The string buffer and string builder classes are used when there is a need to make a lot of modifications to strings of characters. Because unlike strings, objects of type string buffer and string builder can be modified over and over again without leaving behind a lot of new unused objects on the heap memory. The only difference between string buffer and string builder is that string buffer is thread safe, whereas string builder is not. So it is recommended to use string builder whenever possible because it is faster than string buffer. Of course, if there are more threads in a given application and we want to avoid inconsistencies, of course we have to stick with string buffer. So for example, if we create a string like this with value Alex, then it is going to be created in the string constant pool. If we modify with the help of concatenation, then another string is going to be created in the string constant pool. In this case, because there is no active reference to Alex, it is eligible for garbage collection. If we make another concatenation, Alexander the Great, again, there's going to be a new string in the string constant pool. There's not going to be an active reference to Alexander, which means that it is eligible for garbage collection. So this is the case if we are dealing with strings. What if we use string builder? If we create a new string builder with the value Alex, then there's going to be a new object on the heap memory. If we modify or append, for example, under, then the Alex is going to be updated to Alexander. If we append again the Great, then Alexander will be modified to Alexander the Great. So this is why it is more powerful and more efficient to use string builder, because as you can see, we modify and update the same object on the heap memory. Instead of keep creating new objects, we keep manipulating and updating the same object. And this is why string builder is more efficient. Okay, so let's take a look at the comparison of string, string buffer and string builder. Strings are immutable, but string buffer and string builders are not. As far as speed is concerned, manipulating strings is quite fast. Okay, it is not that memory efficient, but anyways, manipulating string is quite fast. Manipulating a string buffer is slow because it is thread safe, but manipulating a string builder is fast again. Strings are stored in the string pool. String buffer and string builder objects are stored outside the scope of the string pool in some location of the heap memory. As far as thread safe is concerned, strings are thread safe because they are immutable. String buffer is thread safe, but string builder is not. So this is why it is advisable to use string buffer whenever there are multiple threads in the application, but if it is a single threaded application, then string builder is the best way possible because it is fast and because it is not immutable, which means that we keep updating the same object. Hence, it is memory efficient. Okay, so that's all about string builder and string buffer. Thanks for watching. In this lecture, we are going to talk about string buffer and string builder. So first of all, let's try to compare string builder and string buffer as far as speed is concerned. So what we have been discussing in the previous lecture, that string buffer is thread safe, hence it is slower. String builder is not thread safe, but usually in a single threaded application it is better to use string builder because it is faster. In order to demonstrate the speed of string buffer and string builder, let's call the append method for 10 million times on string buffer, and let's do the exact same operation with string builder. And then we are able to get the system current time millis that's going to return the system time in milliseconds, and this is how we can measure the duration of the running time as far as string buffer and string builder is concerned. So if we run the application, we can come to the conclusion that, as you can see, string builder is approximately 2 times faster than string buffer. So if we are dealing with a single threaded application, then we should use string builder because it is faster. Of course, if there are multiple threads manipulating the given strings, we have to use string buffer. Let's take a look at concrete methods for string builder. So we are able to instantiate a new string builder with a given string. So in this case, the string builder will contain the string Wall Street, and we are able to append 12, then we are able to append some spacing, and we are able to append New York. So if we print out the string builder itself, then we get Wall Street 12 New York. So as you can see, we are able to concatenate given strings, but the main difference is that here we keep updating the same object. So these operations are memory efficient. Okay, the insert method is going to add characters to the string builder at the requested index and returns a reference to the current string builder. So if we insert this substring to the position 15, it means that we are going to insert the substring 5th floor to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5. Here we are going to insert 5th floor, and as you can see, it is working fine. Okay, so this is how we use insert. We are able to remove given characters in a substring with the help of this delete method. So in this case, we delete the substring starting with index 15 up to index 26. By the way, there's a good documentation. So if you hover your mouse over this method, as you can see, there's the documentation itself. So with the help of this delete method, we have managed to delete a given substring. Okay, then we are able to reverse a given string. So as you can see, this is the reversed string itself. And finally, what's crucial, that with the help of the toString method, we are able to transform a string builder or a string buffer into a standard string object. So usually this is the case that we are going to manipulate the string with the help of string builder because it is more efficient. But in the end, we transform the given string builder into a string because this is what we are after as a programmer usually. So this is how we can use the built-in methods of string builder. Thanks for watching. In this lecture, we are going to talk about enums. So first of all, you may pose the question that what are enums? Enums or enumerations are representing a group of named constants in a programming language. An enum type is a special data type, basically a special clause that represents a group of constants which are unchangeable variables that represents a group of constants. Of course, constants are unchangeable variables like final variables in Java. In order to create enum, we can use the enum keyword, so instead of a class or an interface, we can define an enum and separate the constants with the help of commas. Because they are constants, the field names of the enum types are in uppercase letters. What's crucial that enums are unchangeable variables that must be equal to one of the values that have been specified. Common examples include directions such as north, south, east and west, or the days of the week, so Monday, Tuesday, Wednesday, up to Sunday. So these kinds of constant variables can be used as enumerations. So this is how we can define it in Java. So public enum day, this is how we create the day enum type, and as you can see, we can define the given values: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. If we want to use it as a variable, as you can see, we can use enum as a data type. So a day with variable name d is equals to the day dot, and with the help of the dot operator, we can choose the given variables we have specified within the enumeration. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday or Sunday. So after we select, for example, Friday, then the d variable is going to store Friday as a constant. So we can use enums for different things, such as with switch statements. We are going to take a look at several examples, and it's going to be clear why is it crucial to talk about enumerations. The final question is, what's the crucial difference between enums and classes? An enum can have attributes and methods just like classes, but contrary to a class, enum constants can be public, static and final. It is crucial that unchangeable in this case means that it cannot be overridden. Okay, so an enum cannot be used to create objects, and it cannot extend other classes, but it can implement interfaces. So a good question is when to use enums. You should use enum type anytime you need to represent a fixed set of constants. Use enums when you have values that are not going to change, like month, days, colors, deck of cards, and so on. So in the coming lectures, we are going to talk about concrete examples related to enums. Thanks for watching. In this lecture, we are going to talk about the concrete implementation of enums. So for example, I'm going to create a new enum. As you can see, the name of the enum will be day. And as you can see, this is how we can define an enum. Public enum and the name of the enum. So instead of public class and the name of the class, we can define an enum with public enum and the name of the enum. And here we can enumerate the possible values. So in this case, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. So these are the possible values as far as the days of the week is concerned. So how to use an enum? In the application.java, we can print out, for example, the enum. So we can print out day.Friday, and if we run the application and print it out, then Friday is going to be printed out. We can do something like this, that day, for example, Monday is equals to day.Monday. It's more or less the same, so we can print out Monday and it's going to print out Monday as well. We can iterate through the given enumerations. So for day D, as far as the day values are concerned, so with the help of these values, we can get the possible values we have defined here as a one-dimensional array. Okay, let's try to do something like this. So as far as the values method is concerned, as you can see, it's going to return a one-dimensional array of day type. Okay, so values, and we can print out the D. So if we save it, then we iterate through all the possible days, and Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, we are able to print it out. What's crucial that we are able to define an enum within a given class. So here, for example, we can define enum season. Okay, and we can define the values as we have seen with days. So spring, summer, autumn, and winter. So again, we have defined season as an enum within a given class, and we can use exactly the same manner. So we are able to print out the season.spring. Okay, something like this. It's going to be the spring. We can iterate through the given enum. So season as season values, and we can print out the given value itself: spring, summer, autumn, and winter. And we can use a switch statement. So for example, public static void season method that's going to get a season as an argument. Okay, and we are able to switch on the given season, and we can define that case spring. We would like to print out that this is spring. Then case autumn, we can print out this is autumn. As far as winter is concerned, we can print out this is winter. Finally, in case of summer, we can print out that this is summer. And of course, we can define the default values. So whenever the season is not spring, not autumn, not winter, and not summer, then the default is going to be called. I'm going to call not sure about the season. And of course, sorry for that, we have to use break. Whenever we are using switch statement, we have to use break after every case. So something like this, here, then here, and here as well. So if we call this season method season.autumn, for example, let's save it and let's run it. This is autumn, so it is going to be called. If we use it on summer, for example, then this is summer. So this is how we can use an enum within a given class. This is how we can use enum outside a given class. So when we define the given enum type in a distinct Java file, and this is how we can use enums with switch statements. So that's all about enums. Thanks for watching. In the coming lectures, we are going to talk about dates and times. So in Java, there are two ways to represent and manipulate date and time. The old way, when we use the following classic date and calendar APIs before Java 8, this was the only possibility. So java.util.date or java.util.calendar, java.util.Gregorian calendar. So this is the standard way we can use date and time. And there's the new way. After Java 8, a new series of date and time APIs are created in the new java.time package. So java.time package related classes are way more convenient than using the java.util related classes. Okay, so we will learn the new way, but we will look into the classic old way too, so your knowledge will be complete, and also because you can run into this in many older applications. So older applications rely heavily on the old way of handling dates and time. So this is why we are going to consider java.util.date, java.util.calendar, but after that we are going to talk about the java.time related classes, and you can come to the conclusion that the new classes are very convenient to use. Okay, so what are the main differences between the new version and the old version? First of all, In this lecture, we are going to talk about how to manipulate date and time as far as java.util related classes are concerned. So we are going to instantiate a new date object. It is a new date. We have to import the java.util date, so java.util package, okay. And we are able to print out the date.toString. So if we save and run the application, as you can see, it is going to print the date and the time. So it is Tuesday, the 16th of April. It's going to print out the time, the year, and so on. We can instantiate a new calendar. So java.util.calendar. So calendar.getInstance. And here we can specify the year, for example, 2015. The month is equals to January, for example, and the 1st of January. So this is what we are after. 2015, the 1st of January. We can get a date object. So the date is, for example, current date is equals to the calendar.getTime. As you can see, this getTime is going to return with a date object. So if we print out again the current date.toString, then it's going to print out that January the 1st, 2015. And basically this is the main problem with the old way. So this date and calendar related implementation, that no matter what, we have to define the time itself. Hour, minutes, and seconds, despite the fact that, for example, there is no need to specify the actual time. So as you can see here, we didn't specify the time, but despite the fact that we didn't specify the time, it is going to be printed out. By the way, we can do the same with calendar. For example, calendar 2 is a new Gregorian calendar, and here we can specify the year, for example, 2019. The month will be calendar.April, and we would like to specify the 10th of April, so we can do it without any problem. Again, we can get the calendar2.getTime, and with the help of this toString, we are able to print out the given date. So system out println calendar2.getTime toString. Again, the main problem that it's going to print out the hour, minute, and seconds, despite the fact that there is no need to print it out. So we don't specify the time, but with the help of this calendar getTime, it's going to be printed out anyways. By the way, we can use the simple date format in order to specify whether we would like to print out the year first or the time first or something like this. So if we instantiate a new date object and we specify the simple date format is equals to a new simple date format, we can specify the pattern. And we would like to use something like this, that year, month, day, then hour, minute, and second. So with the help of the simple date format, we can specify the format of the date itself. Okay, and we just have to use something like this, that date format, and here we have to specify the date itself. So if we want to format the date itself, then we have to use something like this. If we run the application, as you can see, it's going to be printed out the year, so year, month, and day. And this is the time itself, so hours, minutes, and seconds. So this is how we can manipulate date itself. And there are several methods with which we can manipulate the date object itself. So again, if we specify a calendar is equals to calendar get instance, we can update the calendar with the help of the set method. So we can specify that the year will be 2019, with the month will be the 1st of October, and then we are able to update it. So calendar.add we can specify calendar date and we can specify the amount. So what does it mean? That with the help of this odd method, it's going to odds or subtracts the specified amount of time to a given calendar field. So in this case, we have specified 2019, the 1st of October, and here we can add 2 days. So if we print out again calendar.getTime.toString, this is how we convert calendar to a date, and if we call the toString method on the date, then it's going to print out the actual date. And as you can see, it is the 3rd of October. So we are able to add or subtract a given date with the help of this add method. We are able to compare given dates. So if we specify date2 is equals to calendar.getTime, then it's going to return with a date object. The date is the actual date, which is the 16th of April 2019. It is the 3rd of October 2019, so we can compare the two date objects. So if we print out that date.compare to date2, then this compare to works exactly the same as we have discussed with integers or strings. It can have 3 possible values: -1, 0, or +1. -1 means that this date is smaller than date 2. 0 means that the dates are exactly the same, and if it is +1, it means that date is greater than date 2. Of course, because the actual date now is 2019, the 16th of April, that's why it is smaller than 2019, the 3rd of October. So we are able to compare two date objects, and we are able to check whether date is before date 2. So it's going to return a Boolean value. Of course, it is true because 2019, the 16th of April, is before 2018, the 3rd of October. If we specify in another way, of course, we will get a false. So we are able to compare date objects, and finally we are able to get the time zone. So if we do something like this, that time zone, so java.util.timezone is equals to timezone.getDefault, we can get the zone name is equals to timezone get display name, and we are able to print out the name of the given time zone. In this case, I am from Hungary, so that's why the time zone name is Central European Time. It is working quite fine. This is how we can manipulate date and time as far as the old approach is concerned. As you can see, it has something to do with the java.util related classes such as date, time zone, calendar, and so on. But after Java 8, there's a way better approach as far as manipulating date and time is concerned, and this is exactly what we are going to consider in the coming lectures. Thanks for watching. In this lecture, we are going to talk about the java.time package related classes. So this is the best way to handle dates and time. First of all, we can use local date and local time, and as you can see, this is the main advantage, that we are able to separate dates and times. So in the previous lecture, we have been talking about the java.util.date class and calendar class, and we came to the conclusion that usually it is not able to separate dates and times. As far as the java.time package related classes are concerned, it is extremely easy to do so. So for example, with the help of the local date, as you can see, it is java.time.localDate, we can call a now method that's going to obtain the current date from the system clock in the default time zone. We can do the same for local time. It is going to obtain the current time from the system clock in the default time zone. So whenever we run the application, as you can see, the current date is 2018, the 16th of April, and the time is approximately 3:30. So with the help of local date and local time, we are able to get the exact date and time. we have the local datetime class, and with the help of the now method, we can get the date and the time as well. We can specify the date as we want with the help of local date of. We can specify the year, we can specify the month, and we can specify the day. We can do it with the help of integers exclusively, so there is no need to use month.march, but 3 represents the third month of the year, which is March, so date A and date B is going to be the same basically. So as you can see, this is the date A and this is the date B that have the same values. Okay, so this local date and local time are extremely useful classes. We can define time with the help of the local time.off method. We can specify the hour, the minute, the seconds, and the nanoseconds. So if we specify 9 and 33, it's going to be 9 hours and 33 seconds. So as you can see, the time is 9:33, which means that it is up to the programmer to define the minutes, to define the seconds, the nanoseconds, whatever he or she wants. We can use the local datetime class where we can specify the year, the month, the day, the hour, and the minute. Of course, we can specify the seconds and the nanoseconds as well. In this case, we just specify the hour and the minutes. Another way is to use date and time as we have instantiated here. So a local time and a local date can be the argument of the local date time, and Java is going to construct a local date time object based on local date and local time objects. As you can see, date time and date time 2 have the exact same values. Again, we can use datetime formatter in order to print and parse datetime objects. So we can specify a local date, a local time, as we have seen earlier. We can construct a local date time, and the parameters are the local date and the local time objects. So basically we create a datetime object with this year value, month value, day value, hours value, minutes value, and seconds value. We can decide with the help of the datetime formatter whether we use a short format, a full format, a long format, medium format, and so on. So this is why this datetime formatter can prove to be very, very useful. As you can see, the short date with format short date is going to be this value, so just the year, the month, and the days. We can do the same for hours and minutes, and we can do the same for a local datetime object, so year, month, days, and hours and minutes. We can manipulate and update dates and times related objects. As you can see, we create a local date with this year value, month value, and days value. We print out the date itself. As you can see, it is the 4th of July 2021. We can update the days. So as you can see, plus days method is going to add 12 days to the actual value, and that's why 4 plus 12 is 16. So we can update the local date object. We can update the year with this with year method. So we update 2021 to 2019. As you can see, the result is 2019. The month and the days remain the same. And a very, very powerful feature is the so-called method chaining. So as you can see, we create a local date and a local time, and we can create a local date time with local date time off with the date and the time, minus days and minus hours, which means that it is going to be 2020, December the 1st, minus 1 day. What does it mean exactly? That the result is going to be the 30th of November, and minus 11 hours is going to decrement the hours value, as you can see. So this is how we can update very, very conveniently the local date, local time, and local date time objects. So this is why java.time package is way more convenient and powerful than java.util related classes. So this is the best way to use date and time. Thanks for watching. In this lecture, we are going to talk about conditional statements. So, as we learned earlier, in programming, it's often required to execute a certain section of code based upon whether the specified condition is true or false, which is known only during runtime. For such cases, conditional statements are used with the help of if statements, if-else statements, if-else-if statements, or switch statements. Okay, so let's talk about the simple if statement. We have a given condition, and if the given condition is true, then the code is going to be executed. What about the if-else statement? If the condition is true, then the code will be executed, and this code will be executed after the else case if the condition is false. So with the help of if-else statement, we can run a specified code whether the condition is true or whether the condition is false. Of course, we can define several else-if statements, so if the condition is true, then the code will be executed here. Else if we can check another condition. In this case, the code is going to be executed is condition 1, so the first condition is false and the second condition is true. Then we can use another else if statement with condition 3, which means that this specific code is going to be executed if the first condition is false, the second condition is false, but the third condition is true. And if we use an else after the if and else if statements, this code is going to be executed if all the conditions are false above. So condition 1, condition 2, condition 3, then the code within the else block is going to be executed. We can use a switch statement, so we can switch on a given expression, and if the value 1 is matching the given expression, then this specific code is going to be run. Otherwise, if value 2 is matching the expression, then this line of code is going to be executed and so on. And we have to define a default case, which means that this code is executed if none of the cases are matched. Okay, there is a possibility to nest if-else statements, which means you can use one if or else if statement inside another if or else if statement. In other words, the nested if statement means an if statement inside an if statement. So for example, this is a nested if statement. We have an if with a given condition, and within the if statement there is another if statement with a second condition, which means that if the first condition is true, then this line of code is going to be executed, but within the nested if, the code is going to be executed only if condition 1 is true and condition 2 is true. So both of the conditions have to be true in order to execute this line of code. So this is the so-called diagram of nested if-else statements. A good question is, can we make a triple nested statement? Of course, the answer is yes, but don't forget that you can often use logical operators as a simpler solution to avoid too much nesting to increase code readability. This is exactly what we have been talking about in the logical operator section, that as you can see, this line of code is executed if the first condition is true and the second condition is true. So we can use just one if statement and we can change the given conditions. So condition 1 is equals to true and condition 2 is equals to true. So this is how we can avoid nested if statements. Okay, so here we have 3 nested if statements, and as you can see, the third nested if statement code is going to be executed if the first condition is true and the second condition is true and the third condition is true as well. So we can avoid nested if statements with the help of logical operators as a simpler solution in order to avoid too much nesting to increase code readability. So that's all about statements. Thanks for watching. In this lecture, we are going to take a look at a concrete example for nested if statements. So for example, if we have 3 numbers, num1 is equals to 2, integer num2 is equals to 10, and integer num3 is equals to 20, and we are after the greatest number, then we are able to use nested if statements in order to find the largest number. So first of all, we can check that if the number 1 is greater or equal than number 2, then we can use another if statement. So if the number 1 is greater or equal than number 3, in this case we know for certain that the greatest number is equal to the number 1, and else we know for certain that the greatest number is equals to the number 3. Okay, in the else statement, we have to check whether if number 2 is greater than equal to number 3. In this case, we know that the greatest number is the number 2, and else we know for certain that the greatest number is equals to number 3. Finally, we can print out that the largest number is, and we can print out the greatest number. So if we run the application, of course, it's going to show us the largest number, which is 20. Of course, we can do something like this, and in this case, the number 2 is going to be the largest number. If we use something like this, then the first number is going to be the largest number. So with the help of these else if statements, we are able to find the largest item. And as you can see, there's an if statement within an if statement, and this is what we have been talking about, that we are able to use logical operators. Because what does it mean exactly? It means that if number 1 is greater than number 2 and number 1 is greater than number 3, so we can use something like this: number 1 greater or equal than number 3. So we are able to get rid of nested if statements with the help of logical operators, but anyways, both of them are working fine. This is how we use nested if-else statements. Thanks for watching. In this lecture, we are going to talk about loops and nested loops. So a loop statement allows us to execute a statement or group of statements multiple times. It repeatedly loops until a particular condition is satisfied. What's crucial that there are 3 types of loops: the for loop or the for each loop, the while loop, and the do while loop. And there are 2 types of loop control statements. So with the help of the break statement and the continue statement, we are able to control these loops: the for loop, the while loop, and the do while loop. So as far as the for loop is concerned, we have to define the starting value, we have to define the condition, so we start with I equals to 0, while the value of I is smaller than 4, and we have to define what we are going to do in every iteration. In every iteration, we are going to increment the value of I, and after that, in every iteration, the code is going to be executed. In this case, we just print out the value of I. So this is why we print out 0, 1, 2, 3, and after the 3 is incremented, so I++, the value is going to be 4. 4 is not smaller than 4, so this statement is going to be false, and if the statement is false, then Java is going to terminate the for loop. Okay, we can do the same with the for each loop. As you can see, we don't have to specify the 3 conditions. Here we iterate through the colors one-dimensional array of strings, so we know for certain that it's going to be a string. We have to use the name of the variables, and then we have to define the one-dimensional array itself. Sorry for that, the valid syntax is something like this, by the way. So this is how we can print out red, green, blue, and yellow. What about the while loop? The while loop is going to have just a single statement, and if the statement is true, then it is going to be execute the given code snippet. So for example, the initial value of I is equals to 0, which is smaller than 3, so it prints out the value of I, and then it increments the value of I. 1 is smaller than 3, so it prints out 1, then it increments the value. 2 is smaller than 3, so it prints out the value and increment the value. 3 is smaller or equal to 3, so it prints out 3, but after the incrementation, 4 is no longer smaller or equal to 3, so this is when Java is going to terminate the while loop. On the other hand, the do while loop is going to do some operation, and after that it's going to check a given statement. So as you can see, the while loop is going to check the statement, and if the statement is true, then it's going to do some operations. On the other hand, do while loop is going to do some operations, and after that it's going to check a given condition. So for example, in this case, I is not greater than 100, but the value of I is going to be incremented and going to be printed out because it is a do while loop. So at the beginning we do some operations. Here we just print out the incremented value of I. This is why 1 is going to be printed out. And then we check some condition. 1 is not greater than 100, which means that the condition is false and Java is going to terminate the do while loop. Okay, so while is going to check the condition at the beginning, while on the other hand, the do while loop is going to check the condition after doing a given operation. Okay, we can use the break and the continue statement In this lecture, we are going to talk about a concrete example for nested for loops. So first of all, I'm going to define something like this. For integer I is equals to 0, I is less than 5, I plus plus. This is the outer for loop. Here we print out that outer for loop I index and we print out the value of I. And here we have an inner for loop j is equals to 0, j less than 5, j plus plus. And here we print out that I value and we print out I, and j value and we print out j. So this is how we can use nested for loops. As you can see, this is the outer for loop and the inner for loop. So what does it mean exactly? That within a given iteration, as far as the outer for loop is concerned, we will make as many iterations with the inner for loop as we define here. So if we save and run it, as you can see, we have outer for loop I index 0. We make as many iterations as we specify here. So 0, 1, 2, 3, 4, which is 5 iterations because we use something like this. If we define j is less than 3, then we are going to make just 3 iterations with the inner for loop. So the outer for loop I index is 0. We make 3 iterations, 0, 1, 2. Then we make another iteration with the outer for loop. That's why the index will be 2. And here we start again. So that's why, as you can see, the indices starts over and over again. 0, 1, 2, then 0, 1, 2, then 0, 1, 2 again until we hit 4, because after incrementing 4, it's going to be 5, and 5 is not less than 5, which means that we terminate with the for loop. So this is how we use nested for loops. Usually, it is useful when we have a two-dimensional array of integers, for example. We have a new integer array with 3 and 3 items. What does it mean? That it's going to be a 3 times 3 matrix. It is a two-dimensional array with 3 columns and 3 rows. And we can do something like this, that with the help of the nested for loop, I'm going to get rid of the unnecessary white spaces. We can say that the nums with row index I and column index j is going to be equals to I times j. And if we run the application, of course, then we have to print out the values. So I'm going to use another for loop and going to print out the value nums I and j. Of course, something like this. Here we use some spacing, and after every inner for loop, we make a new line character. So if we run the application, of course, we get an array index out of bound exception because we would like to use the index 4 and index 5 when we have just index 3 and index 3 as far as the row and column indices are concerned. So of course, it is fine. We have to use something like this. And as you can see, we end up with something like this. 0, 0, 0, 0, 1, 2, 0, 2, and 4. So with row index I and column index j, we store the value I times j. So usually when we are dealing with so this is why I told you that with the help of a nested for loop, we are able to manipulate two-dimensional arrays. Just for demonstration purposes, let's take a look at for loop labels. This is what we have been talking about, that we can have names for each Java for loop. These are called optional labels. Okay, so for example, the outer for loop has the label outer loop. The inner for loop has the label inner loop. And why is it good? Because if we want to break out of the outer loop instead of the inner loop, then we can specify that break outer loop. Without specifying that we break of the outer loop, the break keyword is going to break out of the inner loop. So if we run the application like this, we end up with something like this. If j is equals to 2 and I is equals to 2, then we break out from the inner loop and the outer loop keeps iterating. So this is why we have some additional values here. If we specify that we would like to break out of the outer loop, what's going to happen? As you can see, after j is equals to 2 and I is equals to 2, we are going to break out of the outer loop, which means that there are no further iterations. So finally, we terminate with our for loops. So this is why sometimes it can prove to be very useful to have labels such as inner loop label and outer loop label, because we can specify with the help of break and continue that what for loop we are referring to. So this is why it is crucial to use labels. Thanks for watching. In this chapter, we are going to talk about array data structure and arrays related methods. So as we learned earlier, an array is a container object that stores a fixed number of items from the same data type. It is very important that an array can store items with the same data type. So we are not able to store strings, integers, and floating point numbers in the same array. A given array can store items with the same data type. Each item can be referred to by an index. Arrays are zero-based, which means that indices starts with 0. Okay, so this is how we can create a one-dimensional array of strings. We can define the given values, so Adam, Kevin, and Joe, or we can create a one-dimensional array of strings with the new keyword, so new string, and we can define the number of items we are going to store in the one-dimensional array. The first item, so with index 0, this is what we have been talking about, that arrays are zero-based. So the first item is Adam, the second item is Kevin, the third item is Joe. So we end up with the exact same one-dimensional array of strings if we use something like this. So curly braces and Adam, Kevin, and Joe. Okay, we can loop through the array with the help of a for each loop. In this lecture, we are going to talk about the most important arrays-related methods. So first of all, we can create a one-dimensional array of integers. This is what we have been talking about in the previous lecture: 1, 5, 3, 10, 15, and 0. So in this case, this nums one-dimensional array of integers is going to store 1, 5, 3, 10, 15, and 0. If we want to print out this array, we can use the so-called arrays.toString, and we have to specify the one-dimensional array. And if we run the application, as you can see, we get the array we have defined here. What if we would like to sort the array? We have the arrays.sort method that's going to take a one-dimensional array as an argument, and after the sorting procedure, as you can see, this is the numerical order: 0, 1, 3, 5, 10, 15. We can do the same with strings. So if we have string names, for example, Adam, Kevin, then Joe, Nora, and something like this, if we sort this one-dimensional array of strings and we print out arrays.toString names, it's going to give the alphabetical ordering. Adam, Joe, Kevin, Nora is going to be the alphabetical order of the one-dimensional array of names. So with the help of this array sort, we can sort the given one-dimensional array. By the way, the algorithm itself is the quick sort for primitive types and merge sort for objects, because strings are objects. In this case, merge sort is the underlying sorting algorithm. Because these are primitive types, the quick sort is the underlying sorting algorithm. Both of these methods are extremely fast. They have ortho and log n running time complexity. Anyways, not that crucial. So this is how we can sort a given one-dimensional array of integers. We can use the so-called arrays.fill that's going to take a one-dimensional array, and we can specify the value with which we would like to fill that given array. So if we save and run the application, okay, sorry for that, of course we have to use the numbers. Something like this. As you can see, Java is going to fill the one-dimensional array of integers with the value we have specified. So that's why the array is going to contain values 10. Okay, if the array is sorted, so after we call the sort operation, then we can use the so-called, sorry for that, we have to specify the one-dimensional array. We can use binary search to find a given X item. In this lecture, we are going to talk about how to handle arrays as method arguments. So for example, if we have a simple integer number with value 10 and we have another method, private static void reverse or something like this with the number, and we do something with this number. So if we update the value of the number, so we call this reverse method on the number, and we print out the value of the number, basically because Java is going to pass the argument by value, which means that this variable is not the same as this variable. Java is going to make a copy of that given variable, so if we do something with that given variable, then it is not going to be reflected in the method in which we call the given method. So if we run the application, as you can see, despite the fact that we update the value of the number in another method, the value of the number is still 10, so the initial value. But this is not the case as far as arrays are concerned. So we can define a one-dimensional array of numbers with the values, for example, 1, 2, 3, 4, 5. If we do the same with something like this, sorry for that, I'm going to rename it, for example, alter or modify, maybe it is the best name of the method. So here we modify the one-dimensional array of integers. So we call the modify method on the one-dimensional array, and here we iterate through, so for integer I is equals to 0, I less than the nums.length I plus plus, and we do something like this. The nums with index I is equals to the nums index I times 10. So what does it mean exactly? That we are going to iterate through all the values and multiply the values by 10 on a 1-by-1 basis. So the first value will be 10, the second value will become 20, 30, 40 and 50. So let's see whether it's working fine or not. If we use arrays.toString on the one-dimensional array of integers, then the result should be 10, 20, 30, 40 and 50. So as you can see, in this case it is working fine that we make a given modification for a one-dimensional array of integers, and it is going to be reflected in the method from where we called the method that's going to make the modification. So it is not the same as variables like this. So arrays are quite special in this aspect. And by the way, we can use something that's called the anonymous arrays. So we can define arrays something like this: new integer, and we can define the values on the fly. So 1, 2, 3. There's no need to specify the array like this. So we can do the same. I'm going to comment it out. It is just for demonstration purposes that we are able to create and initialize the values within the same step. So these are called anonymous arrays. That new integer is going to be a one-dimensional array of integers with these values. So we can do it. Java is going to compile it without any error. So this is how we can create arrays like this. And this is crucial, that arrays are passed by reference and not by value. So if we make a modification to a given array, when the array is a method argument, then the modification is going to be reflected outside the scope of the given method. Thanks for watching. In this lecture, we are going to talk about multidimensional arrays. So in Java, you can declare an array of arrays. It is called multidimensional arrays. That means that the components of a multidimensional array are also arrays. So for example, a two-dimensional array is basically a matrix. In order to access the items of a two-dimensional array, we have to define two indices, the row index and the column index. So this is how we can create a two-dimensional array. In this case, we create 3 rows, as you can see, and 4 columns. And as you can see, the indices starts with 0. So row index 0, row index 1, row index 2, and the second index is for the column index. So column index 0, column index 1, column index 2, and column index 3. We can create a 3-dimensional array. Here, we declare a 3-dimensional array of size 2 levels with 3 rows and 4 columns. You can think of this array as a cube basically. Each item requires 3 indices to access, for example 0, 1 and 3. So as you can see, a 3-dimensional array is basically a 3-dimensional structure. 2 means that it has 2 levels, 3 means that it has 3 rows, and 4 means that it has 4 columns again. And as you can see, it has something to do with dimensions. A simple 1-dimensional array is a 1-dimensional structure. A 2-dimensional array is a 2-dimensional structure. A 3-dimensional array is a 3-dimensional structure. Arrays beyond 2 dimensions are rarely used, so that's why we will focus on 2-dimensional arrays instead of 3, 4 and more dimensional arrays. Anyway, with the knowledge of the 2-dimensional arrays, you will succeed with more than 2-dimensional arrays too. Let's see an example of a 2-dimensional array. So this is how we can create a 2-dimensional array with 3 rows and 4 columns. Notice that the initial base value of the items are zeros, which means that we can create a 2-dimensional array without initialization. The initial values are going to be zeros. Okay, so the first index represents the rows, the second index represents the columns. We can initialize the array with some data. This is called assignment initialization. The indices are the square brackets. So in this case, the first item, so first row, first column has the value 4. The first row and second column has the value 2. What's crucial that indices starts with 0 as usual with arrays. We can create and initialize an array like this. The first row will contain the values 4, 2, 3 and 12. So 4, 2, 3 and 12 as you can see. The second row will contain the values 5, 7, 6 and 9, and the third row will contain the values 11, 8, 1 and 10. So this is how we can initialize a 2-dimensional array. Okay, so the first block is going to be the first row, the second block is going to be the second row, the third block is going to be the third row of the 2-dimensional array or the matrix. We can create a so-called irregular 2-dimensional array, also called jagged array, which is a multi-dimensional array where members arrays have different sizes. For example, we can create a 2-dimensional array where the first array contains 4 items, but the second array contains only 2 items. So this is how we can create something like this. As you can see, the first row contains 4 items, 4, 2, 3 and 12. The second row contains 2 items, 5 and 7. The third row contains 3 items, 11, 8 and 1. Again, we have the row indices and the column indices as usual. What's crucial is that if you try to access a non-existing index, you will get an error message. So if we want to access index 1 as far as rows are concerned and index 3 as far as columns are concerned, as you can see, this is the item we would like to access, but it is an empty slot, so this is why we will get an array index out of bound exception. So we have to make sure that we accessing valid items as far as irregular 2-dimensional arrays are concerned. We are going to talk about concrete examples in the next lecture. Thanks for watching. In this lecture, we are going to talk about 2-dimensional arrays. So we are able to create a 2-dimensional array with the help of 2 brackets like this. And we are going to create 2-dimensional array of integers with 3 rows and 4 columns. So what does it mean exactly? Because arrays are initialized with zeros, that's why at the beginning there's going to be something like this, with 3 rows and 4 columns, and all the values are zeros. So we would like to initialize the values, so I less than 3, I plus plus, and we have j is equals to 0, j less than 4, j plus plus. And we are going to set the nums I and j to be equals to I plus j. And then we are going to, sorry for that, it is an integer as well. And then we are going to print out the values accordingly. So here we system out println nums I and j plus some spacing. And sorry for that, now we have to use something like this because we have multiple operations. So we use here like this, and after the for loop we would like to use a new line character. So if we run the application, this is the result. As you can see, the matrix has 4 columns and 3 rows. So what if we would like to manipulate this item? We have to define the row index, it is 0, 1, 2, and we have to define the column index 0, 1, 2. So what does it mean exactly? That we can update 2 and 2. We update the value with the integer 8. So if we save and run the application, as you can see, we are able to update two-dimensional arrays based on indices. And this is why we like array data structure, because we can access the items with the help of indices. This is called random access. It is extremely powerful because it has ordo 1, so constant running time complexity. I'm not sure whether you are interested in algorithms or running time analysis, but random access is an extremely powerful feature of arrays because it is extremely fast. So this is how we can initialize a two-dimensional array. This is how we can update the value of a two-dimensional array. We are able to initialize a two-dimensional array with the following method. So we can define 1, 2, 3. This is going to be the first row. Then we can define the second row, for example, 4, 5, and 6. And then we can define the last row, 7, 8, and 9. And if we initialize the values of the number two-dimensional array, then I'm going to get rid of this. And we just have to print out the values. I don't want to update any values. So if we save and run it, of course, there's going to be an array index out of bound exception, because as you can see, we would like to access an item that's outside the scope of the array, because it is a 3 times 3 matrix or two-dimensional array. Of course, we are not able to access the 4th index. So let's try something like this. And as you can see, it is working fine. So we are able to initialize a two-dimensional array like this. We can specify the items. And what's crucial, that we are able to create a so-called irregular two-dimensional array as well, which means that the two-dimensional array is missing some values, as you can see. So if we use something like this, we can define 3 here. Then in the next row, there's going to be just 2 items and then 3 items again. So here we can use the for each loop. So we get a one-dimensional array of n, for example. And then we iterate through on an integer by integer basis, and it's going to be the k value. It is an array, and it's going to be the num. We iterate through the array itself, and then we print out the number with some spacing, and we use a new line character. So if we print out this matrix, as you can see, there are the values missing. So it is a so-called jagged or irregular matrix. If we want to access the item here, for example, where there's no value, of course, we will get an index out of bound exception. So if we use something like this, that row index 1, so the second row, and column index 2, which means that the third item, then I guess we get a index array out of bound exception. Yeah, because it is an irregular matrix or an irregular two-dimensional array, so we have to make sure that we access valid items. So this is how we use two-dimensional arrays. This is how we can initialize the values. This is how we can iterate through the values on a one-by-one basis. Thanks for watching. In this lecture, we are going to talk about Varargs. So first of all, the Vararg is a short form for variable arguments. It allows a method to accept 0 or multiple arguments, and it stores these arguments using an array under the hood. So we can define variable arguments with the help of 3 dots. So for example, we have this example method that's going to take an integer as an argument, and because we use 3 dots, it represents variable arguments. that tells the compiler that we use Varargs and these arguments will be stored in an array called X. So this X array may contain several variables, and this is the powerful feature of variable arguments, that if we want to use this method with just a single variable, we can do it without any issue. If we want to use 5 parameters, then it is going to work fine as well. So this is the powerful feature of variable arguments. We can call the example method with no arguments at all. We can call example method with a single argument. We can call example method with 4 values. So because of the 3 dots or variable arguments, we can call our example method with an arbitrary number of arguments. Don't forget that Varargs are arrays, so we need to work with them just like we would work with a normal array. In this example, we have defined the data type of X as an integer, so this array is going to store integers. We are not able to define strings as parameters or floating point numbers. We have to use the data type we have defined here. The number of arguments can be found out using the x.length method, so basically we can handle X as a one-dimensional array. While using Varargs, you must follow some rules, otherwise the program code won't compile. So first of all, we can use several parameters. So for example, we have a string, we have a floating point number, and we have one or more integer values. What's crucial is that we have to make sure that this variable argument is going to be the last parameter of the method. So Varargs parameter should be written last in the parameter list of the method declaration. So for example, if we define Vararg at the beginning of the method, it is not going to compile, which means that there's going to be a compile time error. Another important fact that each method can have only one Vararg parameter, so we are not able to use a Vararg for a string and another Vararg for an integer. We have to make sure that a given method may have just a single variable argument. So these are the rules we have to follow. In the next lecture, we are going to take a look at concrete examples. Thanks for watching. In this lecture, we are going to take a look at a concrete example for variable arguments. So for example, we would like to sum up integers. That's why we are going to create a public static void sum method. So in the argument, we want to get 2 integers. So integer num1 and integer num2. So we can call this method without any issue 3 and 5, but what if we would like to use this method for 2 integers, 3 integers, 4 integers, and it depends on the user at runtime. This is why variable arguments came to be. So we can do something like integer ... numbers. And here we can use this nums variable as a one-dimensional array. So we can iterate through I is less than the nums.length I++. We have to define a sum. At the beginning it is 0. So here we can define that the sum is equals to the sum plus the nums with index I. So this is how we can sum up the value, and finally we can print out that the result is, and we append the sum. So here with the sum method call, we can define 2 integers, so 3 plus 5 is equals to 8, but we can define as many values as we want. So 3 plus 5 plus 10 plus 20 In the coming lectures, we are going to talk about array lists. So first of all, arrays, as we have discussed in the previous lectures, have fixed length. So after arrays are created, they cannot grow or shrink. In contrast of this, an array list is a resizable array, also called a dynamic array, which means that it changes size at runtime as needed. So it grows its size to accommodate new elements and shrinks the size when the elements are removed. ArrayList, just like arrays, allows you to retrieve the items by their indices. This is called random indexing, and this is the most important feature of arrays. So accessing items based on their indices are extremely fast operations. Arrays allows duplicate and null values. ArrayList is an ordered collection. It maintains the insertion order of the items. As far as data manipulation is concerned, array lists are quite slow because a lot of shifting needs to occur if any item is removed from the array list. The old way of creating an array list is like this, that array list, the name of the variable, is equals to a new array list. There is another generic way to create an array list, and this is what we have to do. So array list string is equals to a new array list, which means that in this case we specify that the array list is going to store strings. So this is a new generic way of creating an array list. By the way, after Java 7, you can even omit the type from the right side. So as you can see, you don't have to specify string because Java is going to know for certain that the array list is going to store strings. Okay, the main difference is that in the new way of creating an array list is forced to have the only specified type of object in it. If you try to add another type of object, it gives compile time error. So in this case, if we specify that the array list is going to store strings, then we are not able to insert integers, doubles, custom objects, or whatever. In this case, we are able to insert strings exclusively. This is what makes the containers type safe. So this is called type safety. Items in an array list are actually objects. For primitive types, you have to use wrapper classes. Integer for int, boolean for boolean, character for char, and so on. So in this case, if we want to store primitive type integers, no matter that these are primitive types, we have to use the integer wrapper class accordingly. What's crucial that ArrayList class is non-synchronized. If multiple threads try to modify an array list at the same time, then the final outcome will be non-deterministic. Finally, because the ArrayList class implements the list interface, this is why we can do something like this, that the new array list is equals to a list interface. So a list of string example list is equals to a new array list. We can instantiate a new array list like this. Of course, we cannot do something like this, that the array list is equals to a new list, because the list is an interface. We are not able to instantiate interfaces in Java. So that's all about the theoretical background for array lists. In the next lecture, we are going to talk about the most important methods. Thanks for watching. In this lecture, we are going to talk about how to use array lists. So first of all, we can instantiate an array list like this. We use an interface. We are going to store strings. List is equals to a new array list. Of course, this array list is the java.util.ArrayList, and as you can see, it is working fine. We have to import the java.util.list interface as well, and this is how we can create an array list. An array list is basically a one-dimensional array wrapper class. So we can add given strings, for example, names, Adam. Then I'm going to add, for example, Kate, then Joe, Kevin, and Daniel at the end. With the help of this add method, we are able to add a given string to the data structure. So if you hover your mouse, it's going to append the specified item to the end of the list. So it is crucial that in this case we insert Adam, then we insert Kate, which is going to be the last item of the array list. Then because we add Joe, this is why Joe is going to be the last item. Then Kevin and Daniel. So if we print out that system out println, arrays dot toString, and we have to convert the list to an array. As you can see, we can do it with the help of the toArray method. So this ArrayList can be converted into a one-dimensional array with the help of the toArray method. Okay, and then we are able to print it out with the help of the arrays.toString method. So if we save and run it, as you can see, Adam, Kate, Joe, Kevin, and Daniel, these names are going to be stored in the one-dimensional array, so in the array list. We can do something like, I would like to remove, and we can specify the Adam, so the value we would like to remove, or we can specify the index itself. So if I remove the item with index 0, then Adam is going to be removed. So if I remove it here, and after that we print out the content of the array list, as you can see, Adam is no longer an item in the array list. If we remove the index 1, then Kate is going to be removed. And we can specify the value, of course. So if we want to remove Joe, then we don't have to specify the index. As you can see, Java is going to get rid of the Joe item. So this is how we can remove a given item. We can insert a given item with the help of the odd method, but here we can specify the index. So if we would like to insert the, for example, second Joe to the first position, so with index 1, what does it mean? That the second item is going to be this value. We can do it without any problem. As you can see, we have managed to insert the second Joe value with index 1 without any problem. Kate, Joe, Kevin, and Daniel has been shifted because of the new item. In this lecture, we are going to talk about generics. So generics enable types such as classes and interfaces to be parameters when defining classes, interfaces, and methods. Type parameters provide a way for you to reuse the same code with different inputs. The inputs are the types basically. So let's talk about the advantages of generics. First of all, type safety. Type safety means that it is guaranteed that there's going to be just one specific type of object. So as you can see, we can create an array list without specifying that we are going to store strings. In this case, it is not safe as far as types are concerned because we can insert characters, we can insert integers and so on. If we define that this array list is going to store strings, then it is going to be safe as far as type is concerned because we are not able to insert integers, characters, or any custom objects. It is going to result in a compile time error. So this is why type safety is extremely crucial. Okay, the second important fact is that if we use generics, then typecasting is not required. With generics, we don't need to typecast the given object. If we do not specify the type and we insert a given string, whenever we get that given string, we have to cast that given object. This is called typecasting, and we should avoid typecasting whenever it is possible because it is quite expensive. So this is not the fastest solution possible. If we define that the array list is going to store strings, then Java knows for certain that we are going to add strings and we are going to get strings. So there is no need for typecasting, which is going to result in better performance. So typecasting is not required with generics, okay? And finally, we are able to transform runtime errors to compile time errors. So there is compile time checking with generics. So errors are checked at compile time, so no problem will occur at runtime, which is quite favorable. It is a better programming practice to have compile time checking than runtime checking. So for example, if we use something like this with generics, that we have an array list of strings, we add a given string and we try to add a given integer, then it is going to be resulted in a compile time error. While on the other hand, if we do not use generics, then we are able to add a given integer because we haven't specified the type itself. That's why in that case it is a runtime error. So this is why with the help of generics we are able to transform runtime checking to compile time checking, which is a better programming practice. What about generic methods? We can also write generic methods that can be called with different types of arguments. Based on the type of arguments passed to generic method, the compiler handles each method. So for example, we have a one-dimensional array of integers, we have a one-dimensional array of characters, then we can create two print array methods. The first method will get a one-dimensional array of integers. It iterates through the integers and print them out. And we have another method with one-dimensional array of characters as the argument, and it is going to do the same. It iterates through the characters and print them out. So this is what we have been talking about, that it is called method overloading. In this case, we have to create several methods. We can do better with the help of generics. So we can define a generic print array method with a generic array, and we can iterate through the generic types and print them out. This smaller than greater than operator is called the diamond operator. This is how we define that this method is going to be generic. The capital T is the generic type parameter and the lowercase t is the instance of generic type T. So with generics, one method is enough and it can be called with different types of arguments. We are going to implement this problem in the coming lectures and it's going to be clear. What's crucial that with the help of generics, we can get rid of method overloading. Okay, let's talk about generic naming conventions. A type parameter can be named anything you want, but the convention is to use single uppercase letters to make it obvious that they aren't real class names. So the following are common letters to use. The capital T is the generic type parameter. This is what we have been talking about in the previous slide. We have the capital E letter for an element, the K for a map key, the V for a map value, N for number, T for generic data type, S and U and V and so forth for multiple generic types. So this is why we use a capital T if we have a one-dimensional array of generic data type, then it is a good programming practice to use capital T. What about generic methods with two types? A generic method can deal with more than one generic type. Where this is the case, all generic types must be added to the method signature. So this is the example for a method with one generic type, and this is the example for a method with two generic types. As you can see, we have to specify that it is going to be a generic method with two generic types, T and S. We will have a one-dimensional array of the first type and a one-dimensional array for the second type. We make a nested for loop and we print out the values accordingly. Again, the less than greater than operator is called the diamond operator. Capital T and capital S are the generic type parameters, and lowercase t and lowercase s are the instance variables of generic type T and S. We can create generic classes. A class that can refer to any type is known as generic class. A generic class declaration looks like a non-generic class declaration, except that the class name is followed by a type parameter section. The type parameter section of a generic class can have one or more type parameters separated by commas. So for example, we have a class name, and we can define that it is going to be a generic class, which means that the class is going to contain generic data type. So that's why we can define a private capital T content. If we do not specify with the help of the diamond operator that this class is going to be a generic class, then we wouldn't be able to use this capital T as a generic data type as an instance variable. So of course we can use several generic data types, capital T, capital S. The T and S type indicates that it can refer to any type like integer, string, a custom object, or whatever we want. The type you specify for the class will be used to store and retrieve the data. When you instantiate the class, you tell the compiler what T and S should be for that particular instance. So this is what we are going to talk about in the coming lectures. Thanks for watching. In this lecture, we are going to talk about generic methods. So first of all, if we take a look at the ArrayList implementation, we can use an ArrayList without any problem. So I instantiate a new ArrayList, so the java.util.ArrayList, and I'm not going to use generics. So in this case, we are able to store any type we want in this ArrayList. So for example, the ArrayList.add, I'm going to insert an integer. Then we are able to insert, for example, a string, Adam. The main problem is that if we want to get that given integer, for example, this is the number, we are able to do so without any problem. But if we do something like this, there's going to be a compile time error because there's a type mismatch, cannot convert from object to int. So as you can see, if we use an array list like this, then Java is going to store objects. So no matter what type we use, Java is going to cast these items into objects. And this is why we have to use typecasting whenever we get that given item. So in this case, we have to specify that it is an integer. If we get the string name, then again we have to make some typecasting, so get with index 1, and it is not that convenient because we have to make castings, and typecasting is quite expensive operation, and on the other hand it is not an efficient programming solution. So this is why we can use generics, where we define that this array list is going to store strings, and if we do something like this, then Java is going to know that we are going to use strings. So whenever we want to get the name, then we can do it without casting. So if we get the item with index 0, as you can see, there is no need to cast the given value. And this is why using generics is an extremely powerful method, because there is no need for typecasting. Okay, so let's take a look at generic methods. So if we want to create a generic method, public static, we have to define that it's going to be a generic method. Void, for example, print array. Here we can define that it's going to be a one-dimensional array, and we are able to iterate through all the values. So these are the value in the T one-dimensional array, and we just have to print them out. So we print out the value one by one. So if we want to use this generic method, we can do it without any problem. We have a one-dimensional array of strings, for example, the names, Adam, Kevin, Joe, and we call this print array with the names, then it is going to work fine without any problem. If I save and run the application, Adam, Kevin, and Joe. So Java is going to do the following. Whenever we call this method with one-dimensional array of strings, then Java is going to substitute the capital T value with the given type. So it's going to get rid of this. Java will do something like this. And this is how generics is handled under the hood. So of course we want to use it not just for strings, but what if we have a one-dimensional array of numbers? So instead of strings, we are going to use numbers 10, 20, 30, 40. We are able to print out the one-dimensional array of numbers. Yeah, it is true, because we have to use integers, so the object and not the primitive type. If we use something like this, we are able to print the integers with the same method. So as you can see, we are able to avoid method overloading with the help of generics. We don't have to define the same method for characters, strings, doubles, floating point numbers. We just have a single generic method, and this generic method can handle characters, strings, custom objects, whatever type we want. So this is why using generics is extremely powerful. Of course, we can use multiple generic types. So in this case, we have T and V, and here we have two one-dimensional arrays. So we print out the values for the first array, and then we are going to iterate through as far as the second array is concerned, and we print out the values accordingly. So just for demonstration purposes, first array's values and the new line character, and then we use the same here. So this is the second array's values. So if we use a one-dimensional array of integers, and then we have a one-dimensional array of strings, Adam, Kevin, Joe, it's going to be the names, and of course it's going to be an array of strings, then we are able to use the names as well as the numbers. So if I save it and run the application, as you can see, we are able to print out the one-dimensional array of strings, and we are able to print the one-dimensional array of integers with the help of the same method. We can define as many generic type parameters as we want. In this case, we have two generic types, T and V. Okay, so this is how we create generic methods. Thanks for watching. In this lecture, we are going to talk about generic classes. So we are able to create a class, for example, box, and because this class is going to be generic, which means that this class is going to store a generic type, this is why we have to define it like this. So this is how we notify Java that this box is going to contain one or more generic data types. Okay, so this is why we are able to create a private T element If we do not specify it like this, as you can see, we are not able to use the generic data type. So T cannot be resolved to a type. So this is why we have to make sure that this box class is going to be generic. Okay, here in the constructor, it's going to get T element, and we have to make sure that this element is equals to the element. And then we can define the public tGetElement method that's going to return this dot element. And we can define the setter as well, public void set element t element this dot element is equals to the element. Okay, so this is how we can create a generic class that's able to store a generic data type. Of course, we can define as many generic data type as we want. So we are able to use 2 out of the generic data types, as you can see. Of course, in this case, just for demonstration purposes, we just need a simple element. So why is it good? Because now we can create a box and we can define that the box is going to store an integer. So this box is a new box. Of course, we have to define the integer value itself. And then we are able to print out box1.getElement, and this is how we can get the value we have inserted. As you can see, in this case, we specified 100, so that's why the value of the generic item is going to be 100. So if we run the application, we get 100. Of course, if we specify string, then we can define, for example, a name, Adam, and if we get the item, Adam is going to be printed out. So in the background, what's going to happen? Java is going to take a look at this argument, and because it is a string, Java will know that, okay, this generic class is going to store strings. So what's going to happen? It's going to do something like this. It's going to replace the t values with string, and this is what's going to be the result. So this is how generics works under the hood. Of course, we have nothing to do with it, so this is why we can define a generic class like this, and Java is going to handle everything. But this is why generics is an extremely powerful feature of Java. Thanks for watching. In the coming lectures, we are going to talk about generic wildcards. So wildcards are represented by the question mark, and they are used to refer to an unknown type. So for example, if we write question mark extends number in the diamond operator, it means that any child class of number, such as integer, float, or double, can be used. We can call the method of the number class through any child class or subclass object. This is called an upper bounded wildcard. So you may pose the question that what is the difference between the question mark and the t parameter we have discussed in the previous lectures, that if we define this t parameter, it means that we can use anything: strings, custom objects, floating point numbers, doubles, integers, whatever we want. As far as upper bounded wildcards are concerned, we can define that, okay, we can use any type, but we have to make sure that given type is going to be the subclass of number. So basically we can narrow the possible classes we can use. So in this case, we can use integers, floats, and doubles, but we are not able to use strings or custom objects. It is called upper bounded wildcards. Wildcards can also be specified with a lower bound, where the unknown type has to be a supertype of the specified type. If we use question mark super integer, it means that any superclass and all its parents of the integer class can be used, such as number or object, because number or objects are the superclass of integer. So this is the main difference between upper bounded wildcards and lower bounded wildcards. So we can define them with the help of the extends keyword or the super keyword. Of course, we can use unbounded wildcards, which means that, for example, this list has an unknown type. It is useful when writing a method that can be implemented using functionality provided in the object class, when the methods don't depend on the type parameter. So in the coming lectures, we are going to talk about upper bounded wildcards, lower bounded wildcards, and unbounded wildcards. Thanks for watching. In this lecture, we are going to talk about upper bounded wildcards. So let's suppose a situation that we have a public void static print method that's going to take a one-dimensional array as t, and we iterate through for t value in the t one-dimensional array, and we print out the value itself. Of course, we have to tell Java that it's going to be a generic method. This is what we have been talking about in a previous lecture. And of course, sorry for that, we have to make sure that the order is matching. So we have to use static right before the void parameter. So this is how we can define a generic method, as we have discussed earlier. So we can use a string names one-dimensional array, something like Adam, Joe, and Kevin. Okay, and we can call this print method with the names. It is going to work fine. This is what we have been talking about in the previous lectures. But this is exactly what we can avoid with the help of upper bounded wildcards. That if we use something like this, that we get a list of question mark and extends number. In this case, this method can handle list of given types that are the child class of the number. So if we use something like this, of course, java.util.list, we can iterate through the number value. For example, numbers, I'm going to use the variable name numbers. We can do it without any problem, and as you can see, in this case we are not able to print the one-dimensional array of strings. Of course, because first of all we have to use something like this, that it is going to be a list, and we have to use a new array list. So new array list, something like this. We can add the given name Adam. We can add Joe. Of course, we have to import java.util.ArrayList, and in this case, as you can see, this method is not able to handle list of strings. Why? Because we have defined that the type must extend the number. We can do with doubles. So if we create an array list with doubles, for example 10.5 and 20.5, it is going to work without any problem, and we are able to print out the values. We can use it for integers, so if we use something like this, it is going to work fine as well. So this is why using wildcards can prove to be extremely powerful, because in this case we don't know what's going to be the type, but we are 100% sure that it's going to be a child class of the number. So with the help of this question mark extends number, we can make sure that this list is going to be a list of integers, doubles, or floating point numbers, but this method is not going to handle a list of strings, for example. So this is how we can handle upper bounded wildcards in Java. Thanks for watching. In this lecture, we are going to talk about lower bounded wildcards. So this is what we have been talking about in a theoretical section, that wildcards can also be specified with a lower bound where the unknown type has to be a supertype of the specified type. So if we write question mark super integer, it means that any superclass and all its parents of integer, such as number or object, is going to be fine. So for example, we have a method public static void add and print, and it's going to get the list, and this is where we can specify the wildcard, that it question mark super integer it's going to be the list. Of course, we have to import the java.util.list interface, and here we can add list, we add 10, then we add 20, and then we print out. So arrays dot toString and list dot toArray. This is how we can print out. In this lecture, we are going to talk about unbounded wildcards. So unbounded wildcard type is specified using the wildcard character or the question mark. This is called a list of unknown type. Unbounded wildcard can prove to be useful when writing a method which can be employed using functionality provided in object class, or when the code is using methods in the generic class that don't depend on the type parameter. So for example, we have a public static void print all method that's going to get a list of unbounded type. It's going to be the list. Of course, we have to import the java.util.list interface, and here we can iterate through the object item in the list, and we can print out the items one by one. So if we have a list of integers, list 1 is a new array list, we can add items, for example 10, then we can add 20, we can add 30, and then we can call this print all method. So if we call this print all on the list 1, then we just have to save it and run it, and as you can see, it is working fine for integers. It is working fine for doubles as well. So if we use 10.0, 20.0, 30.0, then it is going to work fine as well. We can use it on strings. So if we use something like this, of course we have to specify strings, Adam, Kevin, and for example Joe, then we can use the same print all method without any problem. So as you can see, Adam, Kevin, and Joe is going to be printed out. So this is why it can prove to be useful to use unbounded wildcards with the help of the question mark. Thanks for watching. In this lecture, we are going to talk about the collections framework overview. So first of all, what is a collection? A collection is a group of objects contained in a single object. The Java Collections Framework is a set of interfaces, classes, and algorithms for storing collections. Some of the benefits are reduced development effort by using a core collection classes rather than implementing our own collection classes. So for example, if you want to implement a tree-like structure, a red-black tree, or a hash table, of course it is much more convenient to use Java Collections Framework related classes than implementing your own from scratch. Then code quality is enhanced with the use of well-tested collections framework classes. So we can take it for granted that these abstract data types and data structures are working fine and as efficiently as possible. Then reusability and interoperability are very crucial features of the Java Collections framework. So the Java Collections framework includes four main types of data structures: lists, sets, queues, and maps. The collection interface is the parent interface of list, queue, and set. So as you can see, collection is the parent interface of these ones. What's crucial that the map interface doesn't extend collection. So as you can see, the map itself is not a collection. Although maps are not collections in the proper use of the term, but they are fully integrated with collections, and this is why it is considered part of the Java Collections framework. So this is crucial that there are four extremely important interfaces and three of them extends the collection interface. Okay, so lists, queues, sets, and maps. A list is an ordered collection of items that allows duplicate entries. Elements in a list can be accessed by an integer index. What is a queue? A queue is a collection that orders its elements in a specific order for processing. What is a set? A set is a collection that doesn't allow duplicate entries. As you can see, a list can have several entries with the same value. It is not true for sets. And a map finally is a collection that maps keys to values. So here we have key value pairs with no duplicate keys allowed. The items in a map are key value pairs. Okay, so this is the exact collection framework related hierarchy. We have the iterable interface as the parent class of collection. Lists, queues, and sets are extending the collection interface. This is what we have been talking about, that the map is not a collection. But as you can see, there are several lists, for example, an array list, linked list, vector, stack. There are several queues such as priority queue, the queue, array the queue. There are several sets, hash set, linked hash set, the sorted set, and the tree set. And there are several options when we want to use the map. For example, we can use a sorted map or a tree map. We can use hash maps, linked hash maps, and hash tables. The red ones are interfaces and all the others are classes. And as you can see, the dashed line refers to implementation, and the arrows when the given interface is extending another interface. Okay, what's crucial that we have the so-called iterable interface. When collection framework was created, it gave a powerful ability to acquire data from collections automatically. This is called iterability. So the ability to iterate through the collections one by one, and this is why it is needed to extend the iterable interface to the collection interface. So as you can see, the parent of collection is the iterable interface. Because of this iterable interface, we can use an iterator method or a for each loop to any kind of collections. So this is how we can iterate through a list, a queue, a set, which is quite a powerful feature. The iteration can only be applied to one-dimensional collections like lists, queues, and sets, but not to maps. You may pose the question why? Because iterator uses the indices of items and map doesn't support indices but key value pairs. So map can be iterated and hence can extend collection, which further extends iterable. So this is the reason why maps are not collections. Okay, let's talk about collection framework's useful methods. Another advantage of the collection interface that it contains useful methods for working with lists, sets, and queues. These methods can be familiar because we already talked about these in the previous lectures. What's very good that they can be used not only for array lists but also for other data structures or abstract data types such as lists, sets, and queues. These methods are the odd method, remove method, isEmpty, and size method, clear method, contains method. With the help of the add method, we can insert a new item to the data structure. With the help of the remove method, we can remove a given item from the data structure. With the help of the isEmpty method, we can check whether the data structure is empty or not. The size is going to return the number of items in the data structure. The clear method provides an easy way to discard all items in the collection. And the contains method is going to check if a certain value is present in the collection or not. Let's talk about collection versus collections. Before we look at the different collection classes in practice, here is an interesting but also confusing, tricky interview question about the collection framework. So what's the difference between collection and collections? The main difference is that collection is a root level interface. This is what we have been talking about. Most of the classes in Java collection framework inherit this interface. This is what we have been talking about when considering collection framework related hierarchy, that as you can see, collection is an interface and most of the classes of the collections framework are inheriting this collection interface. As far as collections is concerned, it is a utility class in java.util package which contains only static methods which are used to operate on objects of type collection. So for example, when we try to sort an array list, then we can use collections.sort, which is a static method within the java.util package, and this collections utility class has some extremely important methods. So this is what we are going to talk about in the coming lectures. Thanks for watching. In this lecture, we are going to talk about the concrete implementation of array lists and linked lists. So first of all, what is the crucial differences between array list and linked list? First of all, array list acts as a list, while linked list acts as a list and a queue. So ArrayList use dynamic array in order to store the items, while linked list use doubly linked list to store the items. As far as manipulation is concerned, ArrayList is slow because if any item is removed from the array, all the bits are shifted in memory. It is crucial. So this is why ArrayList is slower if we have to remove several items. While on the other hand, linked lists are faster because it uses a doubly linked list, so no bit shifting is required in memory. We just have to update the references. I'm not sure whether you are familiar with the concrete data structure of array and linked list, but linked lists are basically nodes linked together by references. So whenever we remove a given internal node, we just have to update the references, and this is why linked lists are extremely fast as far as manipulation is concerned. So whenever we insert or remove a given item, array lists are better for storing and accessing items, and linked lists are better for manipulating data. Of course, array lists are faster because it uses a simple one-dimensional array, and the most important features of arrays is that we can use indices. This is called random indexing. So if we know the index of a given item in a one-dimensional array we would like to access, then we can do it in order 1 constant time complexity, which means that array lists are faster in this case than linked lists. So both array lists and linked lists have several advantages and disadvantages as well. Anyways, let's take a look how we can instantiate an array list. We can do something like this. List is an interface, and because array list is a list, we can do something like this. We would like to store strings, so the array list is equals to a new array list. We can do approximately the same with linked lists. So because linked list implements the list interface, this is why we can do something like this. It is a good programming practice to program to an interface and not the implementation itself. Linked list is the class itself. List is the interface. So this is how we can achieve abstraction. Anyways, we can use the same methods in order to add items. So as you can see, ArrayList.add, it means that we would like to add Kevin, Joe, and Peter to the array list. We can do the same with linked list. We add Kate, Judy, and Julia. With the help of the iterator, we are able to consider every item of the data structure on a one-by-one basis. This is what we have been talking about, that as far as collection framework hierarchy is concerned, both ArrayLists and linked lists implement the list interface. The superclass is a collection, which superclass is an iterable, and because of the iterable interface, we can iterate through a list, a queue, and a set. So this is why we can get the iterator, and with the help of the iterator, we can consider all the items of the array list. We can do it with the help of a simple for loop, as you can see. So either we use the iterator, I guess it is a bit more complex to use iterators than using a for loop. I guess it is very simple. We use the linked list, and because it implements the iterable interface, this is why we can use a simple for loop. As you can see, we have to make sure that the types are matching. So because the linked list stores strings, this is why we have to use string here, and this is how we can iterate through with iterator, and we can iterate through with the help of a simple for each loop. So if we run the algorithm, the array list items are Kevin, Joe, and Peter, of course, because we have inserted these. The linked list items are Kate, Judy, and Julia. So as you can see, the array list items are printed out because of the iterator, and the linked list items are printed out because of this for loop. So this is how we can use array list and linked list. Both of these data structures are extremely important and extremely crucial. We use array lists whenever we would like to store and access data. So for example, when we have a database and we don't want to update the database, so we don't want to remove or insert new items. Whenever we would like to manipulate the data frequently, so we would like to remove and insert or update given items, then using linked lists is the best option possible. Thanks for watching. In this lecture, we are going to talk about queues and priority queues. So you can use a queue when items are added and removed in a specific order. Queues are typically used for sorting items prior to processing them. The Java queue interface orders the element in FIFO, so first in, first out manner. In FIFO, first element is removed first and last element is removed last. By the way, this queue is an abstract data type, and linked list, for example, implements the queue interface. For example, when you implement breadth first search, then we need a queue abstract data type, and this is why queues are extremely crucial. Breadth first search is a very important graph related algorithm. What about priority queues? The priority queue class provides the facility of using a queue, but it doesn't order the elements in a FIFO manner. The elements of the priority queue are ordered according to their natural ordering defined by the comparable interface. So basically, with the help of a priority queue, we can define the priority itself. There are several methods such as add, such as remove, such as pull and peek. So the add method is going to add a given item to the queue. The remove method is going to remove a given item from the queue. The peek method retrieves but doesn't remove the head of the queue. And the pull method retrieves and removes the head of the queue. So this is the main difference between peek and pull. So let's see a concrete example. I'm going to create a new class, for example, access card. And every single access card is going to have a string name, and they have an integer ID. So let's create the constructor. So source, generate getters and setters first of all for the ID and the name, and let's create the constructor as well. So source and generate constructor using fields. Okay, this is how we can define the name and the ID. And finally, I would like to define the toString method. So let's override the toString method. And here we just have to return this.name plus some spacing and this.id. So every single access card has a name and an integer ID, and we can use a priority queue. And because a priority queue implements the queue interface, we can do something like this. First of all, we have to import java.util.queue, and we can use access card, okay. it's going to be the queue, and it's going to be a new priority queue. So the main problem is that if we try to add a new access card, let's try to do so with name, for example, card1, and the ID is going to be 5 whatever. In this case, Java is not going to know that what's going to be the priority of the access cards. So this is why we have to make sure that this class implements the comparable interface, and we are going to compare two access cards. So in order to be able to compare two access cards, this is why we have to override the compare to method. This compare to method In this lecture, we are going to talk about the array-the-queue data structure. ArrayDoQ in Java provides a way to apply a resizable array in addition to the implementation of the doQ interface. It is also known as Array Double-Ended Queue or ArrayDoQ. This is a special kind of array that grows and allows users to add or remove items from both sides of the queue. What's crucial that it is not thread safe, so if you have a multi-threaded application where several threads can manipulate and update the given ArrayDoQ data structure, of course ArrayDoQ is not a good option because it is not thread safe. There are several methods such as add, offer, remove, peek and poll. These methods are the same as we have discussed with priority queue. What's crucial that here we have several additional methods: add first, add last, remove first and remove last, which means that we are able to manipulate both sides of the array. The add first method inserts particular item at the beginning of the queue. Add last is going to insert a particular item at the end of the queue. The remove first method returns the first item and also removes it. The remove last returns the last item and also removes it. So these are the most important methods as far as ArrayDoQ data structure is concerned. So let's take a look at a concrete example. We have the doQ interface. We are going to store integers, so it's going to be the doQ is a new ArrayDoQ. Sorry for that, of course, integer as the wrapper class. And here we can use several methods. For example, as you can see, we have the add method that's going to add the given integers. So in this case, just for demonstration purposes, let's add 1, 2, and 3. Then because doQ is an iterable, this is why we are able to use a for each loop integer number in the doQ, and we are able to print out the value. So we are able to print out the number. So this add method is going to add the values one by one, 1, 2, and 3. This is why we can use, for example, the doQ.offer first. This offer first is going to insert a specific item at the front of the doQ. So if we use this, then we are able to insert 0, and then we are able to insert -1 as well. So in this case, if we run the application, then first of all we have 1, 2, 3, but because of the offer first method, we are able to insert 0 and -1 at the beginning of the doQ. Of course, we are able to do the same. So the doQ, we have the offer last. In this case, it is going to insert the item to the end of the doQ. So if we run the application, as you can see, 4 is going to be the last item. Another important method is the remove first and remove last. So we have the doQ remove last. If we call this remove last method, then the last item is going to be removed, which is the 4. So as you can see, 4 is not present here. We are able to remove the first item. So if we remove the first item, then -1 is the first item, so it's going to be removed. As you can see, it is working quite fine. This is how we use the built-in methods of ArrayDoQ data structure. Thanks for watching. In this lecture, we are going to talk about hash sets, linked hash sets, and tree sets. So you use a set when you don't want to allow duplicate entries. So this is the main motivation behind sets. We don't want to allow duplicate entries. Both of the sets are not synchronized. So it is crucial that if you use a multi-threaded application and you want to manipulate the same data structures, hash set, linked hash set, or tree set, then you have to make sure that you use some synchronization because these data structures are not synchronized by default. There are several standard methods such as adding a given item, removing a given item, checking whether a given item is present in the data structure or not. What's crucial that a hash set uses a hash table as an underlying data structure. So a hash set stores its items in a hash table, which means that it uses the hashcode method of the object to retrieve them more efficiently. Hash set is the most commonly used data structure as far as sets are concerned. A linked hash set is used when you want to store items by the insertion order, and the tree set stores the items in its sorted order. Basically, the tree set uses a red-black tree as an underlying data structure that has quite favorable running time complexity, and it supports the sorting operation, which means that tree set is a sorted tree-like data structure. Okay, but because of the sorted order, tree set is slower than a hash set. So let's take a look at a concrete example. Because all of these data structures implements the set interface, we can use something like this. I would like to use integers, so integer hash set is equals to a new hash set. This is what we have been talking about, that a hash set relies heavily on a hash table under the hood. Okay, let's import java.util.set. And we are able to add given items. So I would like to add the integer 10. Then I would like to add, for example, 20, 30, and 40. We can check whether the hash set contains a given item or not. So hash set dot contains the value 10. Of course, we should get a true because 10 is present in the data structure. But for example, 100 is not present, so this is why we get a false. Of course, we can remove a given item. So if we use something like hash set dot remove and we specify the item, we are able to remove the value 10. Because the set interface is a collection and the collection is an iterable interface, this is why we are able to use a for each loop and iterate through all the numbers. So we can use something like this and we can print out the number. So if we iterate through all the values, as you can see, hash set doesn't maintain any order. 20, then 40, then 30. So it has nothing to do with the order in which we inserted the given items. So this is why hash set is not going to maintain the insertion order. Okay, so let's try to use a linked hash set instead of a hash set. So if we use a linked hash set, we have to import java.util.linked hash set. If we use a linked hash set, then if we consider the items one by one, then it is going to be the order in which we have inserted the given item. So in this case, 10, 20, 30, and 40 is going to be the order, which means that a linked hash set maintains the order in which we insert the given items. The problem with linked hash set is that we are not able to get the sorted order. So if we insert, for example, 100, then 22, then 3, then 40, I'm going to insert some further items, 51, then 29, and we would like to end up with the sorted order. We are not able to do it with the help of hash set and linked hash set. And this is why if we use a tree set, then it is going to make sure that the items we insert are going to be in a sorted order. Okay, so let's import it, and if we iterate through the items, as you can see, it is the numerical order, which means that 3, 22, 29, 40, 51, and 100 tree set maintains a natural order as far as the items are concerned. But because a tree set is way slower than a hash set, a good approach is to use a simple hash set. And whenever we would like to end up with the sorted order, then we can create a set integer sorted set is a new tree set. And here in the constructor, we can specify the hash set. And Java is going to generate a tree set based on the hash set items. And if we iterate through the sorted set, then again it's going to be the sorted order. So it is a bit better approach because a hash set is way faster than a tree set. If we are after the sorted order, then we can transform a hash set into a tree set, and if we iterate through all the values, then it is going to result in the natural ordering. So this is how we can use hash set, linked hash set, and tree set. Thanks for watching. In this lecture, we are going to talk about hash maps, hash tables, linked hash maps, and tree maps. So a map can store pairs of key values. So each key is linked to a specific value. Once stored in a map, you can later look up the value using the key exclusively. So basically, with the help of a given hash function, we are able to transform keys into array indices because maps are using a one-dimensional array as an underlying data structure. And with the help of the hash function, the keys are transformed into array indices, and the given array index is going to store the value itself. So every key is associated with a given value. This is why a map is able to store key value pairs. A hash map doesn't allow duplicate keys but allow duplicate values. Hash map is not thread safe. On the other hand, a hash table is thread safe. This is why hash tables are slower than hash maps. So the most popular data structure as far as maps are concerned is hash map. Okay, it is not synchronized, but it is quite fast. It uses less memory, and this is why usually it is the best option possible. A linked hash map preserves the insertion order. So again, hash table and hash map is not going to preserve the insertion order. A linked hash map, on the other hand, does. And tree map stores the keys in a sorted tree structure. Again, a tree map uses a red-black tree as an underlying data structure that has quite good running time complexity as far as the operations are concerned. The main benefit is that the keys are always in sorted order. There are several important methods. With the help of the put method, we are able to insert a given value associated with a given key. With the help of the get method, we are able to get a value based on a given key. The size is going to return the number of items in the data structure. The clear method is going to remove all key value pairs. The entry set is going to return a set that contains the entries in the map. So let's take a look at a concrete example. Because all of them implements the map interface, we are able to program to an interface. In this case, we will use integers as keys and we will use strings as values. This is what we have been talking about, that a map stores pairs of keys and values. Keys are integers, values are strings. In this case, the map, and it's going to be a new hash map. Okay, so we have to import java.util.map. And we are able to insert, with the help of the put method, a given ID as the key and given value. The value is going to be the name, the key is going to be an ID. So let's insert these values: Adam, Joe, Tom, Adam, Kate, and Judy. This is what we have been talking about, that with the help of a hash map, it is possible to have duplicate values. What's not possible is to have items with the same key value. But as you can see, it is no problem to have the same value associated with different key values. So if we want to iterate through a map, we have to use map.entry, and we have to define that it's going to be an integer and string as the value. These are going to be the entries, so it is an entry. And we have to use the entry set. So this entry set is going to return a set, as you can see. So returns a set view of the mappings contained in this map. Okay, so let's get the entry set, and here we are able to print out the entry get key plus some spacing and the entry get value. So this entry stores the key and the value as well. So if we save and run it, as you can see, it is working fine, but the order is not maintained. So this is not the same order as we have inserted the given items. If we use a linked hash map, then Java is going to maintain the order in which we have inserted the given items. So in this case, if we run it, as you can see, the first item is the first one we have inserted, then the second one, the third one, fourth one, and so on. So with the help of a linked hash map, we are able to maintain the order. But again, how are we able to get the sorted order? So we would like to sort these values based on the key, so the first parameter. And this is why tree hash map is very, very powerful because with the help of, sorry for that, tree map, not tree hash map, but tree map, this tree map is going to maintain a sorted order as far as the key values are concerned. So if we use something like this, as you can see, it is the sorted order as far as the key values are concerned. So 1, 10, 30, 90, and 155. Of course, if we insert a given item with a previously used key value, then the given entry is going to be updated. So as you can see here, we have Kate, but this has been updated to Judy, and this is why we have Judy associated with the integer 10. So this is how maps work. Hash map is quite fast, so this is the most commonly used data structure as far as maps are concerned. With the help of linked hash map, we are able to preserve the insertion order, and with the help of the tree map, we are able to end up with the sorted order as far as the keys are concerned. Thanks for watching. In the coming lectures, we are going to talk about nested classes. So first of all, what are nested classes? A nested class is a class that is defined within another class. They enable you to logically group classes that are only used in one place. Thus, this increases the use of encapsulation, create more readable, maintainable code, and it requires less code to write. So basically, it has something to do with code optimization. There are 4 types of nested classes. A nested class that is not static is called an inner class. So this is why there are nested classes such as static nested class and non-static nested classes or inner classes. And there are 3 types of inner classes: member inner classes, local inner classes, and anonymous inner classes. First of all, let's talk about the member inner class. A member inner class is a non-static class that is created inside the class but outside the method. As you can see, this inner class is within an outer class, but it is outside the scope of a method. So member inner class is accessing the instance variable member of the outer class. So this is why a given method, such as the inner method that belongs to the inner class, can use the instance variable that belongs to the outer class. So in this case, within the inner method, we can modify instance variable. If you want to instantiate an inner class, first you must create the instance of the outer class. So this is why we have to instantiate the outer class, and after we instantiated the inner class, we are able to call the method that is associated with the inner class. Okay, so after that an instance of inner class is created inside the instance of the outer class, you can access the method inside the inner class. So this is how we can deal with a member inner class. What about a local inner class? Local inner class is a non-static class that is created inside the class but inside a given method. The inner class can access the instance variables of the outer class. So as you can see, we have the outer class, we have an instance variable integer instance var, and we have a given method, outer method, and within the method we can define another class, the so-called inner class, that can have as many methods as we want. And this method, for example, In this lecture, we are going to talk about local inner classes. So a local inner class is a non-static class, as we have discussed in the previous lecture, that is created inside the class. So I'm going to create a new class, outside class, and within the outside class, we will have an instance variable, a private string message is equals to this is a message instance variable. Okay, so this is the string itself. And here we can define a method, public void author method. And here within a given method, we are able to define a class. The name is going to be inner class. And the inner class is going to have a public void show message method that's going to print out the message itself. And as you can see, the inner class is able to access the instance variable of the outside class. So I'm going to get rid of the unnecessary white lines. We are able to instantiate an inner class. It's going to be the inner class like this. And we are able to call this show message. So whenever we save it and in the application.java, we are able to instantiate the outside class. So outside class is a new outside class. And if we call the method author method, then we can call it without any issue. Of course, in this lecture, we are going to talk about member inner classes. So a member inner class is created within a class and outside a method. So if we create an outside class and we create a private instance variable, for example, a string, message is equals to hello world, then we are able to create an inner class, so class inner class. Within the inner class, we are able to create a public void show message method that's going to print out the message itself. So as you can see, again, if we create an inner class within an outside class, then the method associated with the inner class is able to access the instance variable that belongs to the outside class. So this is why we are able to print out the message. And as you can see, this message is an instance variable. It has nothing to do with the inner class. So if we want to instantiate an inner class, first we have to instantiate the outside class. So outside class is a new outside class. And then we are able to instantiate the inner class. So this is the In this lecture, we are going to talk about static nested classes. So a static nested class is created within a class as usual, and it is a static class that is defined at the same level as static variables. So it can access static instance variables exclusively, and what's crucial that nested class can be accessed without instantiating the outer class. So if we have an outside class and we have a private string message as usual, for example hello world, and we have a static inner class, so static class nested class, and we have a public void show message method that's going to print out the instance variable message. In this case, we are not able to do so. This is exactly what we have been talking about, that a static nested class is not able to access private instance variables. We have to make the instance variable static, and as you can see, if the message is static, then we are able to print it out within the nested class. So this is the first crucial part, and the second important thing is that we are able to instantiate the static inner class without instantiating the outside class. So we can do something like outside class dot nested class. Nested class is equals to a new outside class dot nested class. So if we do something like this, then we are able to access the methods within the nested class, such as the show message method. And if we save and run the application, as you can see, the static instance variable, so the hello world, is going to be printed out with the help of the static nested class. So what's crucial is that a static nested class can access static field variables exclusively, and we are able to instantiate a static nested class without the need of instantiating the outside class first. So it is a powerful feature of static nested classes. Thanks for watching. In this lecture, we are going to talk about anonymous inner classes. So I'm going to create an abstract class, which is going to be an abstract class. It's going to be, sorry for that, not a public class, but abstract class, okay. And here I'm going to define an abstract public method, void show message. It's going to be the show message abstract method. Okay, and in the application.java, we are able to instantiate this abstract class. So a class is a new abstract class, and as you can see, you are not able to instantiate an abstract class without implementing the given method we have specified here. So because we have specified the show message method, this is why we have to make sure that whenever we instantiate the abstract class, we have to implement it here. So if I try to do something like this, that we instantiate the abstract class, of course we are not able to do so. We cannot instantiate type abstract class. So this is why we have to instantiate as an anonymous inner class, and we have to define the show message. So here this is a message, and we are able to use this instantiated abstract class, so a class dot show message. So as you can see here, we are able to call the method we have defined here. So if we save and run it, of course, this is a message. It's going to be printed out because we instantiated the abstract class and we have to define and override the show message method. And then we called a class.showMessage, which is going to print out this is a message. So this is how we are able to instantiate an abstract class, and this is called anonymous inner class, because here, after instantiating, we have to override and we have to define the method we have specified in the abstract class. We can do the same with a given interface. So abstract interface, here we can define the public void show message method, and because it is an interface, again, we are not able to instantiate an interface in Java. So if we do something like abstract interface, a interface is a new abstract interface. Of course, we are not able to instantiate it, so if I do something like this, it's going to be a compile time error. We cannot instantiate an interface, but we are able to instantiate it as an anonymous inner class. So as you can see, again, we have to override the method we have specified in the abstract interface. So because we have a public void show message, this is why we have to override this method. If we have more than one method, so for example, show message and send message, then in this case we have two methods in the interface, which means that if we instantiate the interface as an anonymous inner class, then we are able to show the message, so showing the message, and we override the send message as well, sending the message ... So again, we can use this interface, so a interface, and we can call the show message and we can call the send message methods as well. So if we save it and run it, then showing the message and sending the message are going to be printed out. So these are called anonymous inner classes when we try to instantiate an interface or an abstract class and we have to override the methods we have specified in the given interface or in the given abstract class. So that's all about anonymous inner classes. Thanks for watching. In the coming lectures, we are going to talk about exceptions. So first of all, what is an exception? Java uses exceptions to handle errors and other exceptional events. When an error occurs during the code execution, Java will normally stop and generate an error message. The technical term for that is Java will throw an exception, which means that Java will show an error message. One of the aims of the exception handling mechanism is to handle the runtime errors so that the normal flow of the application can be maintained. So for example, if we try to divide a given integer by 0, then there's going to be an arithmetic exception because we would like to divide the given integer by 0. And this is why the rest of the code is not going to run. So it is an arithmetic exception. This is why it is a good programming practice to use try-catch blocks that can handle exceptions. If we use try and try to divide the integer 22 by 0, it is going to result in an arithmetic exception, but as you can see, we can catch the arithmetic exception, and this is why the normal flow of the application can be maintained. Okay, there's going to be an arithmetic exception because we would like to divide by 0, but the rest of the code is going to run, as you can see. So this is the main difference between not handling the exception and handling the exception. If we do not use a try-catch block and we do not deal with exceptions, then the application may freeze. Okay, so let's talk about try, catch, and finally blocks. The try statement allows you to define a block of code to be tested for errors while it is being executed. The try block must be followed by either catch or finally. The catch statement allows you to define a block of code to be executed if an error occurs in the try block. It can be followed by a finally block later, and the finally block is used to execute the important code of the program. It is executed whether an exception is handled or not. So first we have the try block. In the try block, there's going to be the code that may throw an exception. For example, we divide a given integer by 0 or something like this. In the catch block, we are able to catch a given exception. So this is where we handle the given exception, and the finally block is always executed, whether the exception is handled or not. So this is why it is useful to have the finally block, because we can take it for granted that these lines of codes are going to be executed no matter what. What's the difference between the throw and the throws keyword? The throw keyword is used to throw an exception. This statement is used together with an exception type, for example, an arithmetic exception, a class not found exception, array index out of bound exception, or something like this. So for example, if we have a method check age that's going to get an age as a parameter, and if the age is less than 18, we are able to throw a new arithmetic exception with the error message not valid age. So with the help of the throw keyword, we are able to throw an exception. On the other hand, the throws keyword indicates what exception type may be thrown by a method. Static void check age integer age throws arithmetic exception. It indicates that arithmetic exception may be thrown within the given method. And this is exactly what's happening here, that if the age is smaller than 18, then we throw a new arithmetic exception. So this is the main difference between throws and the throw keywords. Let's talk about compile time exceptions and runtime exceptions. A checked exception is checked by the compiler at compilation time. This is why it is called compile time exception. The programmer should handle these exceptions such as IO exception, SQL exception, and something like this. Unchecked exception is an exception that occurs at the time of execution. These are called runtime exceptions such as arithmetic exception, null pointer exception, and so on. By the way, it is an extremely good programming practice to reduce all runtime exceptions to compile time exceptions, because compile time exceptions have to be corrected by the software engineer, and it is known in compilation time. On the other hand, runtime exceptions are usually hard to debug, so it is quite hard to find, for example, why a null pointer exception is happening. So this is why we prefer compile time exceptions. And what about errors? Problems arise beyond the control of the user or the programmer. Errors are generated by the runtime environment, such as out-of-memory error, virtual machine error, so these are errors. And if we take a look at the exception hierarchy, the throwable is an object in the java.lang package, and exceptions and errors are throwable. But an exception can be a runtime exception or a compile time exception. So exceptions under error and runtime exception classes are so-called unchecked exceptions. Everything else under the throwable is checked exceptions. What's crucial that we can use multiple catch blocks. A try block can be followed by one or more catch blocks. Each catch block must contain a different exception handler. So if you have to perform different tasks at the occurrence of different exceptions, then we can use multiple catch block. So for example, we have a code that may throw several exceptions, and we are able to catch all of them. We can catch the arithmetic exception, which means that if there is an arithmetic exception in the try block, then this line of code is going to be executed. We can catch a number format exception. So whenever there's a number format exception in the try block, then this line of code is going to be executed. So we are able to catch multiple exceptions. We are able to use nested try blocks, so exception handling can be nested. It can prove to be very useful when methods are used in a catch or finally block that also throws exceptions. So we have a try block, and within the try block we have an inner try catch block again. We can catch a runtime exception, and then we have a catch block for the original try block. Okay, so we are able to nest try catch blocks. And finally, let's talk about exception handling and method overriding. An overriding method, the method of child class, can throw any unchecked exceptions regardless of whether the overridden method, so method of the parent or superclass, throws exceptions or not. However, the overriding method shouldn't throw checked exceptions that are new or broader than the ones declared by the overridden method. The overriding method can throw those checked exceptions which have less scope than an exceptions declared in the overridden method. Simply put, subclasses can throw fewer checked exceptions than their superclass, but not more. In the next chapters, we are going to take a look at multiple exceptions, nested try-catch blocks, exception handling with method overriding, and so on, so it's going to be clear. Thanks for watching. In this lecture, we are going to take a look at a concrete example as far as try-catch blocks are concerned. So we instantiate a scanner class that's going to take an input from the user. So if we run the application, this scanner is going to ask for a given number, and we are able to give a given number, for example 2, and this is what the scanner does under the hood, that it is waiting for an input from the user. And then we have try-catch blocks. As you can see, first of all, in the try block, we print out that give me a number. Then the scanner is asked for a given integer, and it is going to parse that given integer. And then we are going to divide 20 by that given integer the user provides. And then we catch given exceptions. For example, we catch the arithmetic exception, because if we rerun the algorithm and we give 0, then of course we are not able to divide 20 by 0, so Java will catch arithmetic exception. So if we hit enter, as you can see, Java will throw an arithmetic exception. And as you can see, the arithmetic is the one we have printed out, and then the exception is this exception, the arithmetic exception. The user tried to divide by 0, so this is the arithmetic exception. And what's crucial, that because we use a try-catch block, this is why more code is going to be executed. So if we get rid of the try block and we do not use any try-catch block, then in this case, if we save and run the algorithm and provide 0, as you can see, there's going to be an exception and the application is going to be terminated. So because there is an exception here, these lines of codes are not going to be executed. So this is why it is advisable to use try-catch blocks, because we can make sure that the application is not going to freeze. We can catch a given exception and then we can execute more operations. So that's all about arithmetic exception. What if we run the application and we provide a letter? So instead of an integer, we are going to provide the letter A. Of course, Java is not able to parse the letter A as an integer, so it's going to be a number format exception, because the input is a string, but then we try to parse that given string as an integer, and this is why the number format exception is going to be thrown. So we print out number format exception here, as you can see, but after that the application continues, as you can see, so we print out more code. So this is why it is extremely powerful to use try-catch blocks, because we can make sure that the application is going to run despite the fact that there is a given exception. So this is how we can catch arithmetic exception, and this is how we can catch multiple exceptions, so number format exception besides arithmetic exception. So this is how we can use try-catch with multiple catch blocks. Thanks for watching. In the previous lecture, we have been talking about how to use multiple catch blocks. In this lecture, we are going to talk about how to use nested try-catch block. So as you can see, we have a try block, and within the try block, we create a one-dimensional array of integers, and then we create another try-catch block because we try to divide one of the items of the one-dimensional array by 0. So this division is going to be handled by this exception, and everything else is going to be handled by the outer catch block. So here, if we try to access the item with the index 9, of course it's going to be resulted in an array index out of bound exception. So if we run the application, then we get an element at such index doesn't exist. So this is what we print out here, and as you can see, the application doesn't freeze, so it is going to be printed out as well. So this is when we try to access an item with an index that's outside the scope of the one-dimensional array. Okay, so this is the first exception. As you can see, after this exception, Java is not going to consider the second try-catch block. It is going to catch that given exception, and then it is going to run the other operations. So if we comment it out, then there's going to be a division by 0 exception, and it is catched by this block, so arithmetic exception. So we print out arithmetic exception, division by 0 is not possible, and as you can see, after that Java is going to execute other operations. In this case, we just print out that the application doesn't freeze. So what's crucial that if there is a single exception like here, so this is the first exception, then Java is not going to consider other part of the application. It is going to catch that given exception and continue with the application. So this is why if you run it, we are not going to get two exceptions, one because of the index array out of bound exception and one because of division by zero. In this case, if there is a given exception, then Java will catch that exception without running other parts of the code. Thanks for watching. In this lecture, we are going to talk about exception handling when dealing with inheritance. So we will have a parent class. The parent class have a public void method and a child class extending the parent class. So in the child class, we are able to override the method itself. So as you can see, it's going to be the overridden method we have defined in the parent class. And in this case, if the parent class method doesn't throw a given exception, then we are not able to do so here. So here in the child class, we are not able to throw, for example, an IO exception because in the parent class, we haven't specified that this method throws this IO exception. So as you can see, it is a typical case of a compile time error that exception IO exception is not compatible with throws closing parent class method. If the parent class throws a IO exception, then of course it is going to be fine. So as you can see, there is no compile time error at all. We can do that in the parent class, it throws an exception, and because all other exceptions are an exception basically, this is why it is going to work fine as well. So as you can see, there's not going to be any problem here. We are able to print out that this is the child class. So this is why we can say that if the superclass doesn't declare any exception, then the subclass can only declare unchecked exceptions, but not the checked ones. So for example, if the parent class doesn't throw any exception, then of course we are not able to throw IO exception in the child class. But we can do something like array index out of bound exception is an unchecked exception, or for example, null pointer exception is an unchecked exception. So child class is able to throw unchecked exceptions, but it is not able to throw checked exceptions such as IO exception, or for example, class not found exception, I guess, again, it is a checked exception. So we have to make sure that in this case, the parent class either throws a class not found exception, it is going to work fine, or we have to make sure that the parent class is going to throw the given exception that's the parent class of the class not found exception. So this is why we can say that it throws an exception and it's going to work just fine. So this is a rule of thumb that if the superclass doesn't declare an exception, then the subclass can only declare unchecked exceptions but not the checked exceptions. If the superclass declares an exception, then the subclass can only declare the child exceptions of the exception declared in the superclass. So simply put, subclasses can throw fewer checked exceptions than their superclasses. So this is why we have to make sure that we are dealing with inheritance, that the given class extending the parent class, then we have to make sure that these exceptions are matching and there's not going to be any compile time errors. Thanks for watching. In this lecture, we are going to talk about the differences between the final keyword, the finally keyword, and the finalize keyword. So we are going to take an overview of three already known Java keywords: final, finally, and finalize. While these keywords resemble each other, each has a very different meaning in Java. Many people are confused about this topic, so it's worth summarizing it. Okay, so we have the final keyword, we have the finally block, and we have the finalize method. First of all, final is a keyword. The variable declared as final should be initialized only once and cannot be changed. So if we do something like this, that final integer I is equals to 10, and if we try to modify the value of I, then it's going to be a compile time error because this variable is final That's why we are not able to change the value. So first of all, we can declare a variable to be final. Then we are able to use the final keywords as far as classes are concerned. So Java classes declared as final cannot be extended. Methods declared as final cannot be overridden. So we can use the final keyword for variables, for classes, and for methods as well. Putting final in front of a field, a variable, or a parameter means that once the reference has been assigned, then it cannot be changed. So this is the final keyword. What about the finally keyword? Finally is a block as far as exception handling is concerned. So the finally block always executes when the try block exits. This ensures that the finally block is executed even if an unexpected exception occurs. But finally is useful for more than just exception handling. It allows the programmer to avoid having cleanup code accidentally bypassed by a return, continue, or break. So this finally code is going to be executed no matter what. Putting cleanup code in a finally block is always a good programming practice, even when no exceptions are anticipated. So that's all about the finally block. And the finalize is a method as far as garbage collection is concerned. So before an object is garbage collected, the runtime system calls its finalize method. You can write system resources release code in the finalize method before getting garbage collected. So as you can see here, a given class can have a finalize method. As finalize is a method and not a reserved keyword, so we can call finalize method explicitly, then it will be executed just like normal method call, but object won't be deleted or destroyed. So these are the crucial differences between the final keyword, the finally block, and the finalize method. Thanks for watching. In the coming lectures, we are going to talk about object-oriented programming. So, as we learned earlier, object-oriented programming is a methodology to design a program using classes and objects. Object-oriented programming concepts make it possible to reuse code without creating security risks or making a Java program less readable. It allows us to create specific interactions between objects. So these are the main characteristics of object-oriented programming. A class is basically a blueprint from which you can create an individual object. So when we instantiate a given class, this is when we end up with a given object. The object is an entity that has state and behavior. An object can be defined as an instance of a class. And this is what we have been talking about as far as memory management is concerned, that whenever we instantiate a class, we create an object on the heap memory. So every object is present on the heap memory. Okay, so there are four main principles of object-oriented programming: inheritance, polymorphism, abstraction, and encapsulation. So first of all, let's talk about inheritance. When one object takes all the properties and behaviors of a parent object, it is known as inheritance. When you inherit from an existing class, you can reuse methods and fields of the parent class in the child class. So the parent class is the superclass, the child class is the subclass. You may pose the question that why is it good? Because it provides code reusability and it provides code readability. So for example, we have a parent class with a protected string field name and a public void method. Then in the child class that extends the parent class, we can reuse the methods and fields of the parent class. Of course, new methods and fields can be defined as well, but what's crucial that we can achieve code reusability. So this is inheritance. What about polymorphism? This concept refers to the ability to perform a certain action in different ways. It can take two forms. We have method overriding. It occurs when a child class overrides a method of its parent. A method overloading happens when various methods with the same name are present in a class. So method overriding is called runtime polymorphism when we have a protected void method and in the child child class, we are able to override that given method. This is called runtime polymorphism. And we have the compile time polymorphism, basically method overloading, when we can create the same method with different parameters. So this is called method overloading. And the objectives are that it provides code flexibility and better implementation of inheritance. Okay, what about abstraction? It hides complexity of data and shows only the relevant information, gives flexibility to programmers to change the implementation of the abstract behavior. There are two ways to achieve abstraction, with the help of abstract classes or with the help of interfaces. It provides flexibility of implementation, code readability, and multiple inheritance. So we can use abstract classes and we can use interfaces in order to achieve abstraction. What about encapsulation? Binding or wrapping code and data together into a single unit are known as encapsulation. It restricts direct access to data members, so field variables of a given class. You can implement encapsulation in Java by keeping the fields or class variables private and providing public getters and setters. So with the help of getters and setters, we are able to manipulate these variables. Why is it good? Because it provides code readability and data protection. So for example, we have a given class encapsulated class with a given field variable, the private string name, and with the help of getters and setters, we are able to return the name and we are able to change the value of the name variable. So this is called encapsulation. So these are the four pillars of object-oriented programming. In the coming lectures, we are going to talk about inheritance, polymorphism, encapsulation, and abstraction on a one-by-one basis. Thanks for watching. In this lecture, we are going to talk about the concrete implementation of inheritance. So for example, we have a parent class, so the parent, and we have a child class, so we have a child, and the child is able to extend the parent. This is called inheritance, which means that if we define a given protected void method, and for example, it's going to print out that this is a method of the parent class, okay, and we are able to call this method from the child class. So if we search for the method, as you can see, we can override a method that's present in the superclass. What's crucial that if we make this method not protected but private, then the child class is not able to override it. So as you can see, the method of type child must override or implement a super type method. So in this case, we are not able to override the method we have defined here in the parent class. So this is why it needs to be protected. Okay, so in this case, we are not going to override, but we are going to create a protected void child method, and it's going to print out that method in the child class or something like this. So as far as the parent class is concerned, this is the method of the parent class, and sorry for it, it's going to be a parent method. So we are able to do something like this, that we instantiate a child is equals to a new child, and here we are able to call the child.parent method. So as you can see, because the child class extends the parent class and the parent class has a protected parent method, this is why if we instantiate the child, then we are able to call the parent method, and of course we are able to call the child method. So if we save and run the application, this is a method of the parent class and this is a method in the child class. So this is called inheritance, that the child is going to extend the parent class, which means that the child is going to inherit the methods and the instance variables of the parent class if we declare it to be protected. Okay, so this is inheritance. We can define multi-level inheritance. So if we create a new class, grandchild, and it extends the child, then because the child extends the parent, we can say that the grandchild extends the parent as well. So here we will have a protected void grandchild method, and we print out that method in the grandchild class. And if we instantiate this grandchild, so in the application we can instantiate the grandchild, so grandchild, grandchild, new grandchild, then we are able to call the method of the child, we can call the method of the parent, and we can call the method of the grandchild. So if we save and run the application, this is what's happening here. Method in the child class, this is a method of the parent class, and a method in the grandchild class. So of course we can call this grandchild method because we instantiated a grandchild object. But what's crucial, that because the grandchild extends the child and the child class extends the parent, that's why we can access the parent related method after instantiating the grandchild. So this is called multi-level inheritance, that the child extends the parent, the grandchild extends the child, and this is why the grandchild is basically a parent as well. So this is why it is able to access the methods defined in the parent class. So this is called single level inheritance, or just inheritance. This is called multi-level inheritance. We can do the same with interfaces. So if we have a interface 1, we have another interface, so interface 2, and we have a third interface, interface 3, then we can say that the interface 1 has a method public void interface method 1. So this is the method we define in the first interface. Then we can do the same with interface 2, of course, interface method 2. And then we can say that the interface 3 extends the interface 1 and interface 2. And basically this is the reason why interfaces are extremely crucial, because we are not able to extend multiple classes. So for example, if the grandchild tries to extend the child and the parent, then there is no multiple inheritance in Java. So we are not able to extend multiple classes, but we are able to extend multiple interfaces. So this is why if we have interface 1, interface 2, and interface 3 extends the interface 1 and the interface 2, then it is going to work just fine. So if we have another class, for example, multiple interfaces, okay, with some typo, sorry for that. Anyways, what's crucial, that if it implements the interface 3, then we have to override the methods we have defined as far as interface 1 and interface 2 are concerned. Why? Because interface 3 extends these interfaces. So this is why we have to deal with the methods defined in interface 1 and the methods defined in interface 2. So this is why we have to override these methods. So I print that this is coming from interface 1 and this is coming from interface 2. So whenever I save it and instantiate a new multiple interfaces like this, then we are able to call the multiple interfaces dot interface method 1 and multiple interfaces dot interface method 2. Why? Because this multiple interfaces class implements the interface 3, but the interface 3 extends interface 1 and interface 2 that contain these methods. So these are the methods we override. So this is how we can achieve multiple inheritance with the help of interfaces, and what's extremely crucial, that we can extend multiple interfaces, while on the other hand a given class is not able to extend multiple classes. So this is why interfaces are extremely crucial. And of course, a given class is able to extend the given class and implement a given interface. So if I create a new class, hybrid class for example, then it is able to extend the parent class and it is able to implement the interface 3. So in this case, of course, we have to override the interface method 1 and interface method 2 because of this interface. And we are able to use the methods we have defined in the parent class. So the parent class has the protected void parent method. So this is why in the hybrid class, we are able to override the parent method. So I'm going to print out that this is the parent method. Okay, here we print out that interface method 2, and here we print out that interface method 1. Okay, so if I save it and in the application I instantiate a hybrid class, okay, is equals to a new hybrid class, and we are able to call the methods we have defined. The interface method 1, we are able to call the interface method 2, and we are able to call the method we have defined in the parent class. As you can see, the parent method. So if I save it and run it, then these are the methods we have defined. So this is how we can achieve inheritance with the help of classes and with the help of interfaces. Thanks for watching. In this lecture, we are going to talk about polymorphism. So I'm going to create 3 classes. The first class is the child class. The second class is the parent class. And we are going to use another class, the so-called grandchild. And the parent is going to have a protected integer h parameter, which is equals to 50. And it has a protected void travel method. And we print out that parent is traveling. Okay. We have the same methods and same variables here. So we have protected integer age is equals to 10. And we have a protected void travel method. Here we print out that grandchild is traveling. Okay, and we have approximately the same here. We have a protected integer age is equals to 30, and we have a protected void travel method again. So we print out that the child is traveling. Okay, so these are the classes we are going to use, and what's crucial that the child extends the parent and the grandchild extends the child. So if we use something like this, because the grandchild extends the child and the child extends the parent, we can say that child is a parent and grandchild is a parent. So we are able to use something like this. Parent P1 is equals to a new parent. Of course, we can do it without any issue. But we can do something like this. The parent P2 is equals to a new child. So because the child class extends the parent class, this is why we can instantiate a child as a parent. And because the grandchild extends the child, which is a parent, we can use parent P3 is equals to a new grandchild. So something like this. And we can call the travel method without any problem. So travel and P3 travel. So if we run the application, then parent is traveling, child is traveling, and the grandchild is traveling, which means that, as you can see, the references are all parents. The newly instantiated classes are parent, child, and grandchild, but if we call the same travel method, then the travel method of the parent class is going to be called, the travel method of the child class is going to be called, and the travel method of the grandchild is going to be called. The problem is that in Java we can override In this lecture, we are going to talk about encapsulation. So just to summarize again, binding or wrapping code and data together into a single unit are known as encapsulation. The objective is to provide code readability and data protection. So if we create a new class, for example, person, then we are able to create private field variables. So a private string name and the private integer age. So in this case, we are going to use the person as a wrapper class in order to store the name variable and the age parameter with private access modifiers. So for example, we use a constructor. In the constructor, we do nothing, and we are going to create getters and setters. So we source, generate getters and setters for the age parameter and for the name parameter. So this is how we can create the getters and the setters. And as you can see, basically this is the basic concept of encapsulation. I'm going to override the toString method, and here we return person plus this dot age plus some spacing and this dot name. So whenever we create a new person object, so person p1 is a new person, we can use the getters and the setters in order to set the age, for example 22, and in order to set the name, for example Adam. So if we print out the person object, then the toString method is going to be called. So this is why we have created the toString method. So whenever we print out a given object, then the toString method is called, and the result is a person with age 22 and name Adam. What's crucial that we can do something special here. So for example, we check that if the age parameter is greater or equals than 0, this is when we set the age parameter. This is how we avoid that the user will use a negative value for the age parameter. So in this case, it is going to work exactly the same manner, but if we use -22, then this -22 is not going to be used. 0 is the initial value of integer field variables. So whenever we create a private integer age, then whenever the new class is instantiated, then Java is going to use 0 as the initial value for the integer. So this is why maybe it is not the best solution possible. What's good that if the age is smaller than 0, then we throw a new exception. So in this case, we throw a new illegal argument exception, and we specify that the message is the age parameter cannot be smaller than 0. And else we set the age parameter to be the age parameter. So in this case, whenever we use, for example, 56, then it is going to work just fine. And whenever we use -10, then Java will throw an illegal argument exception that the age parameter cannot be smaller than 0. As you can see, it is a runtime exception because the user provided an age parameter that's smaller than 0. So this is how we can deal with encapsulation. What's crucial that you can implement encapsulation by keeping the fields, so the class variables, private and providing public getter and setter methods. So that's all about encapsulation. Thanks for watching. In this lecture, we are going to talk about encapsulation and mutable objects. So if we create a new class, cars, and this class is going to store a private list of strings, for example, cars. First of all, let's import java.util.list, and then let's create a source, generate getters and setters for the car list of strings. In this case, it is called encapsulation, that we have a cars class that has a private field variable, a list of strings, and we can get the list of strings and we can set the list of strings with the help of getters and setters. So let's create a new list of cars, a new array list, and I'm going to add, for example, Honda cars.add, for example, Ford. Let's add Mercedes And just for demonstration purposes, it's going to be fine. What's crucial that we are able to instantiate the cars class, so a new cars, and of course we are able to set cars and provide this cars list of strings. Okay, sorry for that, we have the same variable name, so it's going to be the cars class set cars. And in this case we are able to iterate through, so strings cars class dot get cars, and we print out the given string. So it is going to work just fine. We instantiated a list of strings, Honda, Ford, Mercedes. We use the setter method in order to inject a list of strings, and we store this list of strings in a private field variable. It is going to work just fine. We iterate through the cars class.getCars, which is a list of strings, and we print out the value. What's crucial that we are able to modify the value of this list. So if we do something like the list of string actual cars is equals to the cars class dot get cars, and we add another value, for example BMW, and then again we iterate through all the values of that given list, then in this case, okay, I use a new line character to be able to separate the results, but as you can see, we have managed to insert a new value, and it is because the fact that lists and array lists are mutable objects, which means that we are able to change the value of the given array list. It is not the same with strings. This is what we have been talking about, that string objects are immutable. We are not able to change the value of a string after we have created it. Lists and array lists, on the other hand, are mutable objects, which means that, as you can see, we have created the given list, we injected into the cars class, and then we get the cars and we updated the list and add another value BMW. And there is no need to call the cars class dot set cars and we specify the actual cars. As you can see, if we do something like this, of course we know for certain that the list is going to be updated. But if we do not do something like this, the list is going to be updated anyways, because lists and array lists are mutable objects. So this is why it is a good programming practice that whenever we get the cars, as far as the cars class is concerned, we are not going to return the actual list, but we are going to return new array list, and here we specify this dot cars. And in this case, what's going to happen? Whenever in the application.java we get the cars, a new array list is going to be returned. So whenever we update the value and we add a new car type to that given list, the list we store here is not going to be changed because we returned a different array list. So in this case, no matter that we add BMW, we rerun the application, and as you can see, the original list hasn't been changed. So this is why we have to be very careful when dealing with lists and array lists, because they are inherently mutable, which means that if we get the given list and we add the new value, then the original list is going to be changed here. So this is why it is a good programming practice that whenever we get the list of strings, in this case the cars, we return a new array list, and of course we make sure that this new array list contains the same values as the original list. But this is how we can make sure that whenever the user updates that given array list, then this change is not going to be reflected in the original list. Thanks for watching. In this lecture, we are going to talk about Java beans. Java beans, or also known as POJOs, so plain old Java objects. Java beans are classes that encapsulate many objects into a single object, the bean itself. Java beans should follow the following conventions. It must implement serializable interface. it should have a public 0 argument constructor. This is called a default constructor, and all properties must be private. So these are the instance variables of the class, and we have to allow access to properties using getter and setter methods. So for example, if we have a class, name is going to be Java Bean example. For example, we have the private string name and the private integer ID of the given bean. We have to make sure that it's going to have a default constructor, so without any argument, and we have to make sure that it is going to have getters and setters. So let's generate getters and setters for the ID and for the name. And I'm going to override the toString methods, so whenever we print out the object itself, then we are going to print out the name and some spacing and the ID. Okay, so let's save it, and in the application.java we are able to instantiate a new Java Bean example, new Java Bean example, and we are able to set the given properties, such as the ID is going to be 1 and the name is going to be Java Bean 1. Okay, so if we print out this Java Bean example, then it is going to work just fine. We have the name and we have the ID. Of course, we should make sure that the class implements the serializable interface. So in this case, it is working fine, but it is not a Java Bean because a Java Bean implements the serializable interface. We are going to talk a lot more about the serializable interface, but as you can see, serializability of a class is enabled by the class implementing the java.io serializable interface. Classes that do not implement this interface will not have any of their states serialized or deserialized. So basically, a given class that implements the serializable interface can be used with streams, for example, or if you want to save the state of a given class, then you have to make sure that the class implements serializable interface. Anyways, what's crucial that beans implement serializable interface, and in the coming lectures we are going to talk a lot more about this interface. So that's all about a Java Bean. A Java Bean implements the serializable interface. It has a default constructor, it has private instance variables, and we have getters and setters in order to get and in order to set the given instance variables. So that's all about Java Beans. Thanks for watching. In this lecture, we are going to talk about interfaces. So originally, an interface could only have abstract methods, but after JDK 8, changes have come, which means that the interface body can contain abstract methods, default methods, and static methods as well. So if we create an interface, for example, modern interface, then here we can define several methods. Let's define a public void abstract method. It is going to be the classic interface method, so the so-called abstract method. But after JDK 8, we are able to define a static method within a given interface. So we have a public static void static method. Okay, and we are not able to use a semicolon because there's going to be a compile time error. This method requires a body instead of a semicolon. So we are able to, just for demonstration purposes, I print out that this is a static method in the interface. ... Okay, so this is how we can define a static method within an interface. So let's use the command static method. And finally, we are able to define a so-called default method. So public default void default method. And again, we have to define the body. So just for demonstration purposes, this is a default method in the interface. Okay, so this is how we can define a classical abstract method without a body, as you can see. Then we can define a static method, and here we have to define the body of the method. And finally, we are able to define a default method. Again, we have to define the body itself. So this is a default method. So if I save it and let's implement this interface, so the application class implements the modern interface, and if we save it, as you can see, we have to add the unimplemented methods, but basically we have to deal with the abstract method exclusively. So we don't have to override a static method, we don't have to override the default method, we have to override the abstract method exclusively. Okay, so let's use something like abstract interface method from the application class. And here we can use something like, first we have to instantiate the application class, so new application, and first of all we are able to call the abstract method. So if I save it and run it, then this method is going to be called, so abstract interface method from the application class. We are able to call the static method because it is static, there is no need to instantiate anything. So we can use something like modern interface dot static method. We can call a static method present in an interface just like we are dealing with classes. So if I save it and run it, this is a static method in the interface. And finally, we are able to call the default method. So as you can see, we are able to do something like this, application.default method. So the method within a given interface that defined default, it means that we don't have to override that given method, but we are able to call it as far as the given class is concerned that implements the given interface. So in this case, we can run all the methods. So as you can see, this is a default method in the interface. So as far as abstract methods are concerned, we don't have to define the body of that given method and we have to override it as usual. As far as the static method is concerned, we have to define the body of the given method and we can call it like this. And as far as default methods are concerned, we have to use the default keyword. We don't have to override that given method, but we are able to call it like this. So these are the three main types of methods within a given interface. What's crucial that we are able to override the default method. So with default functions in interfaces, there is a possibility that a class is implementing two interfaces with the same default method. The first solution is that we can override it. The second solution is that we can call the default method of the specified interface using the super keyword. So I'm going to create another interface. Let's call it another interface. And within this interface, I will have the exact same method as here. So I'm going to copy and paste the method here, public default void default method. And here I print out that default method from another interface. Okay, so if I save it, then the application class is going to implement this another interface. So what's crucial that after implementing another interface, then we have to override the default method. So if we override, for example, like this, then another interface.super.default method is going to be called. This is why we have been discussing that we have to use the super keyword. So Java has to know whether we are going to call the default method present in the modern interface, so this method, or present in another interface. So this is why we have to override the default method, and in this case we are going to call the another interface related default method. So if I save it, then whenever we call application.default method, then default method from another interface is going to be called. We can do the same with the modern interface. So if we use modern interface.super.default method, we save it and run it, then in this case this is a default method in the original modern interface. So that's all about abstract methods, that's all about static methods, and that's all about default methods as far as interfaces are concerned. Thanks for watching. In this lecture, we are going to talk about nested interfaces. So an interface which is declared inside another interface or inside another class is called a nested or inner interface. The nested interfaces are used to group related interfaces so that they can be easy to maintain. The nested interface must be referred by the outer interface or the outer class. It can be accessed directly. So if we create a new interface, for example, outer interface, and here we will have an abstract method. So we will have a public void message, and within this interface we can define another interface, the so-called nested interface. So we will have a public interface nested interface. Okay, and here we will have a public void message inside, and we will have a message outside. So this message outside is outside the nested interface. The message inside is inside the nested interface. What's crucial that nested interfaces are static by default. You don't have to mark them static explicitly as it would be redundant. Nested interfaces declared inside class can take any access modifier. However, nested interface declared inside an interface, so this is the case here that we have an interface, and within the interface we create another interface. So nested interfaces within a given interface is public implicitly. So if we run it, then we are able to make sure that the application class will implement the outer interface dot nested interface. So this is how we can refer to the nested interface. It belongs to the outer interface, so this is why outer interface dot nested interface, and here we can add an unimplemented method. As you can see, we have to override the method that belongs to the nested interface. So this is why we have to override the message inside. So I just print out that system out println. This is a method within a nested interface. Okay, and here we are able to instantiate, so outer interface dot nested interface message is equals to a new application. So we can instantiate a new application as an outer interface dot nested interface because that given class implements that given interface. This is In the coming lectures, we are going to talk about serialization. So first of all, what is serialization? Serialization is a mechanism of converting the state of an object into a byte stream. So the aim of serialization is to transform the objects into byte streams. Deserialization is the reverse process where the byte stream is used to recreate the actual Java object in memory. This mechanism is used to persist the object and to travel object states on the network. So we have the objects, so the instantiated Java classes. With the help of serialization, we end up with a stream of bytes that can be persisted into a file, into a database, into memory, whatever. Then deserialization is the process when we take the byte streams and convert them back into objects. So this is serialization, and the reverse process is the deserialization. Only the objects of those classes can be serialized which are implementing the java.io serializable interface. Serializable has no data member and method, so it is just a marker interface. It is used to mark Java classes so that objects of these classes may get certain capability. So this is the java.io serializable interface, and if we want to serialize a given Java class, then we have to make sure that given class implements the serializable interface. Let's consider some good to know things about serialization. During the serialization process, only non-static data members are saved, static data members are not. If you don't want to save the value of a non-static data member, you can make it transient with the help of the transient keyword, and that means it won't be saved via the serialization process. We are going to take a look at concrete examples and it's going to be clear. If a parent class has implemented the serializable interface, then child class doesn't need to implement it because serializable is going to be inherited. If a class has a reference to another class, all the references must be serializable, otherwise the serialization process will not be performed. In such case, not serializable exception is thrown at runtime. When an object is deserialized, the constructor of the object is never called, so it is extremely important that if we use deserialization, then we have to take it into consideration that the constructor of the objects are not going to be called. So this is what we are going to talk about in the coming lectures. Thanks for watching. In this lecture, we are going to talk about serialization and deserialization. So first of all, let's create a class, for example, car. The car class is going to be transformed into a byte stream, so this is why we have to make sure that this class implements the serializable interface. So as you can see, java.io.serializable, and first of all we are able to add default serial version ID. As you can see, you can generate serial version ID or you can use the default serial version ID. In this case, we are going to generate the serial version ID, and of course we have to save it. And as you can see, this is going to be the value that's going to identify the class we would like to serialize. So the serialization runtime associates a version number, this is the version number, with each serializable class called the serial version UID. So this is the serial version UID, as you can see, which is used during deserialization to verify that sender and receiver of the serialized object have loaded classes for that object which are compatible with respect to serialization. So if the receiver has loaded a class for the object that has different UID than that of the corresponding sender's class, then the deserialization will result in an invalid class exception. So this is why it is crucial to use serial version UID to be able to check whether the serialized object is the same as the deserialized object. Okay, so this is why we have to generate a private static final long serial version UID. By the way, if we do not specify this UID, it is going to work just fine. In this case, Java is going to generate a serial version UID on its own, but it is highly advisable to generate the private static final long serial version ID. Okay, so we have the serializable interface, we have the serial version UID, and we will have several field variables such as car brand, we will have the motor number, we will have the color, for example, and we will have a constructor. So in the car constructor, we get the car brand, we get the motor number, and we get the color, and we are going to set the car brand to be equal to the car brand. We set the motor number to be equals to the motor number, and we set the color to be equals to the color. I'm going to override the toString method as usual. So in the toString method, we are going to return with this dot car brand plus some spacing, this dot motor number, some spacing, and this dot color. Okay, so this is the class we are going to serialize. So in the application.java, first we instantiate a new car. It's going to be a Ford. The motor number is going to be something like this, and the color is going to be green. So what we have to do is we have to instantiate a file output stream. File output is equals to a new file output stream, and we have to define the file name, for example, serialization.txt. Okay, so with the help of the file output stream, we are able to transform an object into a stream of bytes. Of course, we have to use a try-catch block. Instead of a file not found exception, we are going to catch all IO related exception. Okay, so we use something like this. Then we use an object output stream. So object output stream is a new object output stream, and we have to define the file output. And then we are able to use this object output stream in order to serialize the given object. So we write object and we have to define the car. So this is how we can serialize a given object. Then we have to close the stream, so object output stream dot close, and we have to do the same with the file output as well. So that's all about the operations as far as serialization is concerned. So here we print out that the car object has been serialized. Okay, so if we save and run the application, car object has been serialized, which means that if I navigate to the folder, I guess it is the advanced Java, Udemy serialization.txt, as you can see. So this is the file I am looking for. If we double click serialization.txt, of course it is not a human readable file, but this file is going to contain all the information that needed for Java in order to deserialize the given object. So the given car object is present in this file. Okay, so how to deserialize the given object? I'm going to use a try-catch block, so let's use deserialization, and here I'm going to paste it, and instead of a file output stream, we will use a file input stream. So file input stream is a new file input stream, and we have to specify the txt file, so serialization.txt. Then we have to use an object input stream. Okay, object input stream is a new object input stream, and we have to define the file input stream as the argument. And then we are able to read the given car. So it is the serialized car is equals to, we have to make some casting, and object input stream dot read object. Of course, there's an unhandled exception, a class not found exception, so I throws a class not found exception here. Anyways, we have to print out car object has been deserialized. I'm going to close file input stream, and I'm going to close the object input stream as well. And here I'm going to print out the deserialized car. So if I save it and run it, as you can see, we have managed to serialize, so save the given object, and then we have managed to deserialize, so load the given car object. And as you can see, these are the parameters: Ford, this is the model number, and this is the color. What we have been talking about in a theoretical section, that we are able to prevent some variables to be serialized. So if we use the transient keyword, so string transient color, then the color is not going to be serialized, which means that if we save the application and run the application, as you can see, the color is a null. So with the help of the transient keyword, we are able to notify Java that we don't want to serialize, so we don't want to store this value as far as the color string is concerned. So that's all about the transient keyword. And what's crucial, that if we have a new class, for example, Ford is a car, so we can say that Ford extends the car, because car is a serializable. This is why Ford as a class is going to be serializable as well. So we add the constructor like this. For example, I define another variable string Ford type, and here we get another string, so string Ford type. This Ford type is Ford type. Okay, so let's create a Ford instead of a car. So I'm going to create a new Ford, and for example, the type is going to be Focus. So it's going to be a green Ford Focus. So if I rerun the application, it is going to work just fine. Okay, just to make sure it is working fine, let's define another value. So if we rerun the application, as you can see, it is working just fine. What's crucial, that if we create a given class Ford that extends a given class that implements the serializable interface, then there is no need to make sure that Ford implements the serializable interface, which means that the conclusion is that all the subclasses are inheriting the serializable interface. So that's all about serialization and deserialization. Thanks for watching. In this lecture, we are going to talk about Lambda expressions and functional interfaces. So first of all, what are Lambda expressions? A Lambda expression was added after Java 8, and it is a block of code that gets passed around like an anonymous method. It provides a clear and concise way to represent single method interface using an expression. You can use Lambda expressions only with functional interfaces, so interfaces that contain only one abstract method. What are the advantages of Lambda expressions? First of all, Lambda expression is a function that can be created without belonging to any class. So these expressions are independent of any classes, which means less coding. And finally, Lambda expression can be passed around as if it was an object and executed on demand. So these are the main advantages as far as Lambda expressions are concerned. Let's take a look at the syntax. We have optional parameter types. In this case, we have string s1 and string s2. s1 and s2 are the parameter names. We have the arrow operator, and we have the body itself. In this case, when we return s1 plus s2. This is the syntax including optional parts. Optional parts are the curly braces, for example. So after omitting optional parts, we end up with something like this: s1, s2, arrow operator s1 plus s2. In the next lecture, we are going to talk a lot about Lambda expressions, so it's going to be clear. What about functional interfaces? A functional interface is an interface that contains only one abstract method. They can have only one functionality to exhibit, and Lambda expressions can be used to represent the instance of a functional interface. We have to use this annotation functional interface. It is an interface, so this is why we have to use public interface concatenate, and then we can use a public string concatenation with the parameter types, in this case strings, parameter names text1 and text2, and as you can see it is an abstract method without a body, of course because it is an interface. So this is called a functional interface. Let's talk about predefined functional interfaces. As you will see in the next lectures, you can define your own custom functional interfaces, but useful to know that Java provides predefined functional interfaces as well to deal with functional programming by using Lambda and method references. These predefined functional interfaces are placed in java.util.function package. Of course, you can take a look at the documentation on the website of Oracle as usual, and in the coming lectures we are going to talk about Lambda expressions and functional interfaces. Thanks for watching. In this lecture we are going to talk about Lambda expressions. So let's take a look at a concrete example what to do if we don't want to use Lambda expressions. So for example, I'm going to create an interface sum. And within the interface, I'm going to have a public integer odd method that's going to sum up two integers, the integer num1 and integer num2. So what we can do is to use a so-called anonymous inner class. So sum is equals to a new sum, and as you can see we can instantiate this interface as an anonymous inner type. So we have to define what to do as far as the odd method is concerned. We are going to return num1 plus num2. Okay, so we can do something like I print out that the sum interface odd, for example, 10 and 5. So if I save it and run it, the solution is going to be 15. So this is how we can use interfaces. We define a given method, and in the application.java class, we create an anonymous inner class. We define the concrete behavior, and then we can use this method without any issue. So what to do if we want to use Lambda expressions? With the help of Lambda expressions, there is no need to use anonymous inner classes and so on. So it is way better and way easier to use Lambda expressions. So what we can do that instead of instantiating the given interface as an anonymous inner class, we can use something like this. The sum is equals to, and we have to define the parameters integer num1 and integer num2. We have to use the arrow operator, and then we have to use something like this, num1 plus num2, like this. But of course, because in the sum interface we return with an integer, this is why we have to define the return keyword as well. Sorry for that, of course, without any typo. So this is how we can use a Lambda expression. As you can see, we have to define the arguments because the sum interface odd method has two parameters, the number 1 and the number 2, and these parameters are integers. So this is why we have to define integer num1, integer num2, and then we have to use the arrow operator, which is a fundamental operator of Lambda expressions, and we have to define what to do. Basically, this is how we define the behavior itself. So whenever we have two integers, then we would like to return with the sum of the two integers. Okay, again, we can use something like this, dot odd 10 and 20, for example. So we can use the given interface in the exact same manner, and the result is going to be 30. So we are able to sum up the values with the help of this Lambda expression. What's crucial that we are able to simplify the original syntax and we can omit optional parts. So as you can see, for example, we don't have to define the parameter types because Java will know for certain that these are going to be integers because in the interface the odd method is dealing with integers. In this lecture, we are going to talk about functional interfaces. So any interface with a single abstract method is a functional interface basically, and its implementation may be treated as Lambda expressions. So why do we prefer functional interfaces? Because we can use it for Lambda expressions. But the interface may contain other methods such as static methods or default methods. So what's crucial that a functional interface has to have a single abstract method, but there may be as many static and as many default methods as we want. What's crucial that there are predefined functional interfaces we are going to talk a lot about in this lecture, such as the consumer, predicate, unary operator, supplier, and so on. So first of all, let's create a functional interface. I recreate the sum interface, and as we have discussed in the theoretical section, we can use the functional interface annotation. Okay, there's going to be a compile time error because the sum interface is not a functional interface. Why? Because every single functional interface has a single abstract method. So in this case, we have a public integer odd, integer num1, and integer num2. If we define this abstract method, as you can see, the error message is gone. Because we have a single abstract method, this is why it is a functional interface, which means that we can use it for Lambda expression. But because there are other interface related methods, such as the static void static method, for example, as you can see, it is going to work just fine. Okay, sorry for that, we have to define the body. So this is a static method in the interface. Anyways, what's crucial that we can define as many static methods and default methods as we want. What's crucial that a functional interface has a single abstract method, and we can use it for Lambda expressions. So we have the sum, we can define the num1 and num2, and what do we want to do? We want to sum up the values num1 plus num2. So in this case, we can print out, for example, sum odd 10 and 12, and the result is, I guess it's going to be 22. Yeah, it is working fine. So we can use a functional interface with Lambda expressions. And let's take a look at the predefined functional interfaces one by one. So first of all, let's talk about the consumer functional interface. The consumer interface represents an operation that accepts a single input argument and returns no result. So it consumes a given parameter without returning any value. For example, when we get a given string and we print out that given string in a lowercase manner. So we get Java programming step by step from A to Z, and it is going to accept that given string and performs that given operation we define. What is the operation? That first of all we convert all the letters to lowercase letters, and finally we print out the solution. So if I save it and run it, that's why 22 is going to be the sum of 10 and 12. Then Java programming step by step from A to Z. As you can see, we have managed to transform all the letters to lowercase one. So this is when we can use a consumer. Consumer accepts a single input and returns no result, because we just do some operation without returning a given result. Okay, what about predicate? Predicate interface represents a predicate, so Boolean valued function of one argument. So for example, we would like to check whether a given input is greater than 10 or not. This is why we create a predicate integer. We have the a parameter, so basically this is the input, and what do we want to do? We want to check whether this a parameter is greater than 10 or not. So we can call this predicate.test. This test is going to evaluate this predicate on the given argument. So this is why it is true, because 11 is greater than 12. But what if we specify 5? In this case, 5 is smaller than 10, so this is why we get a false. So this is when we can use predicate. Let's talk about the unary operator. It represents an operation on a single operand that returns a result of the same type as its operand. So for example, we would like to have an input and we would like to transform the input to uppercase letters. So for example, we have that string hello Java and we would like to consider all the letters and convert them to uppercase characters. So this is why we can use a unary operator, and the string.apply with the help of the apply method, it is going to apply this function to the given argument. So this is how we can define a unary operator. Okay, then what about a supplier? It represents a supplier of results, so the supplier can be used in all contexts where there is no input but an output is expected. So in this case, there is no input. This is why the input list is empty and the output list is a random value. So this is why, as you can see, the random value is 0.54908 and so on. So in this case, with the help of the supplier, we can handle situations when there is no input but an output is expected. In this case, random value.get, this get method is going to get the results without an input. There is no input, the output is a random value within the range 0 and 1, by the way. Okay, so that's all about supplier. What about function? It represents a function that accepts one argument and returns a result. So in this case, we can define the behavior itself, that the function string is going to be a function example. The input is a string, and then we would like to return and call a given function with the given argument. In this case, this function is going to return hello plus it is going to concatenate the given string, but this is what we can do with the help of function. Function accepts one argument and returns a result accordingly. Again, we can call the apply method in order to apply this function to the given argument. So that's all about functional interfaces. We can create functional interfaces with the help of functional interface annotation. We just have to make sure that we use a single abstract method, and there are several built-in functional interfaces we can use with Lambda expressions. Thanks for watching. In this lecture, we are going to talk about method references. Okay, so we can use Lambda expressions to implement functional interfaces as we have seen in the previous lectures, but Lambda expressions are not the only mechanisms we can use for this purpose. Sometimes a Lambda expression does nothing but call an existing method. In those cases, it's often clearer to refer to the existing method by the name, and this is why method references came to be. Method references enable you to do this. They are compact, easy to read Lambda expressions for methods that already have a name. So basically, method references are not independent of Lambda expressions. In other words, a method reference is the shorthand syntax for a Lambda expression that executes just one method. What's extremely crucial that method references always utilize the double colon operator. Okay, so there are four kinds of method references. Reference to a static method. The syntax is that we have to use the double colon operator containing class colon static method name. So this is how we can deal with the method reference as far as static methods are concerned. A reference to an instance method of a particular object. In this case, we have to use the containing object, double colon again, and instance method name. So it is very similar, as you can see, and the syntax always contains the double colon operator. What about reference to an instance method of an arbitrary object of a particular type? In this case, we have to use the containing type, double colon operator, method name. As far as reference to a constructor is concerned, we have to use the class name, the double colon operator, and the new keyword. We are going to talk a lot more about concrete examples and it's going to be clear. So here are some examples for Lambda versus method reference solutions. The results are the same, but in many cases the method reference solution has easier syntax. So for example, we can calculate the length of the string with the help of Lambda expression. String, the arrow operator, string.length is the same as string double colon operator length. We can call the substring method with Lambda expressions, and we can call it with method references. We can call replace all method with Lambda expressions, and we can do the same with method references. So as you can see, it is more convenient and easier to use method references. However, we can't use method reference to replace all kinds of Lambda expressions since they have some limitations. We will see examples of these in the following lectures. Until then, the golden rule that needs to be remembered is that if the task can be accomplished with both methods, then use that which is more readable in that case. As far as I am concerned, I am a huge fan of method references. In the next lectures, In this lecture, we are going to talk about method references. So as we have discussed in the theoretical section, there are 4 kinds of method references. A reference to a static method, a reference to an instance method of a particular object, a reference to an instance method of an arbitrary object of a particular type, and reference to a constructor. So this is what we are going to talk about on a one-by-one basis. So first of all, let's create a functional interface. In one of the previous lectures, we have been talking about functional interfaces, and a functional interface is basically an interface with only one abstract method. So we can create an interface. So interface, functional interface. Okay, I'm going to get rid of the typo, and here we will have a public void show method. So this is the only abstract method, and this is why this functional interface is basically a functional interface. So let's take a look at a concrete example as far as the first point is concerned, so a reference to a static method. First of all, let's create the static method itself. I'm going to create a public static void static greeting, and it is going to print out that greeting from a static method. So what we can do in this case is that the functional interface is equals to an application static greeting. So as you can see, it is going to work just fine. The application is the class itself, and as you can see, the static method static greeting belongs to the application class. So this is why we can do something like this, that application static greeting. And what does it mean exactly? That whenever functional interface dot show, so basically whenever we call the functional interface show method as we have defined here, then it is going to be printed out because we use the application double colon static greeting. So if I save it and run it, greeting from static method. So this is how we can use a reference to a static method. Let's talk about the second case. So a reference to an instance method of a particular object. So first I'm going to instantiate the application class. So we have a new application. Let's create not a static but an instance method. So public void instance greeting. And I'm going to print out that this is a greeting from an instance method. So in this case, what we can do is that functional interface 2 is equals to the application double colon instance greeting, as you can see. So in this case, the functional interface is the same functional interface with the public void show method. So whenever we call the functional interface 2.show method, then this instance method is going to be called because we use application instance greeting that's pointing to this method. So after instantiating the application class, we can use something like this. So if I save it and run it, this is a greeting from an instance method, as you can see. By the way, we can do the same with the help of the new keyword, so new application like this, and it is going to be the same. So if I get rid of the object itself, I save and run it, it's going to be the same. So we can use this anonymous instantiation, the and instance greeting. This is the method that's going to be called whenever we call the show method of In this lecture, we are going to compare Lambda expressions and method references. So I'm going to create an interface sum, and here we are going to have a public void addition with integer num1 and integer num2. So this is a single abstract method, which means that it is a functional interface. Okay, so what we can do as usual, that the sum is equals to num1 and num2, and we are going to use the add method. So in this case we call a given method, and let's create that given method. So I'm going to create this static integer num1 num2, and we return with num1 plus num2. So if I save it, and we just have to call the addition with 10 and 11, for example, then of course the result is going to be printed out. Okay, so the result should be 21, of course. Yeah, sorry for that, there's going to be an error message because the sum is going to return an integer, of course. So if we go back to the application, it is working fine. So this is a lambda expression that we have two arguments as we specify here. And with these two arguments, we are going to call this static method integer1, integer2, and we return the sum of the two integers. That's why it is going to work fine. The result is 21. Okay, so this is how we can use lambda expression. But how to use method references? In this case, we can say that sum2 is equals to the application dot add, because this add is a static method. This is why we can refer to it via the application class. So we can use something like this. This is what we have been talking about in the previous lecture. So we can print out again the sum2 dot addition, for example 5 and 10. And of course the result should be 15, which means that it is working fine. So as you can see, maybe using method references is a bit better option because it is more compact than this lambda expression. So this is why I like method references. Okay, if we create another method, for example increment, and in this case we have a given value, this integer num, we return with the number, but before returning the number we are going In this lecture, we are going to talk about for each loops with Lambda expressions and with method references. So after Java 8, the for each loop provided programmers with a new simplified way for iterating over a given collection. This collection can be an array list, it can be a hash set, it can be a map or anything else. So let's take a look at a concrete example. I'm going to create an array list of strings. For example, names is a new array list. Of course, we have to import the java.util.list. Okay. And I'm going to add several names such as Adam, such as Kevin, Natalie, Joe, Brad. Okay, just for demonstration purposes, it's going to be fine, and we can use for each loop without any problem. Because this array list stores strings, we can use string s and names, and we can print out the string itself. So we iterate through the names one by one and we print them out. So if we run the application, of course, Adam, Kevin, Natalie, Joe, and Brad are going to be printed out. But we can use Lambda expressions. So we can do something like this: names for each, and we have to define the Lambda expression because this list stores strings. This is why we are going to reference the names with the variable s. And what do we want to do with these variables? Of course, we want to print them out. So this is what we can do. And if I save it and run it, it is going to work just fine. So of course, feel free to change the variable name. It is not that crucial. You can use name, and in this case the name is going to be the variable for the given string names. Of course, you have to make sure to be self-consistent. So in this case, again, it is going to work just fine. So this is how we use Lambda expressions in order to iterate through all the values in a given collection. We can use method references as well. So we can use names.forEach again, and what do we want to do? We want to do system.out, and we want to call the println function on every single item of the list. So that's all we have to do. If I save and run it, as you can see, it is going to work fine. So this is what we have been talking about, that as far as a method reference is concerned, we have to use the double colon operator. In this case, we iterate through the given array list of strings. This is the names as far as a for each loop is concerned. And what do we want to do? We want to call the println method, which means that we want to print the values one by one. We can do the same with a hash set. So if I create a set of strings, set is equals to a new hash set, and I would like to use arrays as list, and here we can define the given items. So this is the item 1, we have the item 2, we have item 3, and so on. So in this case, we create an array of strings, and this is what we are going to transform into a hash set. So if we import hash set and we import java.util.set, then it is going to work just fine. And again, we can use the set.forEach, and we have to define what do we want to do. Of course, we want to print out the given items. So system out println s, and if I save and In the coming lectures, we are going to talk about optional. So first of all, what is the optional class? Java 8 has introduced a new class optional in the java.util package. It is a public final class and used to deal with null pointer exceptions, which can crash your code at runtime, and it is very hard to avoid without using too many null checks. So it is a wrapper class that contains an optional value, meaning it can either contain a given object or a null value or an empty value. Therefore, it is possible to manipulate null values as if they were normal instances without necessarily having to perform a null check at every single step. So the optional car may contain a null value, it is called an empty optional, or it may contain a given object. In this case, the optional contains an object of type car. Okay, so the optional class includes various utility methods to explicitly deal with the cases where a value is present or absent. However, the advantage compared to null references is that the optional class forces you to think about the case when the value is not present. As a consequence, you can prevent unintended null pointer exceptions, which is quite useful. It is important to know that the intention of the optional class is not to replace every single null reference. Instead, its purpose is to help design more comprehensive code so that by just reading the signature of a method, you can tell whether you can expect an optional value. This forces you to actively unwrap an optional to deal with the absence of a given value. Okay, so let's take a look at a concrete example of creating optional object. We can create an empty optional like this. Optional type car is equals to optional.empty. This is how we create an empty optional, and we are able to instantiate a new car class, and we have the instantiated object, and with the help of the optional.offNullable, and we provide the car as the parameter, we can create an optional with not null value. By the way, the offNullable method ensures that if the car was a null, then the result would be an empty optional instead of a null. For example, if a value is present in an optional container object, then the isPresent method will return true and the get method will return the value itself. Additional methods that depend on the presence or absence of a contained value are provided as well, such as the OR-else method that returns a default value if the value is not present, and the ifPresent method that executes a block of code if the value is present. So this is why this optional wrapper class is extremely useful in order to avoid null pointer exceptions. In the next lectures, we are going to take a look at concrete examples, and it's going to be clear how to use optional class. Thanks for watching. In this lecture, we are going to talk about how to use the optional wrapper class. So first of all, let's create a new person class. So person. The person is going to have one single instance variable, the private string name. In the constructor, we can initialize the value of the name. So I use something like this, string name. So this dot name is equals to the name. I'm going to override the toString method, and we just return with this dot name. And I'm going to generate getters and setters. So source generate getters and setters for the name variable. Basically, we have two methods, public string getName that returns the name itself, so this dot name, and the setName that gets a name parameter and update the value of the name. Okay, so this is the class we are going to use. Okay, and in the main method, we are going to instantiate a new person class. So person with the name Kevin Smith, and we can create an optional with the help of optional, and we have to define that it is going to store a person object. It is going to be a person. At the beginning, it's the person empty, so we can use something like this. Optional java.util, as you can see, this is the package. Here we have to use something like the empty method. So if we use something like this, this is how we can create an empty optional. So what does it mean exactly? That if we print out the person empty, we save it and run it, as you can see, it is the optional empty value. So this is how we can create an empty value instead of a null reference. And of course, we can use the of method. So if we use of the person, then this person, in this case, person optional, is going to store the person object itself. So person optional, we can call the get method. With the help of the get method, as you can see, we can get the person object itself. So get method and get name, this is how we can get the person object with name Kevin Smith. So if I run it, then Kevin Smith is going to be printed out. By the way, if I print out the person optional itself, then the optional is going to be printed out like this, as you can see. So Kevin Smith is the value as far the optional is concerned, because with the help of the of method, it's going to return an optional with the specified person non-null value. So the person has the value Kevin Smith as the name, and this is why if we print out the optional that we have created based on the given object, this is why Kevin Smith is going to be the value of the optional itself. The main problem with this of method that if we specify a null object, so for example, if we set the person to be a null and here we define the person, then we are going to get an exception. So as you can see, null pointer exception, because the person is a null. So this is why this of method is not the best solution possible. We can check whether the optional contains a valid object or not with the help of the isPresent method. So we can use something like a new person Kevin Smith. Okay, we are going to create an optional of the person. By the way, let's talk about the better solution first. So instead of this of method, we can use the of nullable method that's going to take the same argument. So in this case, the person, and it is going to work fine. Why is it a better solution? Because if we define a null here, then there's not going to be any exception. As you can see, the optional empty is going to be the value of the optional itself. So this is why this of nullable is a better solution than using the of method exclusively. Okay, so if we use this of nullable, then we can check that if the person optional is present, this is present returns true if there is a value present, otherwise a false. So what does it mean? That we print out that there is a non-null object in the optional with value, and we can print out the value with the help of the person optional dot get. As you can In this lecture, we are going to talk about how to handle optional with the help of map and flat map methods. So in order to demonstrate it, I'm going to create several classes. A person class, I'm going to have a passport class, so passport. I'm going to have a stamp class, so stamp. The stamp is going to have a private string stamp of country. It is going to have a constructor, so right click, source, generate constructors using fields. So this is a public stamp, it gets a stamp of country, and we set the stamp of country to be the stamp of country. And then we are going to generate the getters and setters accordingly for the stamp of country variable. So this is the stamp class. Of course, every passport has a stamp. So here we have a private stamp. Again, we generate the source and constructor. Without the super method call, we generate the getters and setters for the stamp itself. Okay, this is the passport class, and of course every person has a private string name and a private passport. Again, I'm going to generate the constructor using the fields without the super method call, and I'm going to generate the getters and setters accordingly. So right click, source, generate getters and setters for the name and for the passport. So that's all about the classes. We have a person has a name and a passport, and every single passport has a stamp, basically the stamp of the given country. So first of all, in the main method, we can create a new stamp. So stamp is a new stamp. For example, the stamp of Barbados. We create a new passport. So passport is a new passport. Of course, we have to define the stamp itself. And finally, we can define a person. So person is a new person with name Kevin, and passport, the passport we have created earlier. Of course, if the stamp is not a null or the passport is not a null, then we can print out the person.get name plus the person.get passport.get stamp.get stamp of country, for example. And because we have defined all the stamps and the passports and the person name and all of these, of course it is going to work fine. But the problem is that there is a possibility that the stamp is a null or the passport is a null. So what do we have to do? We have to use a lot of if checks. So we check that if the person is not equals to a null, then we can get the passport. So a passport P is the person.get passport. If the P is not a null, then again we can get the stamp. So stamp S is the passport.get stamp. And if the stamp is not equals to a null, then finally we can print out that, for example, just for demonstration purposes, the stamp gets stamp of country. So as you can see, it is not that convenient because we have to use a lot of if checks whether the given object is a null or not. And this is what we have been talking about in the previous lectures, that we should use optional. So this is why optional is an extremely powerful technique in Java, because we don't have to deal with null pointer exceptions. We don't have to check whether the given object is a null or not. So what do we have to do? The stamp class is going to be fine because it is just a simple string, the stamp of country. But the passport has a stamp field variable that may be a null. So what do we have to do? We have to use the optional like this as usual. So let's import the java.util.optional. Of course, the input is going to be an optional. The return value is going to be an optional. And here, the parameter is going to be an optional. So that's all about the passport. And why is it good? Because we don't have to check whether the stamp is a null or not, because Java is going to handle everything because of this optional wrapper class. And we should do the same with the person class. So instead of the passport, we should use optional passport, which means that first of all, we have to import java.util optional. Here we have to use an optional passport. Here we have to use an optional passport, and here as well. So this is how we make sure that we don't have to check whether the person's passport object is a null or not, because the optional wrapper class is going to handle everything for us. Okay, the problem with this is that if we want to get the stamp of the country, so every single person has a passport, every single passport has a stamp, and every single stamp has a stamp of country, and if we would like to get this value, then we should use the lambda expression stamp of country is equals to, and first of all, let's handle the objects. Instead of a stamp, let's create an optional stamp with optional of nullable, and we have to instantiate a new stamp like this. Okay, this is what we have been talking about in the previous lecture. So we don't have to use this, and it is going to be just fine for the stamp. Why is it good? Again, because Java is going to handle null pointer exceptions. So if we specify a null instead of a new stamp, then the optional is going to be an empty optional, and there is no need to check whether there is a null pointer exception or not. We have to use the same with the passport. So passport optional like this, we have to use an optional.of nullable, and we have to In the coming lectures, we are going to talk about Stream API. So first of all, what is a stream? Introduced in Java 8, the Stream API is used to process collections of objects. A stream is a sequence of objects that supports various methods which can be pipelined to produce the desired result. You can process data in a so-called declarative way, very similar to SQL statements. So what is this declarative way? It means that we can solve problems without requiring the programmer to specify an exact procedure to be followed. Stream lets the developer leverage multi-core architecture without the need to write any specific code. So it is extremely important that with the help of streams, we are able to do parallel programming very easily. What's crucial that a stream is not a data structure, instead it takes input from a collection, array or an input-output channel, and the stream provides an interface to a sequence set of values of a specific element type. However, streams don't actually store items, they are computed on demand. Operations performed on a stream doesn't modify its source. It's extremely crucial that, for example, filtering a stream obtained from a given collection produces a new stream without the filtered items, but this doesn't change the original source collection. So what's crucial that stream is a sequence of objects. It is not a data structure, so streams don't actually store items, they are computed on demand. It is extremely easy to do parallel programming with the help of streams, and stream doesn't modify its source. Okay, so let's take a look at the stream flowchart. We have a stream source that can be a collection, that can be an input-output channel or an array, so any kind of data structure. We can create a stream instance, and then we can do several intermediate operations, operation 1, operation n, so as many operations as we want, such as filtering, sorting, mapping, type conversion, and so on. And we can use a final terminal operation. As you can see, it is a single operation. So we can have as many intermediate operations as we want, but just a single terminal operation at the end. And with the help of the terminal operation, we get the result itself, such as a count, a sum, or a given collection. As far as intermediate operations are concerned, we are going to talk about filter, map, flat map, distinct, sorted, peek, and so on. As far as the terminal operation is concerned, we are going to talk about a lot of methods such as collect, count, reduce, for each, min, max, and so on. Let's take a look at a concrete example. We have a list of strings Alan, James, Kevin, and Joe, and we are able to filter this list of names as far as the first character is concerned. So as you can see, we can get the stream with the help of the stream method, so names.stream. Then we can filter the results. This is a single intermediate operation. And finally, we have the terminal operation that's going to collect the results into a list. Okay, so if we call for each on the names, of course we print out all the names, so Alan, James, Kevin, and Joe. But after the filter operation, the filtered names is going to contain James and Joe exclusively, because these are the names that starts with the capital J letter. So the stream is going to return a sequential stream considering collection as its source. The filter is going to use to select elements based on a specified criteria. The collect is going to return the result of the intermediate operations performed on the stream. What is the intermediate operation? In this case, we have just a single intermediate operation as far as filtering is concerned. Okay, so this is how we can get the stream, this is how we can perform an intermediate operation, and this is how we can perform a terminal operation. As usual, you can check Java API documentation if you want to check the exact methods as far as streams are concerned. Of course, in the coming lectures, we are going to talk about them on a one-by-one basis. Thanks for watching. In this lecture, we are going to talk about the fundamental basics of streams. So first of all, let's create a list of string, for example, the names. We can do something like this dot as list. And here we can specify the values. So Adam, Kevin, Joe, Alan, Natalie. These are going to be the values. Of course, we have to import the list interface, so java.util.list. Okay, so we can use streams with the help of the stream method. So first of all, we are going to end up with a list of strings. It is the filtered names. It is equals to the names dot stream. So with the help of the stream method, we can get a sequential stream with this collection as its source. So we are going to use a stream based on the names list of strings. So these are the values we are going to manipulate with the help of a stream. And we can use an intermediate operation such as filter. In this case, we would like to make sure that we keep the names where the name starts with, for example, capital A. And finally, what do we want to do? We want to collect to a collector.toList. So this is exactly what we want. Of course, because collectors, sorry for that. So collectors is java.util.stream.collectors. And with the help of this intermediate operation, Java is going to select the names that starts with a capital A. And finally, in the terminal operation, Java is going to collect the results into a list. And this is why list of string is going to be the type of the result. So what do we have to do? We can do something like this: filtered names dot for each system dot out println. This is what we have been talking about. This is the method reference itself. We can call systemoutprintln method on every single filtered name that are stored in the filtered names list. So if I save it and run it, then Adam and Alan are going to be the results. Of course, if we change the criteria, so I would like to start with letter Z, then the result list is going to be empty, of course. If I want to make sure that the first letter is going to be an N, then Natalie is going to be in the result list. So this is the intermediate operation, and this is the terminal operation. Let's try to modify the terminal operation. We don't have to collect the results into a list of strings. We can use something like we filter the names based on the first character, for example, starting with letter A, and here we call for each. And again, we can use method reference, so system.out and println. And in this case, we are going to get the list of strings, so the original data structure. We are going to call the stream method. We are going to filter and select the ones that starting with letter A, and then we print out the values. So in this case, the result is going to be Adam and Alan. Okay, if we do not print out the values, then we can store this result as a stream. So stream of strings, it's going to be the stream. And as you can see, it is going to work fine. Of course, we have to import java.util.stream, but as you can see, if we call the stream method and then we do some intermediate operation, then the result is going to be a stream of strings. Why strings? Because the original data structure we are manipulating is a list of strings. So this is how we can store the stream itself, and then we can call the stream.forEach, and we can call the system.out and println. So what's crucial that we are able to store the stream itself, and then we are able to do further operations. So the result is going to be the same, of course. So that's all about the fundamental basics of streams. Thanks for watching. In this lecture, we are going to talk about the most important methods as far as streams are concerned. So first of all, we are going to talk about the stream.off method. Of course, first of all, we have to import java.util.stream, and we would like to call the static method off. So it is going to return a sequential stream containing a single element, but we can define several items as well. So this is item 1, then we have item 2, then we have item 3. And we can do further operations. For example, we can find the first one, and if it is present, then we are going to call the systemoutprintln method. So if I save it and run it, of course, the first item is going to be printed out. So what's crucial that with the help of this off method, we are able to create a given stream containing the given items. In this case, strings, but we can use integers as well. So in this case, the stream is going to contain integers and the first item is the value 10. So this is how we can use the off method. Let's talk about the filter and count methods. So I'm going to create a list of strings, for example, arrays.asList, and here we can specify the given values. So Alan, Adam, Kevin, Joe, and James. So these are going to be the values of the list. Of course, we have to import java.util.list. And we can use streams again. So we can get the stream. So as you can see, in this case, we are going to transform the names, which is a list, into a stream. So this stream returns a sequential stream with the collection as its source. And then we are able to filter. So we would like to call the filter method because we would like to make sure that we store the names that starts with, for example, capital J. And then we would like to count the number of names starting with capital J. The result is going to be a long, but I'm going to print it out. So let's use something like this. So if I save and run it, the result is going to be 2 because there are 2 names starting with capital J. Let's print out the count of the names starting with K. Of course, they're just the single name starting with capital K, so that's why the result is going to be 1. So we can filter the given stream, and finally we can use the count operation that's going to return the count of items in the stream with this given constraint. Okay, so this is how we filter, and this is how we use the count method as well. We can use the so-called iterate method. So we are going to create a stream of integers, numbers. It is a stream.iterate, and here we can define that we start with 1, and the formula is going to be n equals to n plus 1. So what does it mean? That we are going to increment the value by 1. And then we are going to limit to 10. What does it mean? That we are after the first 10 items. So we can do something like this, that numbers for each, we print out the given number. So system out println n and plus some spacing. I'm not going to use a new line character, so something like this. So what's crucial, as you can see, that first of all, we are able to get a given stream and we are able to iterate through the stream with the help of a for each loop. And because of this iterate, let's save and let's check the solution. As you can see, we start with 1, and this is the formula we are going to use. If we use something like this, that n plus 5, then what's going to be the result? We start with this value and we keep incrementing the values by 5. So that's why 1, 6, 11, 16, 21, and so on. So the limit is going to limit the number of integers we are going to get in the end. So as you can see, in this case, we have 5 results. If we use, for example, 20, then there are going to be 20 integers. So this is what we can do with the help of the iterate method. We are able to generate random numbers, so the result is going to be a stream of doubles, and we can use the stream.generate. We are going to use the math.random method, and again we are going to use the limit because we are after the first 5 random doubles. So then we are able to iterate through, and I'm going to call the system.out and println. So I would like to use a new line character. So what does it mean? That we are going to end up with 5 random values because the stream.generate is going to return an infinite sequential unordered stream where each element is generated by the provided supplier. And the supplier is the random method that going to return a double value with a positive sign greater than or equal to 0 and less than 1. So basically this generate is is going to use this method in order to generate 5 random values. If we set the limit to be 10, then of course we are going to get 10 random numbers within the range 0 and 1. So this generate method is going to use this provider as an underlying implementation, and in this case we generate 10 random numbers. Let's talk about the reduce method. So I'm going to create a string of title is equals to this is just an example. So we use a one-dimensional array of strings, and we can use the so-called reduce method. Of course, if we want to use streams, then first we have to transform this one-dimensional array to a stream. So stream is a new arrays.stream, and we have to provide the title. So this is how we transform the one-dimensional array of strings into a stream of strings. And then I'm going to use an optional and string the result, which is equals to the stream.reduce, and here we can define a given operation, that word1 and word2, and the result is going to be the word1 plus some concatenation word2. Okay, and finally, let's print out the result. Of course, we have to import java.util.optional. So first of all, let's run it, and then let's talk about the result. Of course, we can call the get method that's going to return just the string without the optional, as you can see. So if I run it, this is just an example. So what has happened? We have the original one-dimensional array of strings, and we would like to concatenate it with the help of a dash. And we can do it with the help of reduce. The reduce performs a reduction on the elements of the stream using an associative accumulation function and returns an optional describing the reduced value, if any. So in this case, we are going to tell Java that, okay, take any of the two words right next to each other and let's concatenate it by a dash. And if we use, for example, a plus sign, then of course it is going to be used, as you can see, the plus sign. What's crucial that in this case the result is a single string, so a single value. As you can see, we take several inputs, basically a one-dimensional array of distinct strings, and with the help of the reduce method we are able to end up with a single string. So this is the most important feature of reduce, that it is going to reduce several values to a single value. Okay, let's talk about the map method. For example, we have a list of strings, words. We use arrays as list as usual. This is again an example. So this is what we are going to transform to a stream. So first we have to get the stream. Then we have to call the map method, and the map method is going to transform the strings to uppercases, and then we are going to collect the words into a collectors.toList. So what does it mean exactly? First of all, the map is going to return a stream consisting of the results of applying the given function to the elements of the stream. So if we define something like this, that the string to uppercase, then Java is going to consider all these strings and going to apply the to uppercase method, and then we are going to collect the results into a list. Of course, we can use for each, and I would like to print out, so println. So in this case we iterate through the list and print out the values accordingly. So if I save it and run it, as you can see, this is again an example. To uppercase is going to transform all the letters to uppercase characters. So the map method is going to apply this operation on every single item we have defined. Okay, and let's talk about flat map. For example, we have a list of strings, female names, arrays as list, and here we define Kate, Judy, and Nicole. We do approximately the same but with male names. So arrays dot as list and Kevin, Peter, and Joe. Then we are going to combine these lists. So we have a list of strings, the names for example, arrays as list, and we have to define the female names and the male names as well. So Java is going to combine and going to create a list of lists. So if I print out these names, then let's take a look at the topology of the list of lists. As you can see, we have the first list with the female names, and we have the second list with the male names, and as you can see, it is a list itself. So the list has two items, the first item and the second item, and the first item is a list itself with the female names, and the second item of the list is a list itself with the male names. So in this case, when we have a list of lists, this is when we are not able to use map, we have to use flat map. So we have names, we get the stream, and if we want to use map and we want to transform the inner lists to a list of stream, and then we want to collect to a collectors.toList. So basically, what do we want to do? We want to merge these lists and we want to end up with just a single list with all the names, whether it is female name or male name. So this is what we want to do. But in this case, if I do something like this and for each system out println, then let's check what's going to happen. I save it and run it, and as you can see, this is not what we are after. We would like to end up with a single list that contains all the names, no matter the given name is a female name or a male name. So this is why we have to use flat map. If we use flat map, then Java is going to take the lists on a one-by-one basis, and the result is going to be Kate, Judy, Nicole, Kevin, Peter, and Joe. So this is what we can do with the help of a flat map. If we have a list of strings, then we can use flat map as we have seen in this example. So basically these are the most crucial methods as far as streams are concerned. Of course, in the coming lectures we are going to consider further operations. Thanks for watching. In this lecture, we are going to talk about how to use streams as far as maps and hash maps are concerned. So first of all, let's create a hash map. So a map with integer keys and string values. It is going to be the map is a new hash map. So let's instantiate it as a hash map, and of course we have to import java.util.map. Then I'm going to use map.put a given integer and a value. For example, 1 is the name Kevin. Then I'm going to put several other names as well. So we have 2, 3, 4, and 5. We have Joe, we have Adam, we have Judy, we have Donald, and we are able to use streams as usual with collections. So the result is going to be an integer and string related map as well. It is the result map. We can do something like this, that map, we have to call the entry set method, and then we can call the stream method. And now we are going to call filter, and we are able to filter our data structure. For example, we want to make sure that the map key value is smaller or equal to 4, for example. And then we want to collect it to a collectors.toMap. And we have to define the map.entry get key and map.entry get value. So the getters as far as the key is concerned and the value is concerned. So if you hover your mouse to map, then it returns a collector that accumulates elements into map whose keys and values are the results of applying the provided mapping functions to the input elements. So this is why we have to define the get key and the get value. Okay, and sorry for that, we are not able to use the map because we have already used that variable. Let's use the letter M just for demonstration purposes. And if we print out the result map, so let's save and run it. As you can see, the result is Kevin, Joe, Adam, and Judy, because as you can see, the key values are smaller or equals to 4. So 1, 2, 3, 4. So this is how we can filter a given hash map. We can use something like the skip method. So if we want to skip the first 2 items, it means that Kevin and Joe are not going to be printed out. So as you can see, the result is Adam and Judy because, okay, the key values are smaller than 4, so Joe and Kevin are fine, but we skip the first 2 items. If we skip just the first item, then Kevin is not going to be printed out, but Joe, Adam, and Judy are going to be printed out. If we use something like it is smaller or equals to 5, then all the items are going to be printed out except for the first one because we skipped the first item. Okay, so this is how we can use a stream as far as a hash map is concerned. As you can see, we can call the stream method on the entry set, and then we can use any methods we want. Filter method, skip method. Finally, we can collect the results into a map of integers and strings. So this is how we can use streams with hash maps. Thanks for watching. In the coming lectures, we are going to talk about the difference between sequential streams and parallel streams. So first of all, what is parallel stream? The Stream API enables developers to create the parallel streams that can take advantage of multi-core architectures and enhance the performance of Java code. In a parallel stream, the operations are executed alongside each other, and there are 2 ways to create a parallel stream. On a collection, we can use parallel stream method. On a stream, we can use the parallel method. Use parallel streams only with stateless, associative, and non-interfering operations. A stateless operation is an operation in which the state of an item doesn't affect another item. An associative operation is an operation in which the result is not affected by the order of operands. And a non-interfering operation is an operation in which data source is not affected. So what's extremely crucial that of course we have to make sure that the given operations are totally independent of each other. This is when we can use parallelization. Otherwise, the operations have to wait for each other to finish because they are depending on each other. I'm not sure whether you are familiar with algorithms, but for example, merge sort or quick sort can be parallelized because the sub-procedures are totally independent of each other. But for example, solving differential equation cannot be solved with parallel algorithms because the next step and the next calculation depends on In this lecture, we are going to see the difference between sequential and parallel streams. So for example, we would like to measure the time, so that's why we get a long start, which is the system.currentTime millis. Then I would like to create a long C, which is an integer stream, so java.util.stream.integer stream. And I would like to call the range close method that returns a sequential ordered integer stream from start inclusive to end inclusive by an incremental step of 1. So starting with 0 up to 1 billion, then I would like to filter, and I is the I modulo 2 is equals to 0. What does it mean? That I would like to filter out the even numbers. So this is the so-called modulo operator, which means that if we divide the given integer by 2, then the remainder is equals to 0, which means that the given number is even, and I would like to count the number of even values. Okay, and this is the operation we are going to measure. So we have the duration, which is system.currentTime millis minus the start, and then I would like to print out counted the C variable and in plus the duration milliseconds. So if we use a sequential stream, if we In this chapter, we are going to talk about multithreading. So first of all, what is multithreading? Multithreading is a Java feature that allows concurrent execution of 2 or more parts of a program for making optimal use of the available resources, especially when your computer has multiple CPUs. Multithreading enables you to handle multiple activities concurrently in the same program. So first of all, a thread is a lightweight subprocess, the smallest unit of processing, and it's executed inside the process. So it is extremely crucial that operating system may have several processes, and every single process may have several threads. So threads are associated with a given process. Each of the threads can run in parallel, and there is context switching between the threads. There can be multiple processes inside the operating system, and one process can have multiple threads. So the operating system has several processes, and every single process may have several threads. Okay, so what is the advantage of multithreading? Every single process may have several threads. This is what we have been talking about. In this case, the first thread has just a single thread, and the second process has 3 distinct threads. So the advantages of multithreading is that first of all, it allows multiple operations at once, as they are not dependent on each other, thus not blocking the user. Then it saves saves time as multiple operations are possible. And finally, the threads are independent, thus making the functionality better. So for example, as far as the single-threaded application is concerned, we have the first for loop and all the other operations have to wait for the first operation to finish. After we finish with the first loop, then the application can do the second loop, and after it is finished, then the application do the third loop. This is the case when it is a single-threaded application. If we have multiple threads, for example 3 distinct threads, then every single thread can do a given operation. In this case, the first thread is going to do the first loop, the second thread is going to do the second loop, and the third thread is going to do the third loop. So as you can see, it is the main advantage of multithreading, that we can do several operations concurrently. Of course, there are some disadvantages as well. First of all, it is extremely hard to debug a multi-threaded application. If you have, for example, a null pointer exception or something like this, it is extremely hard to debug the given errors. Then, multi-threading applications are quite hard to develop. It is quite complex to handle and understand multi-threaded applications. And the main disadvantage as far as multi-threading is concerned, that it is quite expensive to deal with multiple threads because the central processing unit, so the CPU, has to track what thread is doing what operation. So this is why using too many threads is going to make the application slower. So there is some trade-off between the number of threads and the speed of the application. Using more than just a single thread is a good idea, but using too many threads may result in an extremely slow application. Okay, let's talk about the life cycle of a thread. First of all, if we instantiate a new thread, then the thread is going to be in the new state. With the help of the start method, we are able to start a given thread, and that's when the thread will be in the runnable state. Thread scheduler of the Java virtual machine runs the thread as soon as the processor becomes available. With the help of the run method, the thread is going to be in the running state, and the thread terminates as soon as the run method ends. So this is the terminated state. So a given thread may be in a new state, runnable state, running state, terminated state, and the last state we have to consider is when we call the sleep method or the wait method, and this is when the thread is in a blocked state. So whenever a thread goes to blocked state, it will run again when it returns to runnable state. If the sleep method is called, the thread will go to sleeping state, it changes into runnable state again after sleep time is over. And if the wait method is called, the thread will go to the waiting state, it goes to runnable state after it gets notification through the notify or notify all methods. We are going to talk a lot about these methods in the coming lectures, and it's going to be clear what's crucial, that whenever we instantiate a new thread, then it's going to be in the new state. When we start the given thread, and this is the runnable state, whenever we call the run method, the thread is going to be in the running state. We can call the sleep and wait methods, and because of these methods, the thread is going to be in a blocked state, and whenever the thread has done with its tasks, then it is going to be terminated. There are two ways to create a given thread. We can implement the runnable interface, so a given class may implement the runnable interface, and then we can instantiate a new thread and we have to define that given runnable interface. So this is why we can instantiate a thread example, which is a class, but this class implements the runnable interface. The runnable interface has the run method, which means that the given thread we have instantiated is going to do the operations we have defined within the run method. And as you can see, if we call object.start, this is how we can make sure that the thread is going to do the operations we have defined in the run method. Okay, another way is to use the thread class. So we can create a thread example class and it can extend the thread class. Again, we have to override the run method and we can instantiate the thread example like this. And because this thread example extends the thread, we can start it with the help of the start method. So there are two ways to create a thread: implementing the runnable interface or extending the thread class. In the coming lectures, we are going to talk about how to create a thread and how to use multi-threaded applications. Thanks for watching. In this lecture, we are going to take a look at the concrete implementation of threads. So first of all, I'm going to create a new class. So new class, for example, thread example. And this is what we have been talking about in a theoretical section, that there are two ways to create a thread. First of all, we can make sure that the given class implements the runnable interface. So we have to make sure that it implements the runnable, and because of this runnable interface, we have no other option but to override the run method, and whenever the thread is started, this is the method that's going to be called. So I'm going to print out that thread number plus thread current thread dot get id is running. So this is how we can get the ID associated with the current thread. Thread, current thread, get ID. Okay, so let's save it, and in the application.java, we can create a thread t1 new thread, and here we can instantiate a new thread example. So this thread is waiting for a runnable interface, as you can see, and because the thread example implements the runnable interface, this is why we can do something like this. And what do we have to do? This is what we have been talking about as well, that with the help of the start method, we are able to start the given thread. So it causes this thread to begin execution. The Java virtual machine calls the run method of this thread. So whenever we call this start method on the thread, then the thread example run method is going to be called. So if I save it and run it, then thread number 11 is running. This is the ID of the given thread. Okay, we are able to create a for loop. So integer number of threads is equals to 6, for example, and for integer I is equals to 0, I is less than the number of threads, I plus plus. We instantiate a thread, so thread t is equals to a new thread. We have to instantiate a new thread example, so like this, and we have to start the given thread. So what's going to happen? It's quite straightforward. We create 6 threads and we start them, which means that every single thread's run method is going to be executed. So if I save and run it, as you can see, thread with ID 11 is running, then thread with ID 16 is running, then 13, 14, 15, 12. So these are the IDs associated with the given threads. And as you can see, we have managed to create 6 threads because the number of threads is equals to 6. We are able to do it in another way. Instead of implementing the runnable interface, we can make sure that this thread example extends the thread class. And if this thread example is a thread, then we can use something like, instead of a thread, we can use the thread example directly. So a thread is equals to a new thread example, and as you can see, it is going to work just fine. So if I save it and run it, then it is going to be exactly the same. So there are 2 possible ways to create a thread in Java. A given class may extend the thread, or it may implement the runnable interface. As far as I am concerned, I am a huge fan of implementing the runnable interface. Why? Because a given class may implement several interfaces, but it can only extend a single class. So if this thread example extends the thread class, then this class is not able to extend any other class, which is not the best solution possible if we want to use inheritance. If we use implements the runnable interface, a given class may implement as many interfaces as we want, and it may extend another class as well. So this is why it is a bit better solution to use the runnable interface as far as I am concerned. Thanks for watching. In this lecture, we are going to demonstrate the difference between sequential execution and multi-threaded execution. So I'm going to create a runner1 class, and I'm going to create the runner2 class, and both of these classes will have the public void do operation method. And within this do operation method, I'm going to create a for loop integer I is 0, I is less than 10, I++, And here I'm going to print out that runner1 with integer value plus the I. So just for demonstration purposes, we are going to do some operations as far as the first runner is concerned, and we are going to do approximately the same as far as the second runner is concerned. Of course, it is the runner 2. So both of the runners will have a do operation method with a for loop, and it is going to print out runner2 with integer value and the I value. So as far as sequential execution is concerned, it means that the tasks are executed one after the other. So I'm going to instantiate runner1. Runner1 is a new runner1. I'm going to instantiate the runner2, which is a runner2. And then I'm going to call the do operation as far as the runner1 is concerned. And then I'm going to call the do operation as far as runner2 is concerned. And because we don't use multithreading, what's going to happen? Java is going to instantiate the first runner, then Java is going to instantiate the second runner, then Java is going to run the do operation method as far as runner1 is concerned, and after it is done, then Java is going to call the do operation method of the second runner. So if I save and run it, runner1 with integer value 0, 1, 2, 3, 4, 5, 6 up to 9. These are the operations as far as the first runner is concerned, and these are the operations as far as the second runner is concerned. So this is called sequential execution, where the tasks are executed one after the other. Is it possible to do both operations at the same time, so in a concurrent manner? Of course, this is what we have been talking about, that we have to implement the runnable interface, and the runnable interface has the run method. So instead of the do operation method, we are going to use the run method, and we do the same for the second runner. So it implements the runnable interface. Of course, we have to override the unimplemented run method. We create the for loop as usual, and I'm going to get rid of the do operation. So because runner2 implements the runnable interface and runner1 implements the runnable interface, this is why we can assign a distinct thread for runner1 and runner2. So what does it mean? That we are able to run both the operations in a concurrent manner. So if I use thread t1 is a new thread, and here we instantiate runner1, something like this, and we do approximately the same with t2 new thread with new runner2, then we are able to start the given thread with the help of the start method. This is what we have been talking about, that if we start the given thread, then Java is going to call the In the coming lectures, we are going to talk about synchronization. So first of all, what is synchronization? In a multi-threaded environment, multiple threads created from the same object share object variables, and this can lead to data inconsistency when the threads are reading or updating the given shared data. The reason for data inconsistency is because updating any field value is not an atomic process. It requires 3 steps. First, to read the current value, second, to do the necessary operations in order to get the updated value, and finally to assign the updated value to the field reference. So this is why if we have multiple threads manipulating the same data, there may be data inconsistencies. Let's consider that we have 2 threads, thread 1 and thread 2. If we want to increment the value of a given integer, then thread 1 is going to read the current value. In this case, the current value is 0. Then it is going to increase the value, so increment the value by 1. And then it is going to set the counter's new value to be 1. But because we have 2 threads, while these operations are happening, the second thread may get the value of the given counter, which is 0 at the beginning, because the first thread has to deal with these 3 steps in order to update the value. So it may happen that the second thread get the value of the counter before the first thread updates it. So the second thread is going to do the same, read current value, so with value 0, it increments the value by 1 and then set the counter's new value to 1. And this is why inconsistency may happen, because most of the operations are not atomic. The solution is that we have to make sure by some synchronization that only one thread can access the resource at a given time. Thread safety in Java is the process to make our program safe to use in multi-threaded environment. Synchronization is the easiest and most widely used tool for thread safety in Java. So as you can see, in this case we have 2 threads, and somehow we have to make sure that the given data is synchronized. Let's talk about the Java monitor. A monitor is a mechanism to control concurrent access to an object. This prevents multiple threads accessing the monitored or the synchronized section at the same time. One thread will start and the monitor will prevent the other thread from accessing the region before the previous one finishes, which means that only one thread can hold the lock on the monitor at a given time. Okay, so we have several threads. So threads enter the acquire lock or the so-called entry set. Then the lock is acquired by the thread. So in this case, the green thread is the active thread. Then the thread goes to the waiting state if you call the wait method on the object, otherwise it releases the lock and exits. If you call notify or notify all, it wakes up the thread or all the threads. We are going to talk a lot about these methods and it's going to be clear. And now the thread is available to acquire the lock. After completion of the task, thread releases the lock and exits the monitor state. So basically the monitor is going to make sure that processes are going to be synchronized. So no 2 threads can update the same variable at the same time. Otherwise, we would end up with data inconsistency. And this is why we have to use the synchronized keyword. Synchronized in Java is an implementation of the monitor concept, and Java Virtual Machine guarantees that synchronized code will be executed by only one thread at a given time. Java synchronized keyword is used to create this, and internally it uses locks on the object or the class to make sure that only one thread is executing the synchronized code at a given time. There are different ways in Java to create synchronized code. With the help of synchronized method, we have to use the synchronized keyword void method name, and it means that the method is synchronized. So no 2 threads can manipulate the method at the same time. We can use static synchronization when the method is static, or we can use synchronized block. So as you can see, synchronized without a method name, it is called a synchronized block. So with the help of the synchronized keyword, we can make sure that the operations are going to be thread safe. So there's not going to be any data inconsistency. In the next lecture, we are going to talk a lot about the synchronized keyword, about the wait method, notify method, and all the synchronization related issues. Thanks for watching. In this lecture, we are going to talk about synchronization. So let's consider a situation that we have a private integer counter. We set the value to be 0 at the beginning. We make it static because we would like to manipulate this integer counter variable from a static method. And we are going to have a public static void increment method that's going to increment the value of the counter itself. Sorry for that, we have to use this. Okay, and here in the main method, we are going to use two threads. So thread T1 is a new thread, and we are going to use an anonymous inner class. So we instantiate the interface, and here we have to define the run method as usual. So something like this. Okay, and here I'm going to create a for loop integer I is 0, I is less than 1000 and I++, and we are going to call the increment method. So this thread, this T1, is going to call the increment method 1000 times. And we are going to do the same with another thread, so the T2 is going to make 1000 iterations as well, and it is going to call the increment method as well. So we are going to start T1, we are going to start T2, and we are wait for them to finish. So T2.join. Okay, of course we have to use a try-catch block, so surround with try-catch. I'm going to use it like this, and finally we are going to print out the value of the counter. So counter is equals to the counter. You may pose the question that why is it crucial to call the join method, because otherwise Java is going to start the first thread, the second thread, and immediately it is going to print out the value of the counter before the threads are finishing with their operations. So this is why it is crucial that we would like to wait for the threads to finish with their incrementation processes. Okay, so if I run the application, then the result is going to be rather inconsistent. The first thread increments the value of the counter 1000 times, the second thread increments the counter 1000 times, so we should get 2000, and as you can see, we don't get 2000 at all. Okay, sometimes we get, but most of the cases it is not working fine. And this is exactly what we have been talking about in the theoretical section, that incrementation is not an atomic process. It requires 3 steps. First of all, the first thread is going to read the counter variable, then it is going to increment the value, and finally it is going to update the value of the counter. So there are 3 main steps, but within these 3 steps, the second thread may get the value of the counter before the first thread updated. So this is why there may be inconsistencies. So what could be the solution? We should use synchronization. So we should make sure that while a given thread is manipulating the counter, the other threads have to wait for it to finish before starting to manipulate the given variable. So this is exactly why we have to use synchronized keyword. So if we use public synchronized static void increment, what's going to happen? That whenever the first thread calls the increment, then the second thread has to wait for the thread to finish with this method, and vice versa. If the second thread is calling the increment, then the first thread has to wait for the second thread to finish with this operation. So if I save and run it, as you can see, with the help of the synchronized keyword, we are able to solve the problem, and it's going to be consistent. So the value is going to be 2000 because the first thread increments the value 1000 times and the second thread increments the value for 1000 times. What's crucial that it is called static synchronization because it is a static method. So in short, if you synchronize on a static method, you will synchronize on the class, so on the object, and not on an instance. That means while execution of a static method, the whole class is blocked. So other static synchronized methods are also blocked if they are also synchronized. So what does it mean exactly? That if I have a totally independent public static synchronized method, for example, do operation, and it is going to I'm not sure, solve, for example, solving a differential equation, which means that it is totally independent of this operation, then because we use the synchronized on a static method, then if a given thread is calling the increment method, then other threads have to wait in order to run the do operation method, although they are totally independent of each other. Because synchronized keyword has something to do with the class. If a given thread enters a synchronized static method, then Java is going to notify all the other threads that, okay, let's wait for that given thread to finish. No matter that we would like to call a totally independent method, this is how static synchronization works. So this is how we can use the synchronized keyword. Thanks for watching. In the previous lecture, we have been talking about that if we use synchronized methods, it is not the best solution possible, because if a given thread is entering a synchronized method, then all the threads must wait in order to execute a different synchronized method, because they are looking on the class itself. So this is why it is not the best solution possible, because in this case, these methods are totally independent of each other. So we should make sure that a given thread may manipulate the increment method and a different thread may call the do operation method without any issue, because they are independent of each other. And this is why synchronized blocks came to be. Okay, so I'm going to create a class just for demonstration purposes, show numbers class, and within the show number class we have a public void print numbers method with an integer n. Here we print out that numbers starting with, and we print out the value of n, and we do a simple for loop. Integer I is equals to 1, I is less than or equals to 5, I++, and here we print out, for example, I times n, and then we sleep for 400 milliseconds, for example. Of course, we have to surround with try-catch block, so I'm going to use a try-catch block with an interrupted exception, as you can see. So this show numbers class has just a single method, the print numbers, and it is going to print the numbers and then sleep for 400 milliseconds. And it is going to print the number times I, and it is going to sleep for 400 milliseconds. Then I'm going to create two classes. The runner1 that extends a thread, because we would like to assign a distinct thread to that given class. We have a show numbers instance like this, and in the constructor it gets a show number. Okay, and we set this dot show numbers is equals to show numbers. We override the run method, and here we are going to call the show numbers dot print numbers, where the n value is equals to 1. So what's going to happen? The runner1 is going to print the numbers 1, 2, 3, 4, 5, and we are going to do another runner2 that's going to be very, very similar to the runner1, but instead of the n value 1, we are going to use the n value 10. So what does it mean? It is going to print out 10, 20, 30, 40, and 50. So this is the main difference between runner1 and runner2. And if we do not use any synchronization, I guess it's pretty straightforward what's going to happen. But anyways, I'm going to instantiate them as a thread. So T1 is a new runner1. We have the thread T2 is a new runner2. Of course, we have to provide the show numbers class. So let's instantiate the show numbers class like this. And we have to define as the argument for the runner1 and for the runner2. And let's start the given threads. So T1 and T2 dot start. Because we don't use any synchronization, it is going to be the result that 10, 1, 20, 2, 3, 30, 40, 4, 50, and 5. The first solution we can use is what we have discussed in the previous lecture, that we can make this method synchronized, but it is not the best solution possible because synchronized methods are looking on the class itself, and this is why it is a bit better solution to use a synchronized block. Synchronized block is synchronized and we can define the so-called mutex. In this case we define this. So we are going to look on the class itself, but we are not going to make the method synchronized. We just create a synchronized block and we are going to do the operations. Oh, sorry for that, by the way, I would like to do it here. So the for loop is going to be within the synchronized block as well. So I would like to make sure that the synchronized block will contain the for loop and the thread.sleep operations. And why is it good? Because multiple threads can enter the given print numbers method, but they have to wait for each other to finish because it is a so-called synchronized block. So if we use something like this, I save and run it, then first of all the first thread is going to be executed and then the second thread is going to be executed, and as you can see the first thread has already started to run, but the second thread is able to enter the given method because we printed out numbers starting with value 10. Sorry for that, a typo. So the second thread prints out that numbers starting with 10, but the second thread has to wait for the first thread to finish. So what's going to happen? The first thread is going to finish with the for loop and prints out 2, 3, 4, and 5. And after the first thread finished with the synchronized block, then the second thread is able to run the synchronized block on its own. So that's why 10, 20, 30, 40, and 50 are going to be printed out. So the conclusion is synchronized block can be used to perform synchronization on any specific resource of the method. Suppose you have 1,000 lines of code in your method, but you just want to synchronize 5 lines of code. In this case, you can use a synchronized block as we have seen in this given example. So as far as synchronized block is concerned, the lock is acquired on critical block of the code only. So in this case, we don't lock on the method, we just lock on the block itself. So it is the preferred way of synchronization and performance will be better as compared to synchronized methods. Of course, we can use synchronized method with the help of the synchronized keyword as we have discussed in the previous lecture. So we can use something like this and then there is no need for the synchronized block itself. But it is not the best solution possible because the lock is acquired on the whole method. So performance will be less as compared to synchronized blocks. So the best solution is to use synchronized blocks like this. Thanks for watching. In this lecture, we are going to take a look at a concrete example as far as the wait and notify methods are concerned. With the help of wait and notify all methods, we are able to communicate between threads. So this is what we have been talking about, that with the help of the wait method, the given thread is going to be in the waiting state, which means that it is waiting for other threads to call the notify or notify all method. So if we have a given thread and we call the wait method, it is going to give the log back to the Java virtual machine that's going to assign that to a different thread, which means that the thread will be in the waiting state and it is going to wait until a different thread calls the notify or the notify all method. So basically with the help of these methods, we are able to communicate between threads. So let's take a look at a concrete example. We have a class, for example, processor, and in this class we'll have 2 synchronized methods. Public synchronized void, for example, waiting method. Okay, it is one of the methods, and we will have the second method, the so-called synchronized void sleeping method. So it is going to be the sleeping method, and as you can see, both of them are synchronized methods. What does it mean? That if a given thread calls the sleeping method, then all other threads have to wait to call the sleeping method or the waiting method as well, and vice versa. So because both of these methods are synchronized, it is not possible that one thread runs the sleeping method and one thread runs the waiting method in a concurrent manner, because they are synchronized on the same class, which is the processor. So in this case, we are going to get the thread T is equals to the thread.currentThread. This is how we can get the current thread. We print out that t.getName, this is how we can get the name of the thread, is releasing the lock and going to wait. Okay, so we call the wait method. Of course, we have to surround it with try catch because there's an interrupted exception. So this wait method is going to cause the current thread to wait until another thread invokes the notify or the notify all methods. Okay, so this waiting method is going to call the wait method on the given thread. And this is where the thread continues when notify is called. So this is why we print out that the t.getName got the object log back and continue its execution. So this waiting method is going to get the current thread and it is going to wait, and then after it is notified, so basically it is woken up, then we print out that the thread got the object log back and continue its execution. As far as the sleeping method is concerned, first we get the thread t thread current thread. We sleep for 3 seconds, so 3000 milliseconds. Of course, we have to surround with try catch because there may be an interrupted exception. And then we call notify. This notify method is going to notify the waiting thread that okay, you can continue with your execution, and this is when this thread is going to execute with its execution. So after the notify, we print out that a thread which is waiting for lock of this object is notified by the given thread. So this is the waiting method, this is the sleeping method, and the crucial point is that they are synchronized, which means that they are logged on the same class, which is the processor. So this is why it is not possible that the first thread is running this method and the second thread is running this method, because they are synchronized on the same class. Okay, so first of all, I'm going to instantiate a new processor. So processor is a new processor. Then I'm going to create a new thread. So thread T1 is a new thread, and I use an anonymous inner class. So here we can define what's going to happen. We call the processor.waiting method, and I'm going to create another thread for the sleeping method. So T2 is going to run the sleeping method. Okay, so after that I'm going to start the first thread and I'm going to start the second thread as well. So if I run the application, what's going to happen? As you can see, this is when the threads are sleeping for 3000 milliseconds. And what has happened? First of all, the waiting method is called. So first of all, we are going to sleep for 3000 milliseconds. And then we called notify. Notify is going to allow for the second thread to run the waiting method. So this is why the t.getName, which is thread 0, is releasing the lock and going to wait, as you can see. And if we call the wait method, again, this thread is going to run. So we print out that a thread which is waiting for lock of this object is notified by thread 1. And after that, the thread 0 got the object lock back and continue its execution. So this is how we can communicate between threads, because one of the threads is associated with the waiting method and the second thread is associated with the sleeping method. So whenever we call the notify, Java is going to notify the other thread that okay, you can continue with your execution. If we call the wait method, then again this thread is going to wait and the other thread continue its execution here, and after this thread has finished, of course we return here, and this is what's going to be printed out. So this is how we can communicate between threads with the help of wait and notify. Thanks for watching. In this chapter, we are going to talk about design patterns. So first of all, what is a design pattern? Design patterns are established general solutions to commonly occurring software development related problems, represent the best practices used by experienced object-oriented software engineers. So design patterns are language-independent strategies for solving common object-oriented design problems. A design pattern represents an idea, not a particular implementation. So in order to become a good software developer, you should know at least some popular solutions, design patterns to the coding problems. So learning these patterns helps unexperienced developers to learn software design in an easy and faster way. So basically the purpose of a design pattern is to leverage the wealth of knowledge of developers who have come before you in order to solve old problems that you may encounter easily. It also gives developers a common vocabulary in which they can discuss common problems and solutions. So for example, if you say that you implemented a singleton pattern, then most developers will understand the structure of your code without having to get into the low-level details. Okay, so there are 23 design patterns which can be classified in 3 categories: creational design patterns, structural design patterns, and behavioral design patterns. As far as creational design patterns are concerned, these design patterns provide a way to create objects while hiding the creation logic. So instead of instantiating objects directly, creational design patterns hide object creation. This feature gives the application more flexibility in deciding which objects need to be created for a given use case. As far as structural design patterns are concerned, these patterns are concerned with how classes and objects can be composed to form larger structures. So for example, the concept of inheritance is used to compose interfaces and define ways to compose objects to obtain new functionalities. And as far as behavioral design patterns are concerned, these patterns are specifically concerned with communication between objects. So these patterns are concerned with providing solutions regarding object creation, how they communicate, how these classes are depending on each other, and how to provide flexibility as far as testing is concerned. So in the coming lectures, we are going to consider the most important design patterns such as singleton pattern, immutable object pattern, builder pattern, and the factory pattern. Thanks for watching. In this lecture, we are going to talk about the so-called singleton pattern. So singleton pattern restricts the instantiation of a given class and ensures that only one instance of the class exists in the Java virtual machine. So the singleton class must provide a global access point to get the instance of the class, and singleton pattern is used for logging, drivers objects, caching, and thread pool. So there are several applications of the singleton pattern. Let's create a class just for demonstration purposes. The name is going to be singleton class, and in the public class singleton class we are going to have a private, static, volatile instance of that given class. So singleton class, and here we instantiate the given class at compile time. So this is called early or eager instantiation. So here at the beginning we instantiate the singleton class as the instance variable. If a given constructor of a given class is private, it means that we are not able to instantiate the class directly. Of course, we have to use something like this. And then we have a method public static singleton class get instance, and because we have already instantiated the given singleton class, we can return with the singleton class. And finally, we are going to have a method public void show, for example, and I'm just going to print out this is the show method of the singleton class. Okay, so as you can see, with the help of a private static volatile singleton class, we are able to construct the singleton pattern. We are not able to instantiate that given class because it has a private constructor, and we make sure that there is just a single instance of that given class that can be returned with the help of the getInstance method. So whenever we try to instantiate a singleton class, let's try to instantiate it, so a new singleton class, it is not going to work just fine because the constructor singleton class is not visible because it is private. So far it is good because we are not able to instantiate a given singleton class, so this is how we can make sure that we restrict the instantiation of a given class. So what can we do? We can use something like singleton class.getInstance, and with the help of the getInstance method we can get an instance of the singleton class, of course, and we are able to call the show method without any problem. So this is how we can make sure that first of all it is working fine, and this is how we can make sure that only a single instance exists of the singleton class. Of course, because multiple threads may manipulate the same object, somehow we have to make sure that it is thread safe. So first of all, the early or the eager instantiation is not the best solution possible because maybe we don't need that given class, so there is no need to instantiate it at the beginning. We can use something like at the beginning it is a null, and we can check here that if the singleton class, of course with lowercase s, is null, then we are going to instantiate it. So singleton class is a new singleton class, and finally we return with the singleton class. So if it is a null, then we instantiate it whenever we call the getInstance method. So this is called lazy instantiation. We don't instantiate it at compile time, we instantiate it at runtime whenever someone calls the getInstance method. And of course we should make sure that it is thread safe, so somehow we should construct a synchronized block. So if the singleton class is a null, then we can do something like this. We have the singleton class.class, so we lock on the class itself, and here we can instantiate the new class if necessary, and otherwise we return with singleton class. Of course the best solution is to check again whether the if singleton class is equals to a null, because threads are going to wait here in order to call this synchronized method, and maybe a given thread has already instantiated the singleton class, so the best practice is to check again whether the given singleton class is a null or not. And this is how we can make sure that the singleton class is going to be thread safe. So if I save it and run it, as you can see, again, it is working fine. The crucial difference is that now it is the lazy instantiation, so we just instantiate the singleton class if necessary. So if someone calls the getInstance method, and it is thread safe. So that's no problem if multiple threads manipulate the singleton class at the same time. Thanks for watching. In this lecture, we are going to talk about the immutable object pattern. So sometimes you want to create a simple object that can be shared across multiple classes, but for security reasons, we don't want the value to be modified. This is called the immutable object pattern, so we would like to make sure that the given object's values are not going to be changed. One solution is that we could copy the object before sending it to another method, but this creates a large overhead that duplicates the object every time it is paused. So this is not the best solution possible. We are going to take a look at a concrete implementation, and it's going to be clear what's crucial that we can achieve this pattern via encapsulation, and this pattern is inherently thread safe because immutable objects never change. So there's not going to be different threads that tries to modify the values within the object, which means that it is inherently thread safe. So let's create a new class, a person class. The person will have several instance variables: private string name, private integer age, and private list of persons as friends. In the constructor, we define the string name, integer age, and the list of friends. So it is a list of persons, that the friends list. Okay, and we are going to use this dot name is equals to the name, this dot age is equals to the age, and this dot friends is equals to the friends. Of course, we have to import java.util.list. Okay, I'm going to generate the getters. So let's source and generate getters and setters. And of course, we don't want to generate setters because with the help of the set methods, the user would be able to modify the values. And this is the aim. We want to make sure that the values are not going to be changed. Hence, the object will be immutable. So we are going to generate just getters for the age, for friends, and for the name. Okay, and you may come to the conclusion that it is approximately fine. What we can do is that we may set the variables final, and with the help of the final keyword we can make sure that the values are not going to be changed. But the problem is that the list of friends is a reference, so the reference is not going to be changed because of the final keyword, but the content of the list may change. So if I do something like this, that I create a list of person, friends is a new array list, okay, and then we add, in this case, sorry for that, I'm going to modify that the list is not going to store person just for demonstration purposes, it's going to store strings, so the name of the given friend. So let's do something like this, okay, and here we add, for example, Peter, and I'm going to add some other friends, for example, Adam and Joe. Then I'm going to instantiate a given person, so person is a new person. What do we have to define? We have to define the name, for example, Kevin. We have to define the age, for example, 30, and we have to define the friends list. So friends are going to be the input, as you can see. In this lecture, we are going to talk about the so-called builder pattern. So the main problem is that as our data objects grow in size, the constructor may grow to contain many attributes, and dealing with several attributes is not that convenient, and basically this is why builder pattern came to be. So users who reference our object would also be required to update their constructor calls each time that the object was modified, resulting in a class that would be difficult to use and maintain. And this is why the builder pattern solved this problem, which means that we can use method chaining instead of using several parameters. The primary advantage of builder pattern is that over time this approach leads to far more maintainable code. If a new optional field is added to the person class, then our code that creates object using the person builder class will not need to be changed. While on the other hand, if we use constructors, of course we have to update the parameters and we have to update the code itself. If we use builder pattern, of course we have to add some additional code, but we don't need to modify existing code, and this is the crucial part of software engineering. So I'm going to create a new car class, and I'm going to create several field variables: private string brand, then we have the private string name of the car, then we have the private string color, we have the private integer number of doors, we have private integer horsepower, and of course they could be lots of parameters as far as the car class is concerned. So let's generate the constructor. So right click and source generate constructor using fields. I would like to use all the field variables: brand, name, color, number of doors, and horsepower. So this is how we can generate the constructor, and as you can see, this constructor has too many parameters, which means that it is not that convenient to use this constructor because you have to track that what parameter refers to what variable. So I'm going to generate the getters and setters as well for brand, color, horsepower, name, and number of doors. And I'm going to right click source generate the toString method with these parameters. So if I click OK, then as you can see, the toString method is going to print out the car with the brand, name, color, number of doors, horsepower parameters. Okay, so just for demonstration purposes, of course we can instantiate a new car without any issue. So I would like to create a new car, Ford for example. Focus, the color is going to be black, the number of doors is going to be 5, and the horsepower is going to be 125. So if we print out the object itself, then the toString method is going to be called. So this is why it is crucial to override the toString method if you want to print out the given object. And of course we get the result, which is Ford Focus with color black, 5 doors, and 125 horsepower. So this is the old way, but because there are several parameters in the constructor, a bit better solution is to use builder pattern. And the builder pattern uses a private constructor, so I'm going to use a private constructor, which means that we are not able to instantiate a car class. Then we are going to have the getters, so I'm going to get rid of the set methods. So set color, set number of doors, and set horsepower. I'm going to get rid of these methods. And then we have to create an inner static class. So we have a public static class car builder. And this car builder is going to have the same variable as we have defined here. So we would like to build these variables, and within the car builder we are going to define the setters. So as you can see, outside the car builder there are get methods, and we are going to define the set methods inside the static class car builder. So I'm going to use public, and we return with the car builder set name. We get a string name, we set the name, so this name is equals to name, and then we return with this. So as you can see, this refers to the car builder class and we return with the car builder itself. We do the exact same operations for the brand. So we set the brand, going to use brand and brand. We do the same for the color. So set color, this is the color itself. Okay, then I'm going to use the same for the horsepower. So it is an integer, so integer and horsepower like this. Set, sorry for that, it is the number of doors of course, but this is what we have to do with the horsepower as well. So we use horsepower like this. I changed the name of the method, set horsepower, and with the help of these setters, we have managed to deal with all the field variables. Then we are going to create the most important method as far as builder pattern is concerned, a public car, and the method name is going to be build. And this is where we instantiate a new car. So a car is a new car. Car.brand is equals to the this.brand. The car.name is equals to this.name. The car.color is equals to this.color. The car.number of doors is equals to this.number of doors. And the car.horsepower is equals to this.horsepower. Okay, so this is where we set the given parameters for the newly instantiated car object. And finally, we are going to return with the car itself. So this is the builder pattern itself. We have private variables. We have a private car constructor, so it is going to prevent users from instantiating the car class. We have an inner static class, the car builder, where we build the given parameters one by one, and the build method that's going to set the parameters, that's going to instantiate a new car object, and that's going to return with the car object itself. And outside the scope of the static method that belongs to the car class, basically, there are going to be getters exclusively. So if we save it, then we can use something like this, that instead of instantiating the car because the constructor is private, of course we are not able to instantiate it. But we can use something like new car and car builder, and we can set the parameters one by one. The brand is going to be Ford. Then we can use method chaining in order to set the name. It is going to be Fiesta. Then we set the color, it's going to be gray. We set the number of doors to be, for example, just 3, and we set the horsepower to be 80. Okay, and finally, what's extremely crucial, that we have to build the given car. So as you can see, this is a typical builder pattern. We instantiate a new car, that car builder, we set the parameters, and finally we call the build method that's going to use these parameters in order to instantiate a new car. And if we save it and run it, of course it is going to work fine. What's extremely powerful, that we don't have to specify a given parameter. For example, if we don't want to specify the color, then we just have to get rid of it and we don't have to specify it, and the algorithm is going to work without any issue. Of course the color is going to be a null. Or for example, we don't know the number of doors, then we don't specify the number of doors, the algorithm is going to be the same. So it is quite flexible. Of course the initial value is going to be 0, but anyways, this is how we can use builder pattern, and it is an extremely powerful and flexible way of creating objects. Thanks for watching. In this lecture, we are going to talk about the so-called factory pattern. So factory pattern is one of the most used design patterns in Java. It is about using a factory class in order to produce instances of objects based on a set of input parameters. It is very similar to the builder pattern, although it is focused on supporting class polymorphism. In factory pattern, we create object without exposing the creation logic to the client and refer to newly created objects using a common interface. So what's crucial that as far as the implementation is concerned, factory pattern relies heavily on polymorphism. So for example, I'm going to create an interface animal. This animal interface has a single public void run method, and I'm going to create several other classes. For example, a tiger. The tiger implements the animal interface, of course, and we have to override the unimplemented run method that's going to say that tiger is running. So let's do the same for a new class, for example, an elephant. The elephant is going to implement the animal interface as well. Instead of the tiger, the elephant is running, and I'm going to create the same for a turtle. The turtle is an animal again, so instead of tiger it is the turtle, but as you can see it is polymorphism. We have an animal interface, and because elephant is an animal, that's why it implements the animal interface. The tiger is an animal again, so it implements the animal interface, and the turtle is an animal, so it implements the animal interface. And as far as animal factory class is concerned, we can create animal factory that's going to handle the creation of these classes. So for example, I have a public animal get animal method with string species, and here we can say that if the species equals to tiger, then we return with a new tiger instance. Else if the species is equals to elephant, then we return with a new elephant object. And else if the First of all, congratulations on completing this course. I think we have learned a lot about Java programming together, and I hope that your Java knowledge has greatly increased throughout the course. Finally, let me point out some good advices. First of all, try to use what you learned during the course in complex ways. Always look forward to understand the interactions of the Java programming elements and code as much as you can, because practice brings the confident knowledge. In programming, you can always go deeper in every topic, so if you want to expand your knowledge on a specific subject, you should continue with a book or a course focusing on that concrete aspect. So thanks again for choosing this course, and if you like Java programming step by step from A to Z, then please consider checking out some of my other courses. If you are interested in collections and generics, then there is a distinct course on this topic. If you are into multithreading and parallel computing, then consider taking this course. If you are interested in software engineering, then Java Enterprise Edition and Java Standard Edition are going to be the best match for you. If you are interested in algorithms and data structures, then I suggest checking out these courses. Finally, if you are interested in artificial intelligence and machine learning, then I suggest considering these courses. So these courses can be the next steps I would recommend. Thanks for watching.